So, hello students, welcome to Vedantu NEET English. This is Baswarat sir, your biology master teacher. Students, quickly let me know in the chat right now if I am audible and visible to each and every one of you students. Welcome to this amazing channel, your own channel, Vedantu NEET English students. This is Baswarat sir, right? Now again students, first of all, good morning to all of you, right? Good morning, and who can watch this lecture? Before I start anything, let me give a small clarity on what we'll be doing in today's lecture. A small clarity, okay? Students, we are always aware that all of us are aware that molecular basis is a very important chapter, and many students fail to understand that chapter, molecular basis, because you don't learn biomolecules very well. Because if you are aware that biomolecules and molecular basis, both of these chapters are interconnected. That is, whatever you learn in this chapter will be used in the next chapter also, and the molecular basis will be taught by your own Gopika ma'am. Okay, students. Now, students, if you have zero knowledge about these two chapters, absolutely no knowledge at all, you can watch this lecture. If you heard a few points here and there in offline, in coaching center, if you heard about this chapter, even amazing. Because by the end of today's entire long marathon, you will have the ultimate confidence that you can solve any single question in the world from these chapters. Okay, students. So with that being said, can we start today's class? Can I get some fire emoji in the chat to start with the class, students? To start with the class. And also all of you students. And also, right, smash your like button, because if you smash your like button, we'll always be happy, and YouTube will recommend this video to every single student who needs a proper guidance in their journey. Okay, students, can we start, all of you? Yes, this is going to be a marathon, all of you. This is going to be a complete marathon. Yes. So, students, can we start, all of you? Okay. Now, this image right here, students. This right here is a factory. Let's say this is a futuristic factory. In this factory, there are multiple equipments which are working. But students, in this entire factory, right, someone has to work. Similarly, in your body, take your entire body as a large factory. In your body also, there are certain small workers who are always ignored. Small workers. Let me give you one more example. Imagine this is your entire body right here, a set of Legos. And when we join all of these Legos, we might get up some amazing structures, right? Similarly, students, in our body, there are certain types of biomolecules which work behind the scene without even you realizing. For example, your heart beating right now 1,000 times per day, your stomach digesting all the food, your brain processing all the information. All of this is possible, students. All of this is possible because of none other than the biomolecules. Without biomolecules, there is no life. Can all of you agree on that, students? If you agree, just say yes sir in the chat. Yes sir, we agree that without biomolecules, the entire life existence is not possible at all. Not possible at all. Okay. Now, students, when we talk about biomolecules, right? When we talk about biomolecules, we generally say, students, right? All organisms usually have same biomolecules, same type of biomolecules. Okay, there are certain common biomolecules. All the way from the bacteria to a large blue whale or a fungus or a plant, there are certain biomolecules which are found in every single organism. Can anyone tell me, students? Can anyone tell me which are these following biomolecules which are found in humans? Anyone? Okay. You will tell me, sir, biomolecules are lipids. We can have lipids, carbohydrates, proteins, right? Glycerol, fatty acids. All of these are different carbohydrates. But, what are these carbohydrates made up of? Can anyone in the chat tell me, any smart pants in the chat tell me, what are these biomolecules made up of? All of the following biomolecules, students, all of these following biomolecules, they are made up of nothing but carbon, nitrogen, and oxygen. All of you agree with students? All of you agree with me, students? They are made up of nothing but carbon, nitrogen, oxygen, and hydrogen. These are the following biomolecules which are found in almost all living organisms. Okay. Now, I want one volunteer from the chat. I want one volunteer. Okay. Let's take students, Levi. Let's take Levi. Okay. Now let's take Levi for example. Now this is our Earth. This is our Earth right here. On this our Earth, right here is Levi's grandfather's property. Okay. Here we have Levi's grandfather properties here. Grandfather's property. Okay. So we will take his grandfather's property. We'll take. Okay. So we will take their grandfather's property. Okay. Don't tell your grandfather. Okay. Now students, this is your grandfather's property right here. Now students, on this Earth, the outermost layer is called as the Earth's crust. Earth's crust, right? On this top of the Earth crust, students, if I use a magnification glass, and then if I notice what elements are present on Earth crust, I will find the same elements. On Earth crust also, I will find hydrogen, oxygen, and carbon. The same elements are found in your living organisms and also found in your non-living organisms. Then what is the difference? What could be the possible difference that, see, same thing is present in your grandfather's property. Same thing is present in me also. Then what is the difference? The difference is very, very simple, students. The difference is called as relative abundance. Fancy term, no fancy term. Let me make it easy for you. The meaning of relative abundance is that the concentration of these elements, the concentration, right? The concentration is comparatively less here. At the same time, concentration of these elements is more. That is, concentration of these elements is more in the case of your living organisms. More concentration, less concentration, and that is the basic difference, students. Basic difference. Okay? Okay, students? Clear all of you? Now, when I talk about biomolecules, students, bio means living. And molecules, all of you know, they are the molecules. So living molecules. Now let me ask all of you one more simple question. Where are these living molecules found? In our body, where are they found? Are they found in our brain? Are they found in my hand? Are they found in my eyes, ear, nose, stomach, heart? Where are they found, students? Everywhere. For example, students, let me take one normal cell here. Let me take a normal cell, right? In this normal cell, students, inside the living cell, I find all of these biomolecules. So all the biomolecules can be found inside the living cell. For example, think of living cell as a swimming pool, large swimming pool. In this large swimming pool, I can find all the biomolecules inside here. In the cell pool, I can find all the biomolecules on the inside. Now students, that is the basic form of biomolecules which we learned. Now till here, anyone, any doubt, or the class is going as butter? Anyone, students, anyone, any doubt here? See, all of us know biomolecules are living molecules. All organisms usually have the same molecules, the carbon, nitrogen, oxygen, hydrogen. Concentration is more in the living organisms. It is less in the case of Earth's crust. They are found inside a cell. All the biomolecules are found inside a cell. Clear, all of you? Clear? No. Let's go to the next concept now. Next concept. Okay. Now, these biomolecules, right? These biomolecules are generally of two types. They are generally of two types. Micromolecules, macromolecules. See, all of you tell me in the chat. Micro means small or big? Micro means small. Macro means bigger. So based on that, right, if I tell you, you should not believe me. If I tell you there is something called as micromolecule, macromolecule, you should not believe me. Just like how you should not believe anything which Instagram says. You all of you get these ads, right, in Instagram, right? Best pillow in the world. Don't believe anyone. Unless you have a scientific proof, do not believe anyone. Okay. So even if I tell you something, you should not believe unless there is a proof. So now I will give you a proof of micro and macro and how are they classified. Ready, all of you? Ready, students? No. Now I want everyone to become a scientist right now. All of you. Ready, students? Now we will do something called as experimental proof. Ready, all of you? Experimental proof will do. Experimental proof. Now, for this experimental proof, students, what should we sacrifice? All of you tell me in the chat. Should I sacrifice a leaf? For this experimental proof, should I sacrifice a leaf or a liver piece? Or a rat liver? Tell me, students. Leaf or rat liver? This is a leaf. Leaf, or you can take a liver piece. Okay, from a rat. Who should we do RIP, students? I think we'll put RIP for this only. We'll do RIP for this only. Okay, we'll put RIP here only, students. RIP for this. We will take a liver piece. Okay, now we will take a liver piece right here. We'll take a liver piece. Let's say leaf is everywhere. Okay, liver is very fancy now. You take this liver piece, and students, how many of you make chutney in the house? You make chutney in a mixer. But here, students, how many of you make chutney in that? You have in your house, you have that motor, round motor, chutney making. We have to grind everything. I don't know if you have it in your house. In my house, it is there. Okay, old school, right? So that is called as a mortar and pestle. It's called as mortar and pestle. Okay, mortar and pestle. So this is your right now. Here is this is your mortar, and this is pestle. Mortar and pestle. Now to this mortar and pestle, I am adding the liver piece. Let's say I add the liver piece here. Okay. Now, students, you tell me, is chutney making process possible without a solvent? Can I make the chutney without water in your house? No. If you're making coconut chutney, you have to add water to it. Water should be added. Okay. So here we cannot add water. We use one more solvent called as trichloroacetic acid. Okay. So here we are adding a solvent here, students. We are adding a solvent here. Solvent is added. Okay. Trichloroacetic acid is added. That is Cl3CCOH. Okay. Trichloroacetic acid is added here. Okay. Trichloroacetic acid added. Now, once trichloroacetic is added, nicely I'm making chutney now. Nicely grinding. Now, once I make the chutney, what do I get? At the end of chutney, we get one that's liquid, semi-solid substance we get, right? That is called as slurry here. So we end up getting a semi-solid substance called as slurry. Let's make the slurry here. Okay, this is called as slurry. We get the slurry here. Slurry here. Till here, students. Any doubt till here, students? Any doubt till here? Done? Done. I think we'll try to make more space here, students. Try to make more space here. Trichloroacetic acid will add here. Trichloroacetic acid. Okay. Okay. Now, students, next step. Ready, all of you? Ready for next step? For that, I need a dividing here. Okay. Next step, we'll start now. Okay. Now, next thing is going to be, you need to take this slurry and you can add it in a beaker or you can add it in a conical flask. This time, we will take a conical flask, students. This time, we will take a conical flask this time. Okay. Okay. Here we have a conical flask. In this conical flask, let's take here on the top, I will add a mesh here. On top, students, I will add a mesh here. Mesh here. Okay. Like a small filter, I will add. The filter is called as muslin cloth here, cheesecloth. Muslin cloth or a cheesecloth I'm adding here. Okay. Now, on top of this, I will add the entire slurry. I will add the slurry on top. This here is the slurry. Slurry on top. Now, what happens? Understand, students. Now, what happens here is that, right? What is slurry? Slurry is that liquid part which you get. Okay. Now, what happens is, students, understand, very simple. Because of gravity, when you keep a filter there on top of filter, some amount of slurry will come down. All of you can agree with me. What happens is, eventually, some amount of slurry will start to drip down. Some amount of slurry will start to drip down here. Will start to drip down. Okay. So at the bottom also we have some slurry at the bottom here. Some slurry at the bottom. Okay. Some slurry at the bottom, some slurry at the top. Okay, students. Now understand, all of you, very simple concept here. Okay. Now, whatever is present at the bottom, all of you listen to me very carefully. Now, this is where things get interesting. Okay. Whatever is present at the bottom. Okay. I will call this thing as filtrate. I will call it as filtrate. I will call it filtrate, students. Filtrate. Okay, filtrate. Students, clear? Now, whatever is present on the top here, remaining top part, this part is called as retentate. It's called as retentate. Okay, students, because this one is able to come down. It is getting filtered. It is able to filter down. I will call that as filtrate. What is present on the top is called as retentate. Retentate. Okay. Now understand, students. This substance here on the bottom, it is able to filter down because it was soluble in acid. Yes or no? It was soluble in acid. So can I also call it as acid soluble fraction? Yes, sir. I will call it acid soluble fraction. Now what about present on the top? It is not soluble in acid, so it is present on the top. So I will call this as acid insoluble fraction. So acid insoluble fraction. Now all of you tell me, students, if the size of this muslin cloth or cheesecloth is very fine, very tiny, okay, now you tell me, students, will the small particles be able to come down or large particles may be able to come down? All of you know a mesh. In that every single time there is a mesh, only the small will be able to come down. Large particles are present on the top. So can I tell students, whatever is present in filtrate, right, their molecular weight is less than 1000 Daltons here. 1000 Daltons. Now whatever is present on the top, their molecular weight is going to be more than 1000 Daltons. If a molecule whose size is very small, will I call it micromolecule or macromolecule? You will tell me, sir, what is present on the bottom? Size is very less. It is filtrate, and I will call this as micromolecule. Micromolecule. Now, what about your present on top? I will call it as macro biomolecule. Actually, one second, students. Micro biomolecule. I will call this as macro biomolecule. Okay, students. Now understand the small thing here. These micromolecules are actually monomers. When many monomers join together, we get a macromolecule. Now all of you remember how a protein is made. A protein is made up of many small tiny amino acids. When many amino acids join together, we get a large protein. So here also all of these microbiomolecules, right, micromolecules, right, they are basically monomers. Here we have their polymers. They're going to be polymers. So I'll give you again a entire revision, students. How did we come up to this here? Like how did we end up achieving here? Experimental proof. This experimental proof is telling us how do we get micro and macromolecule. Here we sacrificed one liver, RIP, right? Okay. We put it in a mortar and pestle. We added trichloroacetic acid was added here. Then we got a slurry. And this slurry right now, this slurry was used in a conical flask. We added the slurry on top. Some amount of slurry was able to drip down. That is called as filtrate. Whatever is present on the top is called as retentate here. Retentate and filtrate. This is called as acid soluble fraction, acid insoluble fraction. Here molecular weight is less than 1000 Daltons, more than 1000 Daltons. Macromolecules, microbiomolecules. They are monomers, polymers. Students, can it become more easy than this? How easy is it, students? Tell me. How easy is it? Hello, Gopika ma'am also is here. All of you understood, students? All of you understood? Yes or no? This is called as experimental proof for your micro and macromolecules. Now I will show you a quick example, students. Again, in micromolecules, example is simple sugars. What is a simple sugar? The simple sugar, it means it could be your monosaccharides, disaccharides, and in some cases oligosaccharides to some extent. That's all. Okay. Amino acids, nucleotides. All of you know nucleotide. If you do not know, I will teach you. Don't have to worry. Okay. Now, here what do we have, students? In biomacromolecules, what do we have? Complex carbohydrates, polysaccharides, long chain of polysaccharides. Here we have proteins, we have nucleic acid. Can anyone give me an example of nucleic acid, students? Can anyone give me an example of nucleic acid? Quickly, students. Quickly. Christina, Green, Pavitra, Chaitra, anyone? Karthik, anyone? Example of nucleic acid? You will tell me, sir, DNA or RNA? DNA or RNA? Now, students, now. Here is an imposter here. All of you play that game called Among Us, right? Among Us. In Among Us game, there is always one imposter. Now, here also, there is one kalla here. Imposter, who is not supposed to be here, but he is here. The imposter here, students, imposter here is none other than this hiding in the plain sight called as lipids. So why am I calling it as imposter? Understand, very simple. This lipid here, right? The size of lipids is actually less than 1000 Daltons. Its size is around 800 Daltons or even less actually. The size of lipids is around 800 Daltons. So technically speaking, lipids are supposed to be where? Micro. If you go by the size, they are supposed to be in micro. But where are they? In macro. Why? Understand, students. How many of you played a game called a chain when you were kids, right? I still play sometimes, right? When you were in school, you play a game called chain. So what is happening here is all of these lipids, they are forming a nice gang. All of them are holding hand and they are forming something called as vesicles. They are forming something called as vesicles here. Vesicles. I will show you what is a vesicle. You might have seen vesicle in the soap formation, the missile formation, right? So they will form a large vesicle. So all small lipids will join together. They will form vesicle, and all of these vesicles are present right here. So lipid is present on top here. So all the vesicles will join hand and lipids are present where? On top. Nice, no? Nice. See, unity in diversity there. Like even if you are minority, if you hold hands together and you can become a stronghold. So they have become strong people now by holding hands. Okay, by holding hands. Clear, students? Clear? That is your entire macro and micro molecules. Oof, so easy. Now, students, here's a quick table. Again, I'm telling students, this particular chapter, right? There are so many tables. Question will be generally asked from tables only. So don't have to worry. Okay, students? Yes. We also play a nice. Okay. See, all of you can see Earth's crust hydrogen is less. Here we have more. Carbon is less. Carbon is more in human body. Now oxygen is less. Oxygen is more in human body. Nitrogen very little. More in human body. I told you, all of these elements are less in Earth's crust, more in the human body. But both are found in both the places. Right? These elements are found in both the places, more in the human body, less in Earth's crust. That is the basic difference. That is the basic difference, students. Students, quickly, let me check the likes. How many of you have liked? How many of you not liked? Students, what is this? 200 likes still not done. Our target is 200. First, to make it 200 likes. Then we'll go ahead. All of you. Quickly smash the like button. All of you. Nice. Exactly. Never let the child die inside you. Okay, students. Now, what if I tell you, students, in living tissues, all of these following elements, ions are also present. All of you will believe me, students? All of you will believe me? See, they are inorganic in nature. Most of them are inorganic in nature, right? In macromolecules, micromolecules, we look at organic molecules. What if I tell you all of them are present in your body also? All of you will believe me? You're like, no, sir. How will I believe you? You tell me, students, I cannot believe you, sir. So give me a proof, then I will believe. Okay, I'll give you proof now. So students, all of you ready for second experiment now, students? All of you ready for second experiment? Here now we will do one more experiment now. We will do one more experiment right now. Okay, one more experiment. Ready, all of you? And students, do not worry, all of these notes will be available in Telegram channel. So download the Telegram, join the channel, you will get all the notes. Okay. Now, experimental proof you understand. Now this is called as ASH test. It is called as ASH test. Now in this case, we will take one leaf only. Okay, we can't keep killing rats unnecessarily. So we will take a leaf now. We will take first a green leaf. First we will take a green leaf here. And friend, this is much more destructive in nature. We'll use fire and all here. Fire will use. Chick chick boom, fire will use. Okay. Now I have a leaf here. Okay. Now this is a green leaf. Okay. Let's destroy it. Now what we'll do is we will remove all the water. Can anyone tell me what is the process where we remove the water? What is the process? Removal of water is called as evaporation. Okay, we will do evaporation here. Evaporation. Okay. Now once we do evaporation, we get one more very dry leaf now. Dry leaf now. So your wet leaf became dry leaf. All the water content has been removed. So students, by definition, can I call it as a fresh? This is going to be fresh here, fresh. So can I also call it as wet weight because water is available? Wet weight. Wet weight. So if this is wet, what do I call this? I will call it as a dry weight now. Dry weight. Because all the water has been completely evaporated. Okay, evaporated. Now what we do is we completely put it in mixie. Okay, mixie. Or we can call it as grinder. Mixie or grinder. All of you know Shinchan, no? Shinchan's mother. Mixie, Shinchan's mother. Okay. Now once we put it in the grounder, we completely destroy it. Once you put it in, right? Once you put it in your mixer or a mixie, nicely grind it now. Grind it. Once we completely get the powder now. We get the powder here. Now what do is you do a process called as incineration. We do a process called as incineration, or we can call it as burning. Completely burn it now. Completely burn it. Okay. Completely burn it now. Now once burning happens, what happens, students? Can I call it as oxidation also? Yes, oxidation is happening. Whenever we are burning something, students, whenever we are burning, all the organic compounds are removed. All the remaining water molecules are also removed. Completely gone. Full combustion is happening. Combustion. Now, what do we get after this? What do we get, students? What do we get? What do we get? Once we completely burn the leaf, we get ashes. Ashes. Not the Pokemon ash. This is a different ash. Okay. We get the ash here. Now, if you take this ash right now and you do analysis, we do the analysis now. Once we do the analysis of this ash, we will find that a particular organic matter, such as your leaf, has inorganic elements such as your sodium, potassium, calcium, magnesium, and water has been removed obviously. Sodium chloride, calcium. We have get all the different types of your elements we get. So that is the experimental proof telling that yes, inside a living tissue, we have other types of elements are also present. Then students, and what do we do? Some of you might ask me, sir, what are these analysis? There are multiple analysis, students. There are a lot big machines are there. There could be HPLC not for this. Right? HPLC can be used for other things, but there are other machines which can do the analysis. Okay. Then sir, yes Sanjay, yes Chaitra, Christina, all of you done? This is going to be the entire ash test. Fresh weight, wet weight, evaporation, dry weight, mixie, grinder. I think I'm selling all of you. Okay. Powder, burn, oxidation, ash, analysis. This is called as ash test. Second experiment right here. Second experiment. Then students, done all of you? Okay. Now we come to the next concept called as amino acids. Amino acids, students. Now, can anyone tell me where do we get amino acids from? From where do we get them? Can anyone tell me? All of you. Yes. Anyone? Ravindrani? Yes. Karthik? Blue paper rocket? Blue paper rocket? Huh? Yes, sir. Princess? Yes. Princess, today I'm taking a class on KCT also. Today I'm taking a class in the evening, human reproduction. Okay. Yes. Gene? Yes. Gene? Okay. Now students, now we'll do something called as your amino acids. Okay. Can anyone tell me where do we get the amino acids from? You like, sir? Some amino acids are produced inside my body. Some we eat chicken. Okay, we eat chicken. We eat a lot of different types of food items. Through diet, we can get amino acids. Okay. Now don't tell me, students, from protein. Amino acids make up the protein. Remember that much. Okay. Remember that much, all of you. Remember that much. Okay, students. Now, first of all, students, can anyone tell me these amino acids, are they macromolecule or micromolecule? Anyone? Students, are they macromolecule or micromolecule? You will tell me, sir, amino acids are very tiny. like all of us, it's very tiny it is. So I will call it as a micromolecule. I will call it as a micromolecule. Biomolecule. Micro biomolecule. Now students, if it is a micromolecule, is it acid soluble or acid insoluble, students? It is acid soluble. Acid soluble in nature. Present in filtrate. Present in filtrate. It is a monomer or polymer. It is going to be a monomer in nature. Monomer in nature. Okay. For example, students, if it is a monomer, let's take I have one amino acid plus one more amino acid plus one more amino acid. What do I get, students? Can anyone tell me what will happen when I join multiple amino acids? When I join multiple amino acids, I end up getting a structure called as protein. Protein. We end up getting the protein, students. Protein we get. Crazy, no? Crazy. That's how we get the protein. Now, can anyone tell me, students, is this protein right here monomer or polymer? This protein right here is going to be polymer in nature. I'm teaching as if you're in small kids today. Okay. I'm teaching all of you in small kids. Okay. All of you small kids today, learn as small kids, get the highest marks. It is a polymer. Okay. It's a polymer right now. Okay, students. So here we can see many chain of amino acids joined together, we get a protein. Now students, there are plenty of proteins. Okay. There are so many different types of proteins, right? So many proteins are there, right? So many proteins are present in the world. It could be your melanin, trypsin, actin, hemoglobin, insulin, glycogen, fibrinogen, yes, collagen, creatine, growth hormone, pepsin. Students, is growth hormones also proteins? Can anyone tell me, is hormones also protein, students? Yes, yes or no? Do you think hormones are also protein? Yes, they are. Okay, hormones can also be type of proteins also there. Yes. Do you think, students, enzymes are also protein? Enzymes are protein, students? Enzymes are also protein, tell me yes or no? Enzymes are also proteins, tell me yes or no, quickly in the chat. Is enzymes also proteins? Yes, yes. Except ribozyme, right? Your enzymes are also made up of proteins. So there are so many proteins, So if there are so many proteins, at least we should have around 1000 amino acids. Tell me yes or no? At least minimum to minimum 1000 amino acids to make so many proteins. No, we don't. No. Actually, there are at least around 300 are there. 300 amino acids are there. But in our body, 300 are made, in lab and everything. But in our body, only 20 amino acids are found, students. In our body, students, only 20 amino acids are found. We have leucine, isoleucine. All of these are amino acids which are making up the proteins in our body. All of these amino acids, students, all of these amino acids will make up the proteins in our body. Will make up the proteins in our body, students. Okay. Now, where do we get from? We get from chicken. So, how many of you like chicken, students? How many of you like chicken? See, students, if I get an option to eat chicken biryani or rice and rasam, honestly, I will go for rice and rasam. I don't know why. I don't know why, students. If I get an option to eat chicken biryani or rice and rasam with one papad, with apla, okay, I will still go with rice and rasam. I don't know why, students. I don't know why. I think it's the, vegetarian coding in me. Okay, I will still go for rice and papad. You tell me, what do you want? All of you. What do you want in the chat? Okay. Now, students. Now, there are mainly two types of amino acids. There are two types of amino acids. One is called as essential. One is called as non-essential. Okay. Essential and non-essential in nature. Now, all of you can understand by telling that essential means important or not important. Tell me, students. Ma'am will go with biryani only, I know. Ma'am will go with biryani only, I know. Okay. Now, students, essential means what? Tell me. Essential means it's important. Essential means it's important for us. Okay. So, essential amino acids, students. Essential amino acids are very important, but why is there a but here? Okay. There's a but here because even though essential amino acids are important, very important, these amino acids are not produced by the body. Scam, no? Scam. We know it is important. We know it is important, but they are not produced by the body. If they are not produced by the body, how do we take them? Chom nom nom nom. Okay. So by diet, nom diet we take. Okay, by diet we take. Now what about non-essential amino acids? Non-essential means it is not that important. It is important. See, when I say not that important, we need them. Without them we can't survive. The reason I'm calling them non-essential is because we are taken for granted. Our body can produce it. Body can produce them. So if a body can produce, I will call them non-essential. So aram se we can eat it. Okay, ma'am is also hungry. We will parcel one biryani to ma'am today, students. But if students, I'm telling you now. Okay, bet if this video gets around 700 likes before ma'am finishes, I will send one parcel to ma'am today. One biryani for ma'am. Okay. If you want biryani, you have to score really well. I'll buy you biryani also when you come here to Bangalore. Okay. Now, students. Now, there are something called as essential, non-essential. This, they have not asked you the question, but if they ask, you should know. Okay. For example, essential, we have a small trick here. Private Tim Hall. Again, I'm telling you, students, not my trick. I took it from internet. Don't tell anyone. Okay. So, private Tim Hall. Here we have PVT for phenylalanine, valine, threonine. T is tryptophan, isoleucine, methionine, histidine, arginine, lysine, leucine. Okay, private Tim Hall. Non-essential is almost all guys get cut after going to play sports. Non-essential. Now, students, let me tell you one small secret here. All of you ready? Students, all of you ready now? One small secret. Small secret, okay. I still remember this was when I was in class 12th. No, not class 12th. After class 12th. It was in my degree first year. Okay. And I was studying about the entire protein structures. I still remember protein structures. Okay. There was some in protein structures we learned something called as fibrous and globular proteins and everything. Okay. There I made nicely one day before the exam. See, one day before the exam. Okay. One day before the exam, I made one small trick to remember it. Okay. I made a small trick to remember it, but when I went to the exam hall, to get the trick only, it took me 30 minutes of my time and I could not get the trick out of in my mind. I made a song, something, see, I still can't remember because I didn't practice. So that something about mnemonics is that, yes, mnemonics are good, but if you do not practice your trick will become tricky in the exam. And God promise, you will not remember the trick at any cost if you don't remember. So please be very careful when you're making the tricks. Okay, please be very careful. Otherwise, forget everything. You will not get the tricks only. I'll tell you why. I'll tell you one small example. I'll tell you. Okay, let's take here we have A for arginine here. A for arginine. Here we have A for aspargine. So if you don't practice it, you will write aspargine there and that thing here. Very possibility is there. Okay, one more example you take. Let's take a I'll tell you what you will make mistake. Okay, tryptophan here. Tryptophan. So here we have tryptophan. If you don't practice tryptophan here, you will write tryptophan here. Yeah, you will write tryptophan where? Nothing. You will write tryptophan here instead of tyrosine. You will write tryptophan here. Gone case. Full marks only gone. Okay. So please be careful about mnemonics. Very scam it is. It is like a double-edged sword. It can be good also, bad also. Okay. Now all of you. Now, can anyone in the chat tell me what is the chemical formula for methane? Anyone, students? Chemical formula of methane. Quickly, students, quickly in the chat. Anyone? Methane. So, students, I'll drink some water. All of you drink some water. All of you drink, students, all of you drink some water. Students, I'm telling you again, practice everything. Otherwise, exam. Oops. Okay. So all of you are telling me CH4. Should we draw CH4 now? Let's draw CH4. C H H H H. Now we'll play one small game. The game is very simple. I give you hydrogen, you give me something back in return. Okay, I will give you hydrogen, you give me something back in return. Okay, very simple game. Okay, now students, I am giving you this hydrogen. What will you give me, students? What will you give me? I am giving you this hydrogen. You are supposed to give me carboxylic acid. You have to give me carboxylic acid. Can anyone tell me the chemical formula of carboxylic acid? Quickly in the chat, students. Carboxylic acid is COOH. Now, students, now I will give you this hydrogen. Now I'll give you this hydrogen. You are supposed to give me something called as amino group. Amino group. That is NH2. This right here is amino group. You give me amino group. Here you gave me carboxylic acid. You gave me carboxylic acid group here. Okay, carboxylic acid. Now again, students. Now I will give you this. Which one should I give, students? Which one should I give? Okay. Now I will give you this hydrogen. You are supposed to give me R group, a functional group. R group. So this right here, students, by give and take barter system, right now we have something which is called as a general structure of a amino acid. So can I also call it as, students, can I also call it as substituted methane? We took a methane and we substituted everything. Completely changed everything. Okay, that is called as substituted methane or amino acid. This is the general structure of an amino acid. All of you wrote down? All of you done? Writing is done? Okay. Now, students. Now. Okay. Now we go to the next concept. That is amino acid. All of you done? All of you understood this much? Here we have a carbon. Here we have a functional group, amino group, hydrogen, and R group. R group here is nothing but a functional group. It is a functional group, students. It is a functional group. Okay. Now, students. Now, one small thing before I go. Right, before we go to the next concept. Now this R right here, let's take one more time, we'll draw here. We have a carbon, here we have a carboxylic acid, here we have a amino group, here we have, let's say, hydrogen, and here we have a R here. Now students, all of you listen to me very carefully, right? What if this R right here, what if this R right here is going to be a hydrogen? If it is going to be a hydrogen, what do we get? If the R here is going to be a hydrogen, we get an amino acid called as, anyone who can tell me? We get an amino acid called as glycine. We get an amino acid called as glycine here, glycine. Okay. Now, what if this R group is CH3? What is CH, students? CH3 is methyl. One second, let me just write. Follow same order, same color also. It is going to be methyl group. What is methyl, students? Methyl is nothing but CH3. If CH3 is given to me in this R group, if it is methyl group, I will get an amino acid called as alanine. Now, students, last one. Okay. Now, what if this R group is going to be hydroxyl methyl? The same color, I have to maintain it. What if it's going to be hydroxy methyl? That is going to be CH2OH. Now, in such case, I get an amino acid called as serine. Now, do you have to remember this? Yes, you have to remember it. I will call it as gas. What is gas? Gas, not which gas you're thinking. This gas here is glycine, alanine, and serine. This is called as gas here. Okay, gas. Now, students, again remember, students, there is something called as chiral and non-chiral. If you learn chemistry, you can tell me. If all of these functional groups, right? If everything is different, that is called as chiral. But here, in the case of your glycine, here also have hydrogen, here also have hydrogen. So, will it be chiral or non-chiral? Tell me, students. Will I call it as chiral or non-chiral? Tell me, students, in the chat quickly. Yes, this is going to be different color I will use. It's going to be non-chiral in nature. Only non-chiral amino acid. Non-chiral and optically inactive. Optically inactive in nature. And it is also the simplest amino acid. Simple, very simple, humble, simple dimple it is. Okay, very cute, small glycine. Okay, so we have glycine, alanine, serine. So I will move aside once, and all of you will take some time and read through it. See this and fix it in your soul. All of you, look at it and fix in your soul. If you are done, I will go to the next concept. All of you, done? All of you, can I get some fire emoji in the chat? All of you, clear? Students, you tell me right now, till now, any difficulty in understanding this chapter? Till now, any difficulty in understanding this chapter? Easy chapter, right? Very easy chapter. Okay. No. Okay, now students, done all of you? Gas done? Okay. Now there is something called sulfur containing amino acid. This you have to know, but you don't have to remember the structure. Sulfur containing is methionine. Students, can anyone remind me? This methionine, somewhere in MIB, you somewhere think of methionine, right? Something called as AUG, yes or no? Some starter code on something. Who can remind me what is methionine? Okay. Then we also have cysteine here. Cysteine. So methionine and cysteine are the sulfur containing amino acids. All of you. Again, students, I'm telling you, I want everyone to participate in the chat. Even if you do not know the answer, try attempting, right? Because I'm here to teach you. If you knew everything, why would you be here? Right? You're here to learn. So try learning everything. Okay? Try learning. AUG start codon. Exactly. Methionine. Okay, students? Now, there is something called as classification of amino acids. Some of the amino acids, there are two types of classification here, students. Two types of classification here. Okay? Two types of classification. Understand? Two type of classification is here. Okay. First one is called as what? First one is called as long chain. It's let's say no chain we'll use aromatic we'll use. First one is called as aromatic amino acids. Can anyone tell me what is the meaning of aromatic? In the case of aromatic amino acid, students, in the case, do we have a benzene ring here? Yes, we have a benzene ring, also called as aromatic ring. Aromatic ring can be found here in these amino acids. For example, let's do a benzene here. Aromatic amino acids. The other one is called as aliphatic, or I will call it as non-aromatic also. Aliphatic or non-aromatic amino acids. Non-aromatic amino acids. They are basically straight chains. They are long straight chain. There's straight chain here. That is non-aromatic amino acids. This one all of you should know. Engagement ring. Yeah, engagement ring. What engagement ring, students? Okay. Now, here are three examples of aromatic amino acids. First one is called as phenylalanine. Students, again, when I say phenylalanine, what comes to your mind? Anyone who can tell me? Phenylalanine. Which chapter is coming to mind? Somewhere in Principles of Inheritance. Somewhere in Principles of Inheritance, we learned about accumulation of phenylalanine, where phenylalanine is not converted to tyrosine because of the enzyme is not present. PKU disease. Anyone remembers? Anyone somewhere connection is happening? Correction? Not happening? Not happening? Happening? Tell me, students. Yes? PKU disease. Phenylalanine. PKU disease. Okay. What about tryptophan, students? Tryptophan. What comes to your mind when you think of tryptophan, students? Tryptophan somewhere in amino acid, somewhere in hormones, somewhere in hormone production also. Hormone production. Okay. Tyrosine, students. Anywhere tyrosine? Coming to mind, tyrosine, students. Thyroid hormone. Yes. Tryptophan you might have observed in auxin preparation. In auxin prep. If you remember the chapter, which chapter? Plant growth and development. In plant growth and development, you might have heard about tryptophan there. Okay. Thyroxine, you might have heard as emergency hormone. Even melanin. Melanin synthesis also, you might have heard about your tyrosine. Even in thyrox hormone also. Right. thyroid hormone. Learned about tyrosine, right? So this three you have to remember. That is PTT or TPP. Third person perspective. If you play games, you know. Your PUBG is a TPP. No, third person. Yeah, PUBG is TPP, right? TPP is it's gonna be your tyrosine. You can't be TPP, students. Sorry, by mistake I told you, students. Let's have PTT only. I don't know what is PTT now. PPT. It can't be PPT also. PTT only, students. I can't even make anything out of PTT. Okay. Now, students. Now we learn something called as acidic amino acid, basic amino acid, and neutral amino acid. Very simple. Very simple. Acidic, basic, and neutral. Understand the difference, students. Understand the difference today. Okay. What do you mean by acidic, basic, and neutral? Now I will show you a diagram and tell me, students, what is extra here? See, the basic amino acid structure is carboxylic group is right here. Here we have amino group, amino group. Now this is your R group here. This entire thing is the R group. Now in this R group, right, students, can any one of you notice here we have a extra COOH, extra carboxyl group is here. This is one carboxyl group, extra carboxyl group. So can I call it acidic in nature? Acidic in nature. Now, if this is called as your aspartic acid. Then we have glutamic acid also, glutamic acid. In glutamic acid also we can see, students, this is your normal amino group, carboxyl group. In glutamic acid again we can see one extra carboxylic group, extra COOH. That is why it's called as extra spicy, no, extra acidic in nature, extra spicy or extra acidic in nature. Okay, students. So this entire formula you don't have to remember. All you need to remember is the names: aspartic acid, glutamic acid. Two are acidic in nature. Okay. Now, similarly, students, if you look at the basic structures. Okay. Similarly, if you look at the students diagrams, no, you don't have to remember in diagrams. Just remember the names here. Okay, names you remember. Okay, diagram nothing, not important. Okay, this entire formula not important. Remember only the names here. Now, basic amino acids, students, if you can notice in lysine, arginine, histidine, you will notice here that here there is an extra amino group, and extra amino group. So in the case of basic amino acids, there is extra amino groups are present. Now again, let me ask all of you a simple question. Gopika I will teach you later on. Okay. Can anyone tell me, students, right, where do you study about lysine and arginine? In which part of molecular base of inheritance, MBI, we study about lysine and arginine? Quickly, students, before Gopika ma'am tells the answer. Who can tell me? Before Gopika ma'am tells, tell me, where do you study about lysine and arginine? If you know, you know. If you don't know, Gopika ma'am will teach you today. Don't worry. Quick. Where do we study? Exactly, Chaitra. We studied it in nucleosome or basic proteins. We learn, right? Histone. So DNA packaging, exactly. In DNA packaging, we learn it. So students, Gopika ma'am will teach you today. All of you, I know, you keep crying. Sir, I can't understand MBI. Gopika ma'am will teach you today. So this is where you learn the basics. All of you understanding, students, this is where you learn the basics. Why are they called as basic amino acids? This concept will be applied in their DNA packaging again. Understanding, students? Understanding, all of you? Yes. So lysine, arginine. Between these two best friends, someone third wheeling is here. Who's the third wheel here? Third wheel is histidine here. Third wheeling person. Okay. Basic amino acids. Now there are multiple neutral amino acids. In your NCERT, you can write valine also. Valine. Okay. Let me give you a perspective. Right. Out of the 20 amino acids, here 2 are acidic in nature, aspartic acid, glutamic acid. 3 are basic in nature, histidine, lysine, arginine. 3 are basic in nature. Now, can anyone tell me what are the remaining amino acids? See, 3 plus 2 is 5. 20 minus 5 is 15. So, remaining 15 amino acids are neutral in nature. So there are 15 are neutral, 3 is basic, 2 acidic in nature. Okay, done students, done. Now, how many of you still do not understand the concept of Zwitterion, raise your hands. Quickly raise your hands. All of you. Okay. From NEET crash course, hi. Students, how many of you don't understand the concept of Zwitterion? Raise your hands. Raise your hands. Sir, I am not able to understand only what is Zwitterion. I have studied NCERT, but NCERT is not clearly telling me, sir, Zwitterion. I am not able to understand why is it called Zwitterion, or what is this isoelectric pH, or what is the meaning of it? What is isoelectric point? No, what is happening there? Raise your hands, all of you. Raise your hands. Quickly, students, quickly. Let me drink some more water before I start that concept. Aromatic, all students, aromatic, please remember the names, that's all. All of you drank water? All of you drank water, students? Now, students, you tell me honestly. All of you tell me honestly, students. Whom are you scared of in the house? Mother or father? Don't tell no one. I know there will be nothing like no one. You are scared of one person. Okay. So in my house, very scared of dad. Okay. Very, very scared. Very scared. Okay. So what happens? You understand the scenario in my house. Scenario. Okay. When no one is in the house, I am in jolly. Full computer games. Like when I was a kid, obviously, when I was 10 years back. Okay. 10 to 15 years back. Okay. Full computer games I'll be playing. Okay. Not doing any homework. Chilling always in front of TV. I'm sitting in front of TV and laughing completely. Okay. Full enjoy. But as soon as I hear the bike sound, my 10th sense, I don't even know which sense is it. Okay. I can hear the something is wrong. As soon as I hear the bike is coming inside that bike, everything close. I will change myself completely, put one nama, sit in front of the book as if I'm reading from 10 numbers. I'm like, okay, Om Namah Shivaya, this is the, okay, nice. India is my country, nice. Everyone is brother and sister. Start reading everything in the world. I don't even know what I'm reading. I don't even know what book I'm holding, but book should be there in front of me. Full attitude change, life change, full perspective change there. Okay. So depending upon the situation, I used to change myself. Full change depending on situation. So I believe all of you also will be doing the same also. So if you are doing the same, I am the same. Can the amino acid also be the same? Tell me yes or no. Can the amino acid also be the same now? Same. So your amino acids also, students, when I'm keeping them in acid, they're like, oh, full different. As soon as I keep them in base, they're again full different. So understand how do they, amino acids are also changing their color. Okay. Amino acids are changing their color. Okay. Now, for example, students, let's take one acidic amino acid. Okay. Let's take one amino acid right now. Tell me, students, quickly in the chat, any amino acid? I will divide it into two halves. Okay. Let's take one amino acid right now. Okay. Let's take one amino acid. Students, I hope it is visible to all of you. Students, is it visible to all of you? It is visible to all of you. Okay. Now, I will take this amino acid, a normal amino acid, students. I will keep it in acidic medium now. Acidic medium. When I take this amino acid and keep it in acidic medium, what happens? In acidic medium, there are more H+. Yes, there are more H+ in acidic medium. And this H+ right now, students, this H+ is now taken up by your NH2. Now, what happens? You see this? If it is taken by NH2, what do we get, students? We get carbon, COH. Here we have an H, here we have an R, and we get NH3. We get NH3 right now, NH3. So, if an amino acid is kept in acidic medium, it is completely changing itself and it is becoming more basic in nature. So, in acidic medium, amino acid is becoming basic in nature. Understood, all of you? Understood. Now, let me take one more amino acid. Okay. Okay. Now I am keeping it in basic medium right now. Okay. In basic medium, what is happening, students? This hydrogen is lost to the medium. RIP. It is lost, students. Now understand what is happening here. Okay. Now what is happening here is we have NH2 only, NH2. Here we have carbon, here we have hydrogen, here we have R, and this becomes COO minus. CO minus. So when you keep it in basic medium, the amino acid is becoming acidic in nature. It is becoming acidic in nature. So if you go back to this diagram of your NCRT, here we can see in low pH means what, students? Low pH means what? Low pH means acidic medium. Low pH means what? Acidic medium. In acidic medium, it is becoming NH3 plus in acidic medium. In high pH, in basic medium, it is becoming acidic in nature or ion in nature. So in high pH, amino acids can become ions. In low pH, it becomes a cation. So how you are changing your entire perspective. As soon as someone is coming, now I'll put on a book you're opening. Same thing your amino acid is also doing. Completely changing itself. But, what is the but here? Understand the but. Okay. What exactly happens at a pH, right, called as isoelectric pH? Understand, students. This concept is very important. Okay. There is a pH called as isoelectric pH. Now, if this is your amino acid right here, okay, at a particular pH called as isoelectric pH, what happens is that this hydrogen is transferred to here. This pH is called as isoelectric pH. What is happening here is called as intramolecular proton transfer. Intramolecular proton transfer is happening. Whenever there is intramolecular proton transfer, this hydrogen is transported here. So when that happens, here we get a positive charge and here we get a negative charge. This is what is shown here. Students. All of you can see this. At a particular pH called as isoelectric pH, here we get a partial positive charge and a partial negative charge. This particular ion is called as amphoteric ion or Zwitterion. Zwitterion is a result of intramolecular proton transfer where a molecule has positive and negative charge together, and this is present at isoelectric point. What is isoelectric point? Isoelectric point is a point where in a pH where amino acids will not move in electric field. Chemistry, no so much. Chemistry, no? Yes, chemistry only. Okay, it will not move in electric field that time. Okay, so here and the net charge, positive, negative, net charge is going to be 0 here. And all of this is happening at isoelectric pH. Okay, isoelectric pH, entire thing, isoelectric pH. Okay, at a particular pH called isoelectric pH. This is called as amphoteric ion also. Amphoteric ion. This right here, it is also called as amphoteric ion. Amphoteric ion, also or Zwitterion. Zwitterion, this particular structure here. How many of you understood, students? How many of you understood? Here, molecule with one functional group having positive charge, one functional positive charge, and other functional group negative charge. Positive equals negative, net charge is 0 at isoelectric pH. All of this is happening. That's all. That's all is a Zwitterion. That's all is a Zwitterion. Positive, negative charge together, net charge is 0. Where is it happening? At your isoelectric pH. Why? Because it is happening. Intramolecular proton transfer is happening. How many of you understood, friends? How many of you understood? Raise your hands. How many of you understood, students? How many of you understood? If you understood, students, quickly fire emoji in the chat. Quickly some fire emoji in the chat. All of you. I'll repeat it again. I'll repeat again. See this. Very important concept. Amino acids are different at different pH. What is happening at a particular pH? At a particular pH, what is happening is a amino acid, this hydrogen is transferred to this amino group here from a carboxylic acid, and we end up getting a negative charge, positive charge in one molecule here, right here, right? and it is because of intramolecular proton transfer is happening here, and this structure is called as amphoteric ion or Zwitterion right here, or Zwitterion right here. Net charge is 0. That's all, students. That's all. Now here is a question. Can anyone tell the answer to this question? This is a students NEET PYQ. Quick answer I want. Yes, all of you. Which area? Who is asking which area, students? What are you talking about? K-pop and all. Don't talk K-pop now. Why are you talking about K-pop here? Listen to this now. K-pop later. Or your Lisa can wait. Read this now. Done, students? Now, this answer. This is a NEET 2024 question. The following can be as Zwitterion. The following can be as Zwitterion. Fatty acid, monosaccharide, amino acid, nucleic acids. All of you know it has to be amino acids. Amino acids form the Zwitterion. Okay. Korean pop. Okay. Now, students, with that, amino acids is over. How many of you understood? Students, how many of you understood amino acids in such an easy manner? How many of you understood? Students? It is so easy. The entire chapter is so easy, students. So easy. Okay. Okay, students. Now, can we start with lipids now? Lipid again is very easy. In lipid, the main thing which you have to study about is going to be your gingerly oil, which is going to come. Okay. Apart from gingerly oil, students, in lipids you have to mainly focus on glycerol and fatty acids. Glycerol and fatty acids. That's going to be very important for all of you. Okay. Now, can anyone tell me, students, how many of you tried mixing oil and water? Raise your hands. See, as a kid, I used to love doing experiments, random experiments in the house, random. I will take curd, I will add boost to it, I will call it as boost curd, boosted curd. I will take boost and I will add rice to it, I will call it boost rice. Okay, I will take Horlicks, I will take boost, I will mix together, I made a new chemical. Okay, Horlicks boost mix. Okay, so don't ask me why I should do it. I should keep doing random experiments in the house, thinking that I'm a big scientist. Okay, now in that scientist era, okay, I have tried mixing two things. I'm like oil, water. I'm like, how can you not mix? Huh? How can you not mix? When I am here, I will make you mix. Okay, so I took oil, I took water, nicely combined both. They mixed eventually. Eventually they mix. But if you keep them as such, if you take as such, they do not mix. But if you shake vigorously, they'll mix eventually. Okay, so oil plus water. Okay, now students, here we come to the point called as the lipids weigh less than 800 daltons but still are present as acid insoluble pool, that is present on the top. Why? Because they form group here. See, all of you, I told you they form a group like this. All of you seen this also, right, students? All of you seen this? Students, all of you have seen this? Tell me yes or no in the chat quickly. This is called as a lipid bilayer. All of you see polar head and non-polar tail. Polar head and a non-polar tail. All of you see this? Non-polar tail, polar head, lipid bilayer. Now, all of you can see this and tell me, they're forming a group, right? They're forming a gang. When they form a gang like this, they cannot go down. Chain, they're playing holding hands. Okay. This is what is happening. This is what is happening in the case here. Okay. This is what is happening here. So they are found in your top part. They are not found in retentate here. Okay. So they are found in retentate, not in filtrate. Now, students. Now tell me, students, lipids. Are they found in retentate or are they found in the filtrate? Quickly. Lipids are found in retentate. What about are they found in acid soluble or acid insoluble? Acid insoluble fraction present on top. Okay. Molecular weight is more than 1000 or less than 1000? less than 1000 Daltons. Around 800 Daltons we can find here. 800 Daltons. Okay, around 800 Daltons we can see here. Okay, 800 Daltons we can see here. Okay, are they organic compounds? Yes, sir. They are organic in nature. Organic in nature. Okay, students, are they polymeric in nature now? No, they are not polymeric in nature. They are not polymeric like your monosaccharides. Sorry, not polymeric like polysaccharides. They are not polymeric in nature. Okay, they are not polymeric in nature. Okay, students, not polymeric in nature. Now, lipids, there are three types totally: simple lipids, compound lipids, derived lipids. Now, we'll be focusing mainly in this chapter the simple lipids. Okay, simple lipids. Now, under simple lipids, we have something called as fatty acids, as well as we have glycerol. We have the glycerol here. So, what is fatty acid? What is glycerol? I'll teach you. Don't worry. It's very simple. You're like, sir, this is so easy to understand. Okay, you will tell me thank you after this. Okay, so I'll teach you what is fatty acid, the structure, and what is the function. Same goes for glycerol. I'll teach you one by one. Derived compound lipid, you don't have it in your syllabus. You have one example. Let's see an example. Okay, derived lipid also you don't have in your syllabus, but you have an example, that is cholesterol. Cholesterol is there. Okay, which is present in your heart also. Okay. Now, students, now we come to something called as your fatty lipids, fatty acids. Now, can anyone tell me, students, when you think about fatty acids, what comes to your mind, students? Anyone who can tell me? Like, for example, fatty acid, what is coming to your mind right now? Some acid which is very big acid? Tell me, do not lie to me. Do not lie to me. When you think about fatty acid, what is coming to your mind right now without any knowledge? Some very big fat acids? Yes or no? Because when I was your age, that also even I used to think the same thing. When I was in class 11th, when I did not know what is fatty acid, I was thinking, oh, fatty acid means one very big acid. That's all. That is all in coming to my mind. One big HCl, like try to imagine HCl or H2SO4, big H2SO4. Simple minds, no, undeveloped minds. That was coming to my mind. But as soon as I grew older, I understand fatty acid is not that. Fatty acid is nothing but, students. Fatty acid is nothing but, students, R group with a carboxylic acid, COOH. This right here is a fatty acid. Sorry, I'm so sorry, students. All your dreams have been shattered. This right here is a fatty acid right here. Now, in this fatty acid, if you can notice, students, this entire part is called as your carboxylic acid part. This right here is the carboxylic acid part, and this part is your functional group. And this functional group right here, student, this functional group right here, it can be a methyl, it can be a ethyl. All of you know what is ethyl, right? C2H5. It can be ethyl, or it can be from 1 to 19 any carbon group. 1 to 19 any carbon group it can be. Long chain. So you're somewhere correct. It is fatty means very big it is. It can be very big also, very tiny also. Okay. So 1 to 19 it can be any group. That is called as your fatty acids, where we have a carboxylic acid group and an R group. This right here is a typical fatty acid. All of you understood, students? All of you understood? This R group, is functional group, is a hydrocarbon here. This right here is a, what is a hydrocarbon also? Hydrocarbon. Hydrocarbon also. This one here, functional group hydrocarbon. This right here is a fatty acid. Now, students, this fatty acid can be of two types: saturated, unsaturated. Understand what is the difference. Okay, there is something called as saturated, unsaturated. Very simple difference. Just learn it and you're good to go. Saturated are single bond, unsaturated double bond. That's all. First of all, students, tell me in the chat, how many of you like eating ghee chapati? How many of you like eating butter and ghee? In the chat. This is single bond here, and this is going to be double or triple bond. Double or triple bond. triple bond can be observed here. Double or triple bond can be observed here. So if you love ghee, okay, so you might have noticed, students, in winter season or in normal condition also, will the ghee, when you keep it in a vessel, will it become solid or will it be liquid? Tell me in the chat. See, you might have noticed ghee is always solid, while your cooking oil, which you make omelette, egg and everything, no, oil which you use to fry things, that is always liquid. You might have observed, right? The ghee is solid, the oil is liquid always. I'll tell you why. Students. Oops. Okay. Your saturated fatty acids, right? They can have a single bond and their melting point is very high. Melting point is high. And they are solid at room temperature. While your unsaturated are, your melting point is very low. You might have noticed, students, when you add ghee or when you add oil, which one becomes, students? Which one becomes much more liquid faster? Or which becomes hot faster? Right? Your liquid becomes very hot faster, your oil becomes very faster, heat faster. Yes, it does. Okay. Here the example, the liquid at room temperature. Liquid at room temperature here. The example here is going to be, students, your butter or ghee, nice tasty butter or ghee here. Here the example is your sunflower oil or cooking oil. They're liquid at room temperature, melting point is low, they have double or triple bonds can be present here. While here, students, while your saturated are single bond, melting point is high, liquid at room temperature, and butter or ghee is the example here. Okay, students. Now I'll give a famous example here, which always makes me laugh for no reason. Called as gingerly oil. It is called as gingerly oil, students. Gingerly oil here. Example is gingerly. Who keeps the name gingerly? What is gingerly? Gingerly oil. Gingerly. Students, you try saying it on your own once. Try saying it on. Try saying it gingerly. Tell me, doesn't it make you laugh for no reason? Gingerly. Gingerly. Okay. Now that is your saturated and unsaturated here. Saturated and unsaturated done. Okay. You can add other examples also. Here we can add palmitic acid, stearic acid, arachidonic acid also you can write here. Okay. You can write that also here. Okay. I'll write, otherwise you'll forget, students. You'll forget otherwise. Here we can write something called as the palmitic acid, or we can add here stearic acid. Stupid. Stearic acid. Okay. Palmitic acid is 16 carbon. Stearic acid is 18 carbon. Here we can write arachidonic acid. Arachidonic acid, which is around 20 carbon. Friends, I hope it is visible to all of you. Arachidonic acid 20 carbon, stearic acid, palmitic acid 16 carbon, 18 carbon respectively. Here we have all single bonds. Here we have double and triple bond can be seen here. Okay. Students, 1 second. I'll drink some water to recover. I knew it was coming from 1 kilometer away only. Still. Okay, students, do you want to hear one very lame joke? How many of you want to hear? All of you know something called as dad jokes? Okay. Do you want to hear one small joke? Okay, students, see, when you grow older, right, like me, right, you end up laughing at anything possible. There is nothing called as, unfunny things. Everything is funny in this world. Okay, everything is funny. Okay. Now, students, I'll tell you one small joke. It is not even funny. I don't know why. It is not even funny, but still we will laugh. Okay. Still we'll pretend to laugh at least. Okay. Can anyone tell me what is light and green? Joke. What is light and what is green? Anyone who can tell me? What is light and what is green? Anyone? Some of you will, after listening to this, some of you will unsubscribe. You will dislike and go also. I know. What is light and green? Light green. Light green color. Okay, light green color. And Gopika ma'am knows all my other jokes also. Okay, Gopika ma'am's no other jokes also mine. I keep telling her my other jokes also. Okay. Ma'am is fed up. Ma'am is fed up of my dad jokes. Friend, there's one more famous joke I will not tell you today. Okay. I'll tell you next class. Okay. There is a Aji joke. There is something called as Aji joke, which I will not tell now. Okay. I will tell it some other class. Okay. Oh god, where do I go, students? Light green. Oh god. Now, here I can show you one more thing, students. Here I can see here oic acid number double. See, all of these are double bonds. They can see double bonds here, double bonds. So they are unsaturated example. Linoleic acid, linoleic acid, arachidonic acid. Right, number of double bonds. This they will not ask you. This they will not ask you, students. Okay, this they will not ask you. Okay. Now, can we start glycerol now? So all of you understood. All of you understood. All of you understood your fatty acid, carboxylic acid group plus an your hydrocarbon can be there. Plus a hydrocarbon can be there, students. Now we'll start with something called as glycerol. Ready, all of you? Ready? All of you ready, students? Glycerol. Can we start glycerol? Oh God. Can we start, students? Yes. Now, what is glycerol actually? Glycerol is nothing but an alcohol. That's all. Over. Glycerol is nothing but an alcohol. Glycerol is nothing but an alcohol. It is an alcohol. One second, students. Too much of laughing is not good. I will cry later on, I know, for otherwise. Okay. It's a small theory. All of you know theory, right? If you laugh too much, you'll cry later on. So don't laugh too much. Okay. So it is an alcohol. Okay. It is an alcohol which has 3 carbon. Let's draw it. 1, 2, 3. It has 3 carbon plus 5 hydrogen plus 3 OH. 3 OH groups. So let's draw 3 OH. 1, 2, 3. Let's draw 5 hydrogen. 1, 2, 3, 4 and 5. And ta-da! This right here is your glycerol. This right here is glycerol. This glycerol has one more name. Scientific name. I will call it scientific name. Okay. How many hydroxy is there, students? 3 are there. So I will call it trihydroxy. Trihydroxyl. 3 means propane. Propane. Well, you know better. All of you know better. All of you are organic master experts. All of you are. Okay. So it is going to be trihydroxy propane right now. Trihydroxy propane here. Okay. Trihydroxy propane here. This right here is a glycerol. Difficult. Tell me, all of you. Difficult. Is it difficult to understand? Students, tell me, is it difficult to understand or not? So please don't say difficult now. It cannot become easier than this. Okay. Okay. So glycerol is there. Trihydroxy propane is right here. This is your glycerol. Now, students, now. What if I want to, right, connect? Why if I have one glycerol here, I have a fatty acid. Now I will take this glycerol and this fatty acid and make a baby out of it. What do I get? Interesting. Interesting, students. See, I have glycerol here. Glycerol of trihydroxypropane. I have a fatty acid here. Now, what if I take a fatty acid from your, let's say, some country, glycerol from your one country, and I'll make a baby out of it? What do I get? How do we even make the baby here? Okay, the baby is very simple, students. How do we make a baby called as esterification? We do something called as esterification here. Let's take one glycerol here. Let's take glycerol. Okay, let's take glycerol. One, two, three, four, five, 3. This right here is a glycerol. All of you agree with me, students? This right here is a glycerol right here. Now let's take one fatty acid also. Let's take a fatty acid. Okay. Can anyone tell me in the chat, palmitic acid is how many carbon? Palmitic acid is how many carbon? 14, 15 and 16. 16 carbon. 16 carbon, students. 16 carbon is a palmitic acid. Right? This is a palmitic acid. Palmitic acid. This is a fatty acid. This right here is a fatty acid. Fatty acid. Now you want to make a baby out of it now. Okay. So students, reproduction again. Reproduction chapter. Now what do you do here is you take this hydrogen here. Okay. And you remove this OH here. What do we get, students? Can anyone tell me? What are we removing here? H2O. What is H2O? Water. Okay. So we remove water now. We do minus H2O. Okay. Dehydration reaction. Water we removed now. Water we removed. So what do we end up getting? How does the baby look like? We'll draw the father here. Students, I will write better chemistry, wait. Space is not there otherwise. Two hydrogen is there. Oxygen. CH2. CHOH. CH2 OH. This oxygen is here. Now here I will add, this part is added here now. This part is added here now. C double bond O, and we have a carbon here. Then we have this entire part here. Then we have the entire part. CH2 14 times CH3. This is what we get. Anything is missing? CH2, H2OH, CHOH, CH2, and carbon is here, and this we added here. Now students, now all of you understand one small concept here. All of you understand small concept here, students. Small concept. Here I replaced how many water here, students? One water was removed. So I replaced one OH here. This one OH was removed here. So if one OH was removed right now here, when we take a glycerol and fatty acid, and if you remove only one OH and one OH we are adding, this is called as what? Monoglyceride. I will call it as, students, monoglyceride. This will not be asked in exam, don't worry. Monoglyceride. Okay, monoglyceride. So all of you need to remember here is that when a glycerol reacts with a fatty acid, we end up getting a glyceride. So glycerol plus fatty acid is glyceride. Now all of you tell me, think logically and tell me, what if I add one more fatty acid here? What if I add, students, in this position, what if I add one more fatty acid? What do I call that? Do I call it still monoglyceride or diglyceride? Anyone who can tell me? Can anyone tell me, students, if I remove this OH again and if I add one more fatty, let's say I add here stearic acid. Stearic acid I add. Okay. So do I call it monoglyceride or diglyceride? That time it becomes diglyceride. Diglyceride. Okay. Now what if I remove this OH again and if I add one more fatty acid here? If I add one more fatty acid, what do I get that time? Tell me, students. That time it becomes triglyceride. So whenever we combine a glycerol plus a fatty acid, we always get a glyceride. So glycerol plus fatty acid is always a glyceride. It can be monoglyceride, diglyceride, or triglyceride. All three possibilities are there. Mono, di, tri. Formed by the condensation of 3 fatty acids and glycerol. So 3 fatty acids plus 1 glycerol will give you triglyceride. How many of you understood? Students, how many of you understood the concept of mono, di, and triglyceride? All of you in the chat. Quickly in the chat, students. How many of you understood? Mono, di, and tri. Quickly in the chat, students. If you understood, raise your hands. If you understood, fire emoji in the chat. Mono, di, and triglyceride. Okay. Now, I also told you, students, there is something called as compound lipids. Compound lipids, do you have what? Esters of fatty acid and alcohol along with additional group. So in compound lipid, what is happening is we have fatty acid plus we have the glycerol plus we have additional group. Let's take one example called as lecithin is an example. In lecithin we have fatty acid, we have glycerol plus we have additional group such as phosphate. We have the phosphate here in lecithin. Let me show you the entire diagram for your better understanding. Can all of you see this, students? Here, can all of you see lecithin here? Lecithin. Okay. See here in the middle, right in the middle. Let me just zoom it for you. Okay. All of you see, students? All of you can see. Now, can all of you clearly tell me that, students, this middle part is your glycerol. Middle part is glycerol right here. Okay. Here I am adding one fatty acid, second fatty acid. Two fatty acids are being added here. Then here we add a phosphate group here, and this is a choline. This is a choline part. Okay. So here not Virat Kohli, choline. Okay, choline part. So this is called as a phospholipid. Why? Because phosphate is been added here. PO3 is added here. So phospho group is added here. So phospholipid, lecithin is an example. This is an example, typical example of a compound lipid. Here we have a lipid, we have a fatty acid, glycerol, additional group. Here is the additional group here. Okay. How many of you understood, friends? How many of you understood? Tell me in the chat. See, this if you learn on your own, yes, it may be a little difficult. You can by heart it easily. By hearting is very easy. Okay, by hearting is very easy. But understanding is important. Okay. All of you understood, students? Tell me yes or no. Yes or no? Why is lecithin is a lecithin as compound lipid. Done, students. Lecithin. Okay. So we have different types of compound lipids. We have phospholipids, which we just now learned. Then we have glycolipids, sphingolipids. Some lipids are present in our brain also. They are present. Okay. Present in our brain. Lipids are present in brain. Example is galactosaccharide. Again, not in your syllabus. Extra information if you want to know. I always say extra little. No, extra person I am. Okay. The main lipid found in myelin is the glycolipid called as cerebroside. It is present in your white matter of your brain. Galactosaccharide is present. Okay. White matter of the brain. Then we have simple done, compound and derived lipid. Derived lipid example in NCERT is cholesterol. Lipid derived from simple or conjugate lipid is called as complex lipids. Right? This is called as cholesterol. Is a tricyclic in nature. Tricyclic means 1, 2, 3, 4. 4 cycles in nature. This is a derived lipid. Done, students. Done. Now, with that, we come to the next topic called as your nucleic acids. Can we start, students? See, do you realize? Students, do you think I'm going fast? No, right? Because I want this lecture, everyone, this lecture should be in a way that even if you have zero knowledge about this chapter, you can learn and go. That is my goal today. That is my goal. Okay. Can we start, students? All of you. Even if you have zero knowledge, you can learn and go today in my class. So I want everyone to smash the like button. Tell the other students that, see, students, there is a teacher who is teaching from scratch even now. Okay. Can we start, students, now? Nucleic acids now. Nucleic acid. Yes. We can start nucleic acid. So before I start, let me ask all of you a simple question. Nucleic acid, students. Filtrate or retentate? Quickly, students. Filtrate or retentate? Quickly. Filtrate or retentate? Why are you disappointed, bro? What happened to you? I will talk to one student now. Wait. MTG book, you can study MTG book. What is there now? Students, quickly. Tell me in the chat. Where do we get our entire nucleic acid? Nucleic acid will present in retentate. Macro or micromolecule? Macromolecule. macrobiomolecule. Acid insoluble fraction. Okay. Molecular weight more than 1000 Daltons. Okay. Now, it is a polymer. It is a polymer. So all of us know polymer are made up of some type of monomers. For example, proteins are made up of amino acids. Amino acid, amino acid, amino acid. That is a monomer there. In a protein, monomer is amino acid. Now here also, students, here also there is some form of monomer which is making this polymer. The monomer here is called as nucleotide. It is going to be, students, nucleotide. It's going to be nucleotides. So many nucleotides join together. Many nucleotides join together and make up the long nucleic acid. Nucleic acid, students. Okay, nucleic acid, students. Okay, students. Okay, nucleotide. Now, can anyone tell me, students? Nucleotide. Now, we have, what is nucleotide, students? What is nucleotide? This is a simple nucleotide, students. Again, you will learn this in your MBI. What is nucleotide? A typical nucleotide has three main things. Right in the middle, we have the pentose sugar. Then we have the phosphate group here, and then we have a nitrogenous base. Repeat after me, students. There are three main things here. First one is called as a pentose sugar. Second is called as phosphate group. Third is called as your nitrogenous base. All three are present in the nucleotide. Three things all of you can remember. All of you can remember these three things. PPN or NPP. Nitrogenous base, phosphate, pentose sugar. Okay, pentose sugar. Now, what is the nucleoside then? All of you learned nucleotide. What is nucleoside? Someone is removed from the side now. In nucleoside, someone is removed from the side now. Who is removed now? Understand. In nucleoside, students, the phosphate has been removed. So, in nucleoside, this person is sidelined. This person is completely sidelined here. So, if phosphate is removed, we are left with what? Pentose sugar, nitrogenous base. So, in nucleoside, phosphate is removed here. Nucleoside. Okay. Now, students, can I ask all of you a very simple question? Ready, all of you? All of you can answer. Ready, students? Students, can I start? Right now? I ask all of you one simple question. Okay. What is the difference between DNA and RNA? Anyone? Difference between DNA and RNA. If someone says the full form, I will hit you now. What is the difference between DNA and RNA? Do not tell. Sir, DNA is deoxyribonucleic acid, RNA is ribonucleic acid. I am not asking the full form. Okay. I'll make the question even more specific in nature. Okay. What is the difference between DNA and RNA with respect to the sugar molecule? Anyone? With respect to sugar molecule, students, quickly in the chat. With respect to sugar molecule. Quick. With respect to sugar molecule, what is the difference? Don't worry, bro. Don't worry. Chill. With respect to sugar molecule, what is the difference between your DNA and RNA? Students, very simple difference. If you look at your sugar molecule, pentose sugar can be ribose sugar and deoxyribose sugar. Deoxyribose sugar. Now, what is the meaning of D? D means remove. Oxygen. Removing oxygen is called as deoxy. D means remove. Oxy means oxygen. Deoxy means removal of oxygen. If you look at your deoxyribose sugar in your DNA, deoxyribonucleic acid, in the second carbon, someone is missing here. Someone went to get milk here, okay, didn't come back. So in the second carbon here, we can see one oxygen is missing here. Tata, bye-bye. Okay. Now at the same time in the ribose we can see one oxygen is present here. Okay. So in second carbon ribose sugar oxygen is present. In deoxyribose second carbon oxygen is missing. That is all. That is all, students. Okay. Spot the difference. Spot the difference game we can play. Okay. Spot the difference game. Nice. That is a difference. Okay. Now all of you know there is something called as your nitrogenous bases: adenine, guanine, cytosine, thymine, uracil. This much all of you should know, right? This much all of you should know, right? Adenine, guanine, cytosine, thymine, uracil, ATGC. Now anyone can tell me, students, who is forming a bond here? This much all of you should tell me who is forming a bond here. Okay, who is forming a bond? Adenine is forming a bond with, students. ATGC. This much all of you should tell me. Yes or no. This much you should know. Okay. This much all of you should know, students. So if you learn all this, everything has become so easy. MBA, exactly. MBA has become so easy after this. Okay. All of you, MBA, right? MBA becomes so easy. Now, students, this is what everyone understands, that what is purine and pyrimidine. Okay. What is purine and pyrimidine? I reply to comments, bro. Chill. Okay. Right. What is purine and pyrimidine now? Purine, pyrimidine. Understand the difference. Okay. There is something called as gold as pure. A small thing is gold as pure. Gold as pure. Okay. So in purines, what happens is we have two different purines here. We have guanine, G for guanine, and A for adenine. Gold as pure. So purines we have guanines and adenine. These are the two different nitrogen bases here. Okay, guanine and adenine. Okay, purines. Now, what about pyrimidines? In pyrimidine we have three. Then here we do something called as cut pyramid. Cut the pyramid. Okay, pyramid. Here C stands for your cytosine, U stands for uracil, T stands for thymine. That is your three pyrimidines and two purines. Now, students, here there was a very famous question. Okay. Which of the following are double ring structures? Which of the following are double ring structure? See, if you see, students, if you look at all the pyrimidines, all of them are single ring. But if you look at the purines, they are double ring structure. Now, I will ask all of you a very simple question. Okay. Which of the following are double ring structure? I'll give you four options: guanine, cytosine, thymine, uracil. Guanine, thymine, cytosine, uracil. Which of the following are double ring structure? In the chat, answer in the chat. Answer in the chat quickly. Guanine is going to be the answer. So this is a very famous question. You can easily understand this by looking at the structure of your purines and pyrimidines. Okay. Yes. Believe in yourself. Self-belief. Okay, students. So again, I'll tell you. Purines, we have two of them. Pyrimidines, we have three of them. Gold as pure, guanine and adenine. Cut pyramid, cut is going to be CUT, cytosine, uracil, thymine. Cut pyramid. Done, students. Done. Okay. Nitrogen, nucleoside, done. Now, students, this one I will not teach in detail right now. Right, this will not teach in detail. That is something called as phosphodiester bond. Right. It's an ester bond formed between the phosphate group of one nucleotide and other nucleotide. That is, it is a bond present between two nucleotides. It is a 5' to 3' bond. This Gopika ma'am will teach you in detail later on today. Okay, we can see here 3' to 5. You can see bond here, 3' to 5' bond here. Gopika ma'am will draw and show you this today. Okay, so don't worry, you learn this bond. So right now, all of you should need to remember that between two amino acids, peptide bond is there. Between two nucleotides, we have your phosphodiester bond. Okay, phosphodiester bond. Okay, students, Gopika ma'am will teach them, right? Gopika ma'am, did Gopika ma'am leave already? I think Gopika ma'am left. Gopika ma'am was in the chat, but she left right now. So I think Gopika ma'am will teach you this entire thing. So don't worry today. She'll try and teach you this. Okay, now students, DNA, RNA also very simple. All of you know, right? DNA, RNA. In DNA is double stranded, RNA is single stranded. Here we have thymine, cytosine, adenine, guanine. Here we have, instead of thymine, we have the uracil here. Simple. You have ribose sugar, deoxyribose sugar. One oxygen is missing here. Okay, one oxygen is missing. So what we learned till now, students? Till now we learned about your amino acids. We learned the entire different types of amino acids. Glycerol we learned. Triglyceride, I told you, 3 different places, 3 fatty acids. Cholesterol is a derived one. Lecithin is a phospholipid. Lecithin is a phospholipid right here. Can all of you see, students? Here we have purine. See, always remember adenine, adenosine. Difference is there. Difference is there. Okay. Now, here you can see this is a nucleoside here. Nucleosides. When you say nucleoside, you write uridine. So, if you have uracil, if it is a nucleoside, you write uridine. If it is a nucleotide, you write eic acid. So, you can see the suffix is changing here. The suffix is changing here. Suffix here is for nucleoside is ine. Okay. For nucleotide, it is eic acid, lic acid it is here. Okay. So, suffix is changing for nucleoside and nucleotide. Okay. So, you can see here adenine, nitrogenous base, adenosine, adenylic acid. So, based on the suffix, you can find if it is a nucleotide or nucleoside. Okay. Now, students, after this concept, I'll give you a small break. Okay, students, after this concept of metabolites, I'll give you a small break. Okay, I'll give you a small break after metabolites. Okay, students. Okay. All of you students, after this, I'll give you a small break. I'll give you a small lunch break also. Okay, not lunch break, students. Snacks break. I'll give you snacks break. Okay, after this. Now, understand, students, understand what is the metabolite. Okay. Especially in the case of plants, right? Plants produce 2 types of chemical substances. Something called as primary metabolite. Primary metabolite is used by the plants for their growth directly. It could be carbohydrates, lipids, proteins, nucleic acids. Similar to us, they are also using it. That is called as primary metabolites. Now, students, there is something called as your secondary metabolites. Now, the secondary metabolites are produced by the plants for defense mechanism, for any type of protection. Okay, that is called as secondary metabolites. Now, they are not involved in growth, but they are very important for the plant. It could be the color pigments, alkaloids, rubber, antibiotics, gums, essential oils, scents, and spices. All of them are called as secondary metabolites. They are produced as a defense mechanism. Now, can anyone tell me, students? I'll ask all of you a simple question now. Tell me which is a secondary metabolite produced in calotropis for defense mechanism. Ecology. I'm connecting this to ecology now. I'm connecting this to ecology right now. Tell me, students, which is the chemical substance produced by calotropis for defense mechanism? Cardiac glycoside. Cardiac glycoside. That is a PYQ. Okay. So I hope you remember ecology also. I hope you remember ecology very well. Okay. Okay, students. Cardiac glycoside. Now, students, here is the list of all the secondary metabolites. So this you should remember it even if you forget your name also. Even if you forget your name, this you should remember. For example, pigments, we have carotenoids, anthocyanin, there. Alkaloids, morphine and codeine. Morphine, you know, na, it is used for the drugs for sedation. Codeine is used in cough syrup. Terpenoids, monoterpenes, diterpenes. Essential oils, you know, essential oils. People use that, no, essential oils. They use that in face pack. No, nice. They add essential oil in your bathtub. Rich people, bathtub, they sleep in that nicely. Okay. So lemongrass oil and everything. Toxin, arbutin and ricin. Students, how many of you watched a series called as Breaking Bad? If you watch a series called as Breaking Bad, in the series Breaking Bad, he used something called as ricin. That is a toxin, the ricin. Okay. Concanavalin is a type of lectin. Okay. Concanavalin is also type of your chemical which can induce M phase, mitosis and meiosis. Okay. Drugs, vinblastine and curcumin longa. Vinblastine is a cancer. It can reduce the cancer. Okay, anti-cancerous property. It can be produced from a plant called as vinca rosa. Okay, vinca rosa. Curcumin from a curcumin longa, turmeric. Okay, rubber, gum and cellulose. So all of these are different types of your secondary metabolites. You have to remember them. Okay. Okay, students. Now, before I go, students, I will ask you one simple question. Okay, you watch a CID. Okay. Students, tell me, Arbrin is what? Arbrin is which type of secondary metabolite? Quickly in the chat, students. Insomnia is you cannot sleep. Hallucination is you see things which are not seen. Okay, you see things which are not seen only by others. Hallucination. Insomnia is lack of sleep. You can't sleep at all. Dark circles, full dark circles. You'll become Baba Black Sheep also. Dark circles. Raccoon, you'll become raccoon. It's a type of toxin. Okay. Concanavalin A. Concanavalin A is which type of secondary metabolite? Concanavalin A is which type of secondary metabolite? Quickly. Hallucination, students. Imagine you see a wall. On the wall, you can see eyes popping up. Very scary it is. Very scary. Concanavalin A is what? Concanavalin A is a lectin. So you should remember this. They can make you do something called as match the following here. Match the following here. Okay, students. Now, before I start secondary metabolite, I'll give you a small break. What's the time right now, students? Time right now is 11:55. I will give you a break for 15 minutes. Okay. We'll start the class at 12:10 or 12:15 only. Class resume at all of you go, because I have also not eaten my breakfast, students. I'll go eat my breakfast now. I forgot to eat my breakfast today. I was preparing all this for you. I was trying to prepare all the examples for you, right? I didn't eat my breakfast only. So I'll go eat my breakfast and come back. So all of you also eat something and come back. Okay, so nicely eat, come. So we need ATP, right? Energy, we need ATP. Okay, so we'll resume the class at 12:15. Okay? Okay. Okay, students. Thankfully, I've never got sleep paralysis, students. Sleep paralysis next level. Students, 4 more likes quickly. By the time I come back, cool, students. Okay, so I'll come back now. Okay, so we'll see again back all of you at 12:15. Okay, students. So bye bye, students. I'll go eat and come. All of you also eat and come. Okay. Okay. Bye, students. Bye bye.
Students, let me just drop a message. Let me just drop a message in your Telegram so that people will know that we are back. One second, students. One second. Let's go, students. Let's go. Hello, everyone. Hello. Welcome back, students. Welcome back. All of you. Hello. All of you, break done. All of you ate something and came. Namaste. Yes, namaste. All of you. Namaste. Yes. All of you ate something and came. Sir, do you have a Discord group? Yes, I have a Discord group. Why will I share you my Discord? I don't have a personal Discord. I have a gaming Discord. That's all. Yes. Students, can we start now, all of you? Can I get some fire emoji in the chat and we can start going now? All of you. Can I get some fire emoji in the chat to know that yes, sir, we are ready now. We shall go and start now carbohydrates now. All of you. Can we start, students? Can we start? Carbohydrates. What are carbohydrates? Carbohydrates are nothing but hydrates. They are nothing but hydrates of your carbon. And we have mainly two types here, which all of us know, right? Glucose, all of you know, and fructose, you know. Here we have aldehyde group, here we have ketone group. Aldehyde and a ketone group can be present there, right? So these are your carbohydrates. Now, students, there is something called as classification of carbohydrate. Now, this classification of carbohydrate is mainly based on the number of monomers. See, all of you know what is a monomer. Repeating unit called as monomer. If it has only one monomer, what is it called as? If there are two monomers, what is it called as? Three monomers, one more name is there. Okay. Now, understand, all of you understand. If there is a single monomer, simplest carbohydrate forms the building block of large carbohydrates. If there is a single, only one, like all of you, single carbohydrate, it is called as your monosaccharide. Mono here means one. Single saccharide. Okay. Examples are given here. You can see the examples here. Single monosaccharide. Okay. Now, what is a disaccharide? Di means two, saccharide means sugar unit. If there are two sugar units here joined together by a glycosidic bond, that is called as your disaccharide. For example, all of you know, sucrose is a disaccharide. Sucrose is made up of glucose plus fructose. Here. So two different monosaccharides are joined together by a glycosidic bond here. By a glycosidic bond, not Fevicol. Glycosidic bond here. Glycosidic bond is present between them. Now, one more thing, lactose, all of you know, milk, lactose, it is present. Milk is a disaccharide. It is made up of something called as glucose plus galactose. Again, between glucose and galactose, in between we have the glycosidic bond present between them. Okay, monosaccharides. Then there is oligosaccharide. Oligosaccharide is what? 3 to 9 monomeric units. And finally, we have the polysaccharides. Poly means what, students? Poly means many. Many of you are watching. Poly. So polysaccharide, many repeating sugar units, one after one. It's like a long chain. You might have seen, right? Long chain in front of your famous Pani Puri people. Like, when someone is giving Pani Puri, the long chain is there, right? In front of your government bank, the long chain will be there. If you go to passport office, long chain is there, like, right? So the long chain is called as polysaccharide. Long chain is called as polysaccharide. Now, students, here you need to understand here is that in polysaccharide, it can be broadly classified into two categories. Polysaccharides can be classified broadly into two categories. Okay. First one is called as homopolysaccharide. First one is called as what? Homopolysaccharides. Other one is called as heteropolysaccharide. Heteropolysaccharide. Now, what is the meaning here? The meaning of homo is that homo means same, like Homo sapiens, right? Same. Here, in the case of homopolysaccharide, same type of repeating units are there. Yes, Pani Puri students, Pani Puri chain they play now nowadays. Pani Puri people also become like, attitude, bro, attitude. I don't know what attitude they have now. Next level attitude. Like I feel they're giving me one, and you have to notice students how they do it nowadays. You think they'll give it to you. The puri will come towards you, almost towards you, they'll bait you, and they'll take it away from you and give it to the next person. I'm like, what, bro? I'm waiting here. Okay, next level attitude they have now, Pani Puri people. Okay, so in homopolysaccharide, what happens? Homo means same, polysaccharide means poly means many, saccharide means sugar units. So same sugar units. I'll give you a simple example here. Okay, every single time you stand in a line, right? You stand in a line, right? You stand in a line, you're nicely standing, right? Or what happens is sometimes you wear color uniform. Some of you use color in school used to have color uniform, right? Red color, blue color, green color, color. Yes. So if I make all of you, all red color people stand in one line, red house one side, green house one side, blue house one side, pink house one side. There's no pink, I'm just saying it. There's no pink house. Never. Okay. There is red, blue, green, yellow. Yellow house one side. So all of you wearing same color, homopolysaccharide. Now what if I take one from blue house, one from red house, one from green house, one from yellow house? Now that becomes what? That becomes heteropolysaccharide. Hetero means different. Hetero means different. Different polysaccharides. All of you understood, students? All of you understood? Nice. Now in homopolysaccharide, students, there are two main categories. Homopolysaccharide. Okay. First one is called as structural. Second is called as storage. Now under structural, the example is going to be, you have two examples. First example is cellulose. Second example is going to be chitin. Can anyone tell me, students, chitin is present in where? Which organism do we find chitin as the exoskeleton? Quickly, students. No. Storage, we have starch as well as inulin, as well as one, no space only. I'll write here. We have glycogen also. So under storage we have starch, inulin, not insulin again. Inulin and your glycogen. Okay, glycogen. How many glucogen I have written? Glycogen. Okay, so under structural we have cellulose and chitin here. Chitin, you might fungus you could have seen. Okay. Now heteropolysaccharide. Under heteropolysaccharide we have two examples. One is called as a peptidoglycan. Other one is agar-agar. Can anyone tell me, students, if from which algae do we get agar-agar? Anyone who can tell me? Which? Not insulin, bro. Inulin, not insulin. Inulin. Okay, inulin is different. There is no S here. S is missing. Okay, so peptidoglycan as well as agar-agar. Okay, now peptidoglycan again, students. Why do I call it as hetero? Means it is made up of NAG and NAM, N-acetylglucosamine and acetylmuramic acid. They'll not ask you that. They'll not ask you. Just remember this much. Peptidoglycan is heteropolysaccharide. Agar-agar is also heteropolysaccharide. Red algae, exactly. Chilidium and Gracilaria. Oh, very smart all of you are. Huh? Very smart. Extra smart. Huh? You will get extra marks today from my side. Okay. So students, all of you can remember this. Structural, storage, heteropolysaccharide, peptidoglycan. And here we have agar-agar. Okay, agar-agar. Okay, students. See here, starch present as a polymer of glucose, food reservoir in plants, consists of amylopectin and amylose. Glycogen, polymer of glucose, reserve food material in animals, highly branched, stored in liver and muscles. Now, can anyone tell me the difference between? Starch and glycogen with respect to structure? Biomolecules, class 12th, chemistry. Can anyone tell me, students, what is the structural difference between between your glycogen and starch? See, starch found in plants, glycogen animals. Apart from that, students, structurally they are different. How are they different? See, in the case of starch, we have something called as amylopectin and amylose. Amylose generally has alpha 1,4 linkage and amylopectin has alpha 1,6 linkage. while glycogen also has alpha 1,6 linkage, right? Glycogen also has alpha 1,6 linkage. But the difference here is that in glycogen what happens is the branching is many. There is a frequency of branching is more. The frequency of branching is more here. Alpha 1,6 linkage is more here. That is glycogen. If you don't remember, I'll complain to Diksha ma'am. Okay, if you don't remember, I'll tell to Diksha ma'am. Diksha ma'am teaches them biomolecules very soon as possible. Okay. Now students, what is inulin? Inulin is a polymer of fructose. PYQ alert. PYQ alert. Polymer of fructose. Not metabolized human body, stored in dahlia, dandelions and artichoke. It is found in your plants, in the case of plants. Okay. Cellulose, polymer of glucose again. Chitin is a polymer of N-acetyl glucosamine. Polymer of N-acetyl glucosamine. Now again students, tell me, is chitin homopolysaccharide or heteropolysaccharide? Chitin is a homopolysaccharide or heteropolysaccharide? Quickly students. Yes, blackmailing. Quick. Your chitin is heteropolysaccharide or hetero or poly? Hetero or homo? Chitin is going to be, students, I'm teaching, see it's written here, just see this once. All of you see this once. Once you see this on top, what is written? Just see this, what is written on top. All of you. Students, I want everyone to zoom your eyes 10x now. See what is written here. Plant walls are made up of cellulose, paper made from plant pulp and cotton fibers, cellulosic. There are more complex polysaccharides in nature. The polysaccharides are complex polysaccharides. They are building blocks, amino acids and chemically modified sugars. Glucosamine, N-acetyl-glucosamine. Exoskeleton. See here we can write peptidoglycan is complex. Cellulose is complex here. Right. Exoskeleton of arthropods. Exoskeleton of arthropods, for example, have a complex polysaccharide called as chitin. These polysaccharides are mostly, what students? All of you just read this once. Try reading it. If you know alphabets, just try reading this one more time. Try reading this. All of you. Read now. Tell me what is this. Quickly. It says homopolysaccharide. From where did you get hetero? You tell me first of all, students. From where did you find hetero? You tell me now. From where did you find hetero? You tell me now. I want to know. I want to know from where. Who told you heteropolysaccharide? I don't never told. Huh? I don't never told. So again I'll ask you. I will ask you one more time. Tell me students. Tell me again. Chitin is a homo heteropolysaccharide. Quickly. How much? It's written here on this. Second semester student can tell this. Tell me students. Tell me. What is the answer? Your chitin is going to be homopolysaccharide. Okay. Oh my God. Now, it is found where exoskeleton of arthropods. Remember that. It is a complex polysaccharide. Okay. Now, this you don't have to remember. Don't worry. They'll not ask you this. I will. If I ask you, you'll not tell me. Okay. So, peptidoglycan is made up of NAG and NAM. Agar-agar is made up of galactose as well as 3,6 anhydro L-galactopyranose. Don't have to remember this. Don't. Just remember the examples. Heteropolysaccharide is peptidoglycan as well as agar-agar. This much you can remember, right? This much you can remember, no? Brain cells are not braining only today. All of you are sleeping. All of you listening to a podcast, not learning. Okay. Now understand the next concept. Next concept is going to be something called as reducing sugar. Okay. Next thing is going to be something called as reducing sugar. Ready, all of you? Ready to learn? Oh God. What will I do with all of you students? Huh? What will I do with all of you if you're like this? Tell me now. Ready? Not visible. Huh? Zoom your brain. You zoom next time. Next time you zoom your brain. Ready, all of you? Now, understand what is reducing sugar. Now, all of you have done this. All of you have heard about Benedict solution. Tell me yes or no. First of all, Benedict solution in somewhere in chemistry lab. When you're trying to put some powder in your copper sulfate powder in your pocket and running away, you might have seen Benedict solution. You might have seen there Benedict solution. Okay. So what exactly happens here in the reducing sugar is that you have to do a small experiment here. Very simple experiment. 2 ml of your glucose if you take, same 2 ml of Benedict solution also you should add. Okay. 2 ml of glucose, 2 ml of Benedict solution you should add. Okay. Then what happens? You can get brick red color you can get. What exactly happening here? There is something called reducing sugar. Reducing sugars are the sugars that mostly monosaccharides which has a free aldehyde. They have what? Free aldehyde or free ketone group. They have a free aldehyde or a free ketone group they have. Okay, free aldehyde and free ketone group. Those are called as reducing sugar. So reducing sugar has free aldehyde and free ketone group. Clear? Clear, students, clear. Now what exactly is happening in this reaction? Reducing sugars reduce the cupric ions to cuprous ions. So cupric to cuprous is happening and that's why we get brick red color. That's all. Very simple. Monosaccharides, reducing sugar. Reducing sugar. What are non-reducing sugar? Non-reducing sugars, no free aldehyde or ketone group. All polysaccharides and sucrose are non-reducing sugar. So please remember this. Drill in your mind now only. Drill. Polysaccharides, sucrose are non-reducing sugar. Please remember this. Okay. Now, so polysaccharides have reducing, non-reducing and reducing end. Both are present. Okay. Now, students. Now, now I'll teach you a small concept called as iodine test for starch. You might have seen nowadays, right? You might have seen in reels and all. People are going and checking fake paneer. How many have seen? Students, how many of you seen that? Nowadays, people are running around, these food influencers. They will go to one person, they'll ask, is your paneer real paneer? They're like, sir, mine is real paneer. They're like, can we test it? They will add iodine top of your paneer. Right? If it is a pure paneer, it will not change color. If it is pure paneer, it will not change color. If it is a fake paneer, in fake paneer, what is there? In fake paneer, there is something called as starch is present. In fake paneer, they add starch. They add starch and they're giving you fake paneer. As no paneer, pretending it's not paneer. What they do is they take starch and they make a mixture of it and they'll give it to you. So please be careful when you're going out nowadays to eat paneer in the restaurants. Many cases they're giving fake paneer to all of you. Same, we will understand how are they testing if it is a fake or real paneer now. Understand? Okay. So you take an iodine solution, you take a sample contains starch now. Same, you take one more iodine solution. In iodine solution, this iodine solution, you add cellulose. Now what is the difference? The difference is the structure. If you look at a starch structure, it has something called as helicals. Okay. Here in cellulose, we do not have any helicals here. Now all of you tell me, students, okay. Now let's take one example. I will take our bold. We will take our bold. We will experiment bold now. Bold. Okay. Now we are making bold stand there. Okay. We are tying his hands. Assuming he is a boy. Okay. We'll tie his hands properly. Okay. Now tell me, students. Now I will take a ball and I will throw it at bold. What does he do, students? He has two things he can do. Ball is coming, he is not doing anything. Late reaction, ball on the face, gone. First option. Second is what? His reflex is very fast. He will bend and the ball will go. Okay. Consciousness is there. Okay. If there is no consciousness, it's hitting on the face. Okay. Now, students, in second scenario, I am not tying the hands. Hands are free now. And let's say our board is like Virat Kohli or Glenn Phillips. He is very good at fielding now. Very good fielding. Now I will take one ball. I will throw the ball at him. Can he catch the ball now? He will catch the ball. Same concept to apply here. Here what is happening? In the case of starch, hands are free. Now can they hold iodine, students, tell me? Can they hold iodine now? Can they hold iodine? They can hold iodine. If they can hold iodine, we get blue color. So in the case of your fake paneer, we get blue color it becomes. Okay. Now what about in this case of cellulose? Cellulose is a condition where I'm tying the hands. Nothing to do. Okay, so what is happening here? Here what happens is cellulose does not contain complex helicals, hence does not hold I2 molecules. It cannot hold I2 molecules, and that is why we get what? Negative brown color. Negative brown color. So when you do a test, Paniron test, it should be brown color. It should not become change the color. It should not change the color. Okay, all of you clear, students? All of you understand? So in starch, what is happening? Cellulose, what is happening? Here we get blue color because there are hands are free to catch the iodine. Hands are not free here. Simple as it gets. Students' answers are seen by mistake. Students' answers are seen by mistake. Students, imagine the answer is not seen here. Tell me the answer now. Try to imagine there is no answer here. You tell me the answer now. Cellulose does not hold blue color with iodine because it cannot hold iodine because it does not contain complex helicals and hence cannot hold iodine molecule. Cannot hold iodine molecule. Okay. There's no point in showing, students. Inulin is a fructose polymer. Chitin is present in exoskeleton. Done, students. Done. Okay. That is done, students. That is done. Now, there is something called as functions of proteins. There are multiple functions of proteins here. Okay. Functions of proteins here. Okay. Now, understand here. Okay. You're coming late to the class. I see everything. Okay, but I don't tell. Okay. See here, students. Collagen, intracellular ground substance. Nowadays, you might have seen people add collagen to the face also. I don't know why collagen mask comes nowadays. I don't know if you have heard about it. It's because collagen mask now. Okay. Trypsin is an enzyme. Insulin is a hormone. Antibodies fight against infections. Receptors GLUT4 enables glucose transport into the cell. So there are multiple functions of your proteins. So proteins can have multiple functions. Okay. A protein can have what? Multiple functions. This you have to remember. This you have to remember. Okay. Because students, if you don't remember, this is how you can get a question. No, this is not the question. Question is missing, students. Question is missing. Okay. Now, students, with that, let's go to the next concept that is called, we finished this, right? We finished polysaccharides. We finished polysaccharides today already. We finished the iodine concept. Cellulose does not hold iodine. Concept is done. We finished this also. We finished nucleic acids, adenine, guanine, all that. I didn't teach you this concept, no? So this I'll teach you later on, don't worry, this I'll teach you later on. Okay. Now, students, can we start with structure of protein now? Students, can we start now? Can we start? Structure of proteins now. Now we'll learn the structure of protein, how the protein is made, like what is present in proteins. Okay. Now I will start the structure of protein with the help of a simple question. How many of you know what is translation? How many of you know what is translation, students? Quickly in the chat. How many of you know what is translation? What do I mean by translation? Quickly, students, quickly. Translation. Translation is a process where we get proteins. Okay. Now, whenever translation has occurred, which protein do you think we get here? Do we get primary structure, secondary structure, tertiary, quaternary? Which one do you get as a result of translation? Okay. Translation, students. Okay. As a result of translation, right? As a result of translation, what happens is, okay, students, now RNA to protein, exactly. As a result of translation, we always get primary protein. As a result of translation, we always get the primary structure of protein. Now there's primary structure, secondary, tertiary, quaternary. Now one by one you understand now what do you mean by each one of the following. Okay. Now this is primary structure. In primary structure of protein, we get a single line of amino acids. Amino acids are present in a straight chain here, and from this primary structure of amino acid, we get to know at which position which amino acid is present. For example, students, by primary structure of protein, I can tell 1, 2, 3, 4, 5, 6, 7. Okay, I have 7 amino acid. In third one, let's say I have your leucine is present here, isoleucine is present here, right? Methionine is present here. So by primary structure of protein, we can tell which amino acid is present where. Okay, which amino acid is present where, we can tell with the help of primary structure. Okay, now here major bond is going to be hydrogen bond here. Hydrogen bond. Next we have second structure protein. In second structure protein, now we are giving it a shape. Starting we had a straight chain. Now we're like, we don't like the straight chain. Let's make something very fancy now. So what do? We twist and turn the protein chain now. There is something called as alpha helix where we turn the protein, and there is a beta plated sheets. In beta plated sheets, we do zigzag motion of the protein. I'll show you exactly what is happening here. Okay. And here students understand again, here also hydrogen bonding is very evident here. Intramolecular and intermolecular, both hydrogen bonding can be seen in respectively. Okay. Then we have tertiary structure. Now what is happening in tertiary, understand. Students, how do you eat rice and sambar? Students, see, I don't like to mix my rice and sambar full. What I do is, when I take rice separately, I take sambar separately. Whenever, how much ever I want to eat, that much I mix. Okay. Now imagine there's a plate of rice and sambar. Okay. There's one plate of rice and sambar is here. Okay. Let's take this side, I have my rice. Rice is here. And this side I have my sambar. Okay. Sambar. Okay. Now what is happening here, understand. Let's take this part is gonna be alpha helix. This is beta plated, like your rice and sambar. Okay. Now what is happening? What is happening in your tertiary structure is that this rice and this sambar, nicely it is becoming one round good day. Okay, I don't know what is good day. Good day means one hump it is becoming, one ball it is becoming. Okay, so take a rice, take sambar, nicely mix it and make one ball. That is your tertiary structure. In tertiary structure, what is happening is alpha helix and beta plated are nicely mixed up now. Nicely mixed up and you get a ball. That is called as tertiary structure of protein. Here we can see disulfide bonds also present. We can also see certain ionic bonds here. Okay, weak van der Waals forces can be seen here. And also it provides a 3D structure to the protein, and most of the biomolecules, active biomolecules are present. Most of the bioactive enzymes are present in this stage. Enzymes are present in this stage. Okay, then we have quaternary structure. What is quaternary, students? What is quaternary? Understand. Okay, in quaternary what is happening is, same, we have one more plate like this. Let's say we have one more plate here. In this plate, what we do is, after mixing rice and sambar, we make one round ball. No, we make one round ball like this. Okay. Similarly, you from one more plate. Okay, let's take this is the Ravindrani's plate. This is Ravindrani's plate. Okay. Let's take, we have one more plate here. Someone's plate. Someone else's plate is here. In this plate also, we make rice and sambar mix. We mix here again. And we bring it to this plate. Similarly, students, in the case of your quaternary structures, in quaternary structures, all the different tertiary structures are coming together. Here, multiple tertiary are coming together and making quaternary structure. One ball from here, one from here, nicely mixing it and making one big bowl. Okay, that is quaternary structure here. Can you see, all of you see here? That you can clearly see here. This part is one separate, this part is one separate. This is one tertiary, this is one tertiary. Two tertiaries coming together, quaternary we get. Quaternary. Students, more easy than this, I can't even teach more easy than this. All of you understood, students? All of you understood? How am I? I am doing great. Students, understood all of you? Yes? In the end, it became a khichdi here. In the end, it became a khichdi here. Okay, and all of you understood? Nice. That is how it should be. Okay, that is tertiary. Now I'll give you more information what you can write in exam also. Okay, understand. Okay, primary structure, linear chain represents the position of amino acid. I can tell which amino acid is present where. I can tell here. Okay, here we have N terminal and C terminal. Why it is called N terminal? It is called as N terminal because free amino group here. It is called a C terminal because free carboxyl group here. C terminal. Okay. Alpha helix, beta plated. This is alpha helix structure, beta plated. Like you're folding the paper here, folding the paper. Okay. This is a tertiary structure. Can you see woolen ball? Nice khichdi, nice ball you're making here. Rice and sambar ball. Biologically active, protein fold itself, 3D structure. Here you can see disulfide bond. We can see quaternary. Two or more polypeptide chains. See, we can see one peptide chain, one more peptide chain. Two peptide chains are coming together here. Here each one is a subunit. Imagine one tertiary is coming, one more tertiary is coming, joined together. Each one becomes a subunit. One subunit, second subunit becomes. Okay. Example is hemoglobin. Example is going to be hemoglobin. Hemoglobin is an example of tertiary structure. Hemoglobin is example of tertiary structure. Here we can see 2 alpha chains here and 2 beta chains here. We can see 2 alpha chains here and 2 beta chains here. 2 alpha and 2 beta chains are present here. Okay? Okay, students. This we finished. Students, I'm giving you some NCERT lines so you can read it once. Yes, I will not read now. It's very easy. It's understood now. Nature of bonds. All of you know, in the case of protein, right? In the case of protein, what bond do we have? Peptide bond in the case of proteins can be found here. Okay. Glycosidic bond between carbohydrates. Okay. Phosphodiester bond, students. Where do we see phosphodiester bond? Anyone who can tell me? Any smart person in the chat? Where do we get phosphodiester bond? Anyone? Between 2 nucleotides. Okay. Now, students. Now, there are multiple functions of proteins I told you. Structural, contractile, nutrient, regulatory, defense, transport, GLUT4, but catalytic also is there. Now, students will mainly focus on this thing right here. Catalytic right here. We'll mainly focus on catalytic right now. Okay, catalytic. Now, students, we come to the last, one of the last main concept of this chapter called as your enzyme action. Can we start, students? Can we start, all of you? Can we start? Last part of this chapter. Okay, from here 30 to 40 minutes chapter is over. 30 to 40 minutes chapter is over now. Okay, can we start, students? Can I get the same energy from all of you? Are all of you getting bored already? There is so much to study. Are you getting bored? If you're getting bored, also you have to study. Don't have an option. As if you have an option. As if you have an option. Like, sir, I'm getting bored, I'm not studying. You don't have an option. What to do? Right, you don't have an option also. Shall we start, all of you? Shall we start? Yes. Students, smash your like button, all of you, quickly. Smash your like button right now, quickly, all of you. And we'll start. Okay. Now we'll start something called as catalyst. Okay. Can anyone tell me, students, a catalyst, will it increase the rate of reaction or decrease the rate of reaction? Anyone in the chat who can tell me. What will a catalyst do, students? Will a catalyst increase the rate of reaction or decrease? Okay. Increase or decrease? Catalyst is a substance which can alter the rate of reaction. It can alter the rate of reaction. That is, it can increase the rate of reaction or it can decrease the rate of reaction. Both possibilities is there. It can increase or decrease. Okay, it can increase or decrease, both are possible. Not just decrease or increase, both can be possible. Okay, now students, understand. Here, catalysts are mainly of 2 types. Catalysts are mainly of 2 types here. Okay, understand, all of you, understand. Okay, first one is called as inorganic catalyst. Inorganic catalyst and organic catalyst. Inorganic and organic catalyst. What is inorganic catalyst? Understand. Inorganic catalyst, obviously it's inorganic, and example is going to be platinum. Platinum is an example. This is used in your traditional chemistry use. In your chemistry, use it. Now, organic catalyst, students. Organic catalysts are the catalysts which are found in your living organisms. In your living organisms. Example, I'll give you. Example, they are also called as enzymes. They are called as what, students? Enzymes. So if I tell you, students, what exactly is your enzyme? Enzyme is nothing but, students, enzyme is nothing but biocatalyst. So I can call enzymes as, students, biocatalyst. Biocatalyst. catalyst are nothing but enzyme. You can give any example. Trypsin, invertase, any enzyme you can give example here. Okay, example you can give you here. Okay. Now students. Now we learn about enzymes. Enzymes again now. So okay, anyone tell me students, what are enzymes made up of, students? Are enzymes made up of proteins? Yes or no, students, tell me. Enzymes are basically made up of proteins. But there is an exception here. Except the ribozyme. Except the ribozyme. Because ribozyme is a RNA enzyme. Ribozyme is a RNA enzyme. Ribozyme. Okay, students. Now again, these enzymes are highly specific in action. Highly specific in action. What do I mean by that? What do I mean by highly specific in action? Here, imagine there's one lock, one key. One key will open only one lock. That's how specific it is there. Randomly, any key cannot open any lock here. One key has one lock. Okay, there's not multiple keys also here. One key, one lock. Highly specific in action. Highly specific in action, students. And they need a aqueous medium. They need a aqueous medium to function generally. Aqueous medium. Okay. What is function generally? Okay, students. Now, students, I will show you what before I teach you active site. Okay. I'll teach you active site, then I'll show you the animation. Students, do you want to see animation for this? Do you want to see a visual representation for this? Visual representation for your entire enzyme action? I will show you today. I will show you. Okay. But before that, understand what is an active site. Okay. If you remember, students, this ball structure of your protein. This ball structure of protein, students. There was something called as a ball structure of protein. All of you remember? Students, tell me, was this primary, secondary, tertiary? What was this? This was your tertiary structure of protein. Okay. Now, in this tertiary structure of protein, students, there can be certain gaps here. There can be certain gap. They are called as crevices or grooves, or whatever you can call it, gaps here. Now, inside this gap right here, inside this gap, this right here is called as your active site. Active site. Here mainly there is a functional group. There is a functional group here, and everything can come and join here. So this is an enzyme. A substrate will come and join here. A substrate will come and join. So this is a small confusion which everyone has, is that, sir, does the enzyme join the substrate or the substrate joins the enzyme? How many of you have this confusion? Does the enzyme join the substrate or the substrate is joining the enzyme? How many of you have this confusion? Tell me in the chat quickly, students. How many of you have this confusion? What binds to what? Because I'll make it clear to you right now. If you want, I can make it clear to you, all of you. What is binding what? Confusion is there? Okay. Now, students, you tell me, students. All of you tell me. Okay. Thinking of an example. Okay. All of you understand, students. Imagine all of your name is enzyme from now onwards. Okay. All of you are what, students? Enzymes. All of your enzymes. Now, if you are enzyme, you are sitting and eating biryani. Is the biryani coming to you or are you going towards biryani? Tell me in the chat, students. Quickly, students. All of you. Yes, I will tell anyway. Obviously, you don't have an option. If you're in my class, even if I ask you a question, I will tell you the answer. If you are the enzyme, biryani is a substrate. Biryani is a substrate, you tell me. You are the enzyme, biryani is a substrate. Is the biryani coming towards you to eat or are you going to eat the biryani like that downs? If you're very hungry, then you can go. But generally what happens is, when you're sitting and eating, the biryani is coming to you, right? You are eating the biryani like that. Okay, so substrate is coming and binding to the enzyme. So you are the enzyme. Okay, you are the enzyme right now. Biryani is coming to you and joining in your mouth. Okay, you are sitting randomly. Imagine you're sitting randomly and the biryani is coming to you. Okay, so that is called a simple concept of your enzyme substrate. You will not go biryani. There are chances of that also happening, but think logically, student. Think logically. Okay. Now that is what is happening here. Okay, that is what is happening here, students. Now, students, I am telling enzyme that. I am telling you, enzyme is this much, enzyme is that, enzyme is this. But what actually is the power of enzyme? Understand power of enzyme. Okay, understand the power of enzyme, students here. Okay, now see here. This particular reaction right here, without an enzyme, how long does it take? Without enzyme, this reaction right here will get 200 molecules of H2CO3 in 1 hour. In 1 hour, you will get 200 molecules of this particular thing. But if you add a catalyst like carbonic anhydrase, enzyme is added here. If enzyme is added, students, we will get, instead of 200 molecules, we will get 6 lakh molecules of H2CO3 in, students, H2CO3 in 1 hour, 1 hour, 1 minute, students, 1 minute. Tell me, students, quickly in the chat. 1 hour, 1 minute, 10 minutes. No. In 1 second. In 1 second. Here we were getting 200 molecules in 1 hour. But as soon as you add a catalyst, 6 lakh molecules in just 1 second you're getting. That is the change. That is the effect of the entire catalyst, students. Entire catalyst. Okay. Entire catalyst, students. Crazy, no? Crazy. This is what happens. This is what happens. Okay. Okay, students. That is the benefit of it. Now there's something called rate of reaction. Okay, rate of reaction can change. For example, if you heat, reaction will become double. If you decrease the temperature by 10 degrees Celsius, reaction becomes slow. Reaction, to increase the reaction, you have to heat the food. All of simple, all of you know. Reduce the reaction, temperature should reduce. Okay. Now, before we go to the enzyme, let me just show you the entire thing, what exactly happens here. I had this thing for all of you. Students, can all of you see the protein structure? Is visible to all of you? This right here, can you see? This is how the protein looks like. This is how the protein looks like. Can all of you see? This is a protein structure. Here can be a tertiary or quaternary structure. Okay, you can see, students, it has multiple chains. Can you see? Multiple chains are joined together. This is how a protein looks like. This is how a protein looks like in real. Okay, so please remember how a protein looks like. Now, students, now I will show you the entire process, what is happening here. Students, is the board visible to all of you now? Okay, see here, students. Now, what is happening here? This is your substrate. This is your active site. And this entire structure is called as what, students? What is the entire structure called as? This entire structure right here is the enzyme. This right here is the enzyme. So, an enzyme is like a lock. Enzyme is like a lock, or this enzyme is you right now. This enzyme is you right now. You are the enzyme right now. You are the enzyme. Okay. Now, where will the food enter through, students? Will the food enter through your nose, eyes, ears? No. The food will enter through what? The food will enter through the mouth only. Mouth. So this, imagine this active site is like your mouth. Active site is like your mouth, and this enzyme is you. Now this is your substrate. This is your substrate. Anyone tell me, students, the substrate is what? Biryani. This is biryani right now. Okay. Now biryani is coming and it is coming to you. Biryani is coming to you now. Now where will it bind? It will bind, right? It will bind to the entire enzyme. It will bind at the active site. Now this is called as enzyme substrate complex. It is called as what? Enzyme substrate complex. Here what is happening? Enzyme and substrate both are binding here. Now what happens? Then we get enzyme product complex. The substrate has been converted to product now. Now what happens later on? At the end of everything, enzyme is free, product is here, and this is called as enzyme product separate now. This is what happens in the entire enzyme reaction. In the entire enzyme reaction, students, what do we get actually? In the entire enzyme reaction, first is your enzyme plus substrate, then we get enzyme substrate complex, then we get enzyme product complex, then we get enzyme plus product, both are separate. This is how the entire reaction happens. All of you are clear on this? All of you clear on this, students? Clear on this? Tell me yes or no. All of you clear? Easy peasy, lemon squeezy? Yes. This is what happens in your entire enzyme reaction. Okay, enzyme reaction. Now, students, this is what I told you. Okay. Now, when this entire reaction is happening, right? Substrate 1, substrate 2. Before we get the product, here right in the middle, there is something called as an intermediate product here. This intermediate product here is nothing but also called as transition state. It is also called as what, students? Transition state here. Now, what you should note here is that, students, compared to substrate, this transition state is the right. Transition state has very high energy. It has transition state has very high energy. Now what happens here is that there is an average energy difference between substrate or reactant and intermediate state. That is called as something. Can anyone tell me what is that? That is called as activation energy. What is activation energy, students? Activation energy is nothing but, students, it is the average energy difference between reactants and transition state. The energy difference between reactants and the transition state is called activation energy. For example, see this. Here we have the substrate or reactant or substrate. Okay, reactant or substrate is here. Okay. Now here is the transition state. Tell me, students, which has more energy now? Does the substrate have more energy or transition state have more energy? Where do we have more energy, students? All of you tell me in the chat. Think logically and tell me, students, where do we have more energy right now? All of you tell me, sir. If you look at the potential energy scale here in the y-axis, we can see here that transition state has higher energy. Now this is a gap here. The energy difference between your transition state and substrate, the middle part is called as the activation energy. Okay, activation energy. Now, students, I want one volunteer from the chat. Quickly, one volunteer. This is always the most simple method. Okay, let's take myself only. We have one person here. Okay, we'll draw nice here. Okay, we have one person here. Okay, we have one person right here. Okay, Goku. Okay, now, students, this human, right? Now he is trying to run and jump a high jump. Okay, this is the high jump. This much high jump. Okay. If this is not Goku, if it is normal human, students, can he jump over it? Let's say this is around 10 feet. This is 100 feet. It is 100 feet tall. Can this person jump over it now and land this side? Students, tell me. Yes or no, tell me. Not possible at all. Okay, not possible at all. Now what will we do is, students? Okay. Now we'll call him Raju. Okay. Now Raju can't jump over it. Now what do we do is, a friend is coming here when no one is looking. when no one is looking, this friend silently is reducing the bar to this much. Bar this much now. Bar reduced now. This is, let's say this is around now 2 feet tall. 2 feet tall. Or let's say 1 feet tall. Okay. 1 feet tall. 1 feet tall. Now Raju can easily jump over. Yes. Now Raju can easily jump over this. Jump over this. So there was a decrease in bar now. There was a decrease in bar right now. Decrease in bar. Now students understand what did we do here. Same concept applies here also. When substrate has to become product, there is a large big barrier here. Big barrier called as your transition state energy. Okay. Transition state energy. Now students, without activation energy, without enzyme, this is activation energy. Now one friend is coming and reducing the entire bar. You know, the friend here is none other than the enzyme. With the help of enzyme, the entire bar is reduced now. This much the activation energy. Now the energy difference between substrate and transition state is very less now. Very less difference. Less difference now. Less difference. So this substrate can now easily become the product. It can easily become the product right now. Clear, students? All of you clear on that? What happens? All of you understood what happens? This friend enzyme is coming and reducing the activation energy. You can jump over it and become not easily. That's all is the concept. That is all is the concept here. Concept. Okay. Now, see here. Reactant, product here easily. Okay, students. Now, what is the difference between endothermic and exothermic reaction? Understand difference. In case of endothermic reaction, what happens? In the case of endothermic reaction, reactants have less energy compared to product. So what will happen in the case of endothermic? Students, tell me. In endothermic, is energy absorbed or energy released? Can anyone tell me? In case of your endothermic reaction, is the energy absorbed or is the energy released? Tell me in the chat, students. Tell me in the chat. You will tell me, sir, in the case of endothermic, energy is absorbed. So energy is absorbed here. Energy is absorbed. If whenever energy is absorbed, it can reaction can happen. That is why it's called as endothermic reaction, because reactants have very low energy here. Endothermic. Now, what do you mean by exothermic? In exothermic, what happens? In exothermic, heat is released. Energy is released here. So here, since reactants have a lot of energy, the energy is now released out. Energy is released out and we get the products. That is the difference between your endothermic and exothermic reaction. All of you. Now, students. What is happening here, students? The entire mechanism is written one more time. Let's read this one more time. Let's read it. First, substrate binds to active site of the enzyme, fitting into active site. All of you remember this, students? All of you remember this? First, what happens? First, substrate will come and join with the enzyme at active site. Now, initially when it is joining there, it is not joining very properly. Like it is joining. Now, what happens later on? After some time, it will join very tightly. Now, it will join. Okay. See here. The binding of substrate induces enzyme to alter the shape, fitting more tightly around the substrate eventually. The active site of the enzyme now is in close proximity of the substrate, breaks the chemical bonds of the substrate, and new enzyme product complex is formed. Okay, so the substrate is broken down, substrate is utilized, and we get the product eventually. Okay, that's what happens here. Okay, students. Now there's something called as factors affecting enzyme activity. Temperature, pH, substrate concentration, enzyme concentration. There are multiple factors which influence the enzyme activity. Like for example, temperature. Right? All of you know, enzymes are basically proteins. If temperature goes very high, all the proteins will denature. If temperature becomes very low, all the proteins will stop working. Enzymes will stop working. Temperature. Okay. Same goes for pH also. High pH, nothing will happen. Low pH, nothing will happen. So for enzyme to function, students, we need something called as optimum temperature and optimum what? pH. At the optimum temperature, optimum pH, everything can work very peacefully, students. Everything can work very peacefully. Okay. Okay, students. Optimum temperature and optimum pH. Yes, except Taq polymerase. Now students, I will teach you the concentration concept of your substrate concentration. Based on substrate concentration and enzyme concentration, how does the reaction change? Ready, all of you? Ready. Now again, I will teach you the concept of biryani theory here now. I will teach you biryani theory here now. Okay. Now for example, I will call all of you tomorrow to my house. Okay. I will tell students, tomorrow in my house full party, I will give all of you biryani party at my house. Biryani party at my house tomorrow. So all of you are invited to my house. Okay. Now students, now listen to the concept. Now all of you are like, okay, sir is giving me biryani today. Morning, I will not eat breakfast. I will come directly to sir house. Okay. So I will not eat breakfast. I will directly come to sir's house to eat biryani. Okay. So all of you are sitting in my house now to eat biryani. All of you are sitting in line. All of you are sitting in line right now, ready to eat biryani now. Okay. Now what happens? See, initially what is happening? I told students, what is your name, all of you? The students tell me, what is your name right now? Tell me, your name right now is enzyme. Your name right now is enzyme right now. All of your enzyme. Yes, all of your enzymes. So all of you are hungry right now? Hungry. Okay. Now what will I do? I will give you all of you. I will give all of you some one plate biryani. Some of you be like, sir, this was very nice. I am full. But some of you are like, sir, one plate is not enough. I want 2 plates. Okay, I'll give you 2 plates. After 2 plates, some of you will be very full. But after 2 plates, I'm very heavy. I'm full done, sir, now. But some of you are still like, no, sir, I need more. Finally, I'll give you 10 kg biryani. Okay. At the end of it, at least at the end of it, all of you will be full. All of you will be full. Same concept to apply here also. All of your enzymes. Substrate is the biryani. So initially, some of you are empty. Now what happened? In first plate, one of you became empty. Remaining all of you are still hungry. So I increase the substrate. It means from 1 plate biryani, I go to 2 plate biryani. So I feel now by this time at least, some of you are full, but some are still hungry. Some are still hungry here. So what do I do now? I increase the concentration one more time. 10 kg biryani here. 10 kg. I'm like, go enjoy. Full party now. By the end of 10 kg biryani, students, all your stomachs are full right now. Now you tell me, students, even after giving 10 kg biryani, if I give you more, can you still eat? Can you still eat? Can you still eat after that? Tell me, students. You can't eat after that. Not possible. You cannot eat after 10 kgs. It means you are saturated. Now what is happening is, students, as I increase the substrate, rate of reaction is increasing starting. So I'm increasing the substrate here, rate of reaction is increasing. I am increasing substrate concentration more, rate of reaction is increasing. But after one point right now here, how much ever substrate I increase after one point, there is no increase in rate of reaction. Initially you will increase, but after some time, saturation, stomach full. How much ever, if I open your mouth and put it inside also, take more biryani. You can't eat still. You're like, sir, vomit will come now. You can't eat more. Okay, that is what is happening at the end of it. Okay, so as the substrate concentration is increasing more and more, rate of reaction is increasing, but after a certain point, it cannot increase any further. Students. After you have to give up. After the students, you have to give up only. Okay, you have to give up only after that. Okay, students. Same concept also applies for your enzyme concentration also. Okay. Students, understood all of you? Understood? Tell me yes or no. Understanding or not? Tell me, students. So much examples I'm giving you. All of you understood how substrate concentration can change the rate of reaction. Initially it can increase, but after some time, saturation. Okay, students? Now students, now we'll understand something called as Vmax, half Vmax and Km value. Understand what is it? What is Vmax, students? Vmax is nothing but velocity at which all active sites are filled. How fast all of you are becoming full, basically. How fast all of you are becoming full. Okay. But Vmax is very difficult to find. Okay. So what do? We find half Vmax. Half Vmax is nothing but velocity at which half of the active sites are filled. That is called as half Vmax. Velocity at which half of the active sites are filled. Okay. Now, what do I mean by half? So, when you're eating biryani in my house, at one point, students, half of your stomach was full. Tell me yes or no. Students, tell me. At some point you realized, sir, half of my stomach is full. That is called as half Vmax. Now, students, understand what is Km value here. Km, Michaelis constant. Okay. Understand what is Michaelis constant. Now, students, you tell me, if one plate biryani is to make your full stomach full, to make half stomach full, how much of biryani do you need? Very simple question. Let's say one full plate biryani will fill your stomach. For stomach to fill half, right? How much of biryani should you eat? Half plate biryani, no. Half plate biryani is enough. Half plate biryani is enough to make half stomach filled. So Km value is nothing but students. Whenever your stomach was half full, how much biryani you ate that time? No. When your stomach was half full, right? When your stomach was half full, how much of biryani you ate that time? That becomes Km value. That becomes Km value. That is concentration of biryani. No. Concentration of substrate. Concentration of substrate at half Vmax. So at half Vmax, how much substrate is needed, right? That becomes Km value. That becomes Km value. Okay. So when your stomach was half full, how much biryani you ate that time? That becomes Km value. So students, tell me, what is your Km value in the chat, all of you? Tell me, students, how much of biryani should you eat to make your stomach half full? Tell me, students, how much of biryani should you eat to make your stomach half full? Tell me your capacity now. Tell me. Some of you will be like, sir, I need 2 plates to make my Km value is 2 plate. My Km value is half plate. My Km value is 1 plate biryani. I need to make even my stomach half. Okay. So that is your Km value. Michaelis constant. Understood, all of you? Understood? Wow. What is the Km value, students? Two kg. Oh, who is the 2 kg? 2 kg Km value. Next level. So you need 4 kg now. You need 4 kg to make your Vmax. You need 4 kg to make Vmax. Okay. Understood? 1/4 plate enough. So for you, half kg biryani is enough to make full plate, full stomach. Students, are you getting the concept? Forget biryani, all that, right? If your biryani is only to make you connect and learn. All of you understand the concept or not? Tell me, students. Concept you're understanding. This is the substrate concentration is increasing. Vmax is full velocity at which everything is filled. Half Vmax, half is filled. At that half Vmax, at this half Vmax, how much of substrate is used? That is called as Km value. Very simple to understand, right? Now, students, I'll teach you something called as inhibitors now. Ready, all of you? Ready? Now, students, do you want to learn this way or do you want to learn with the help of animations? Tell me, students, in the chat quickly. Students, let me tell you again. This Km value, Vmax, half Vmax, students don't understand because they think it's very difficult to understand. It is not. It is so easy. Okay. Do you want animation or do you want to learn simply now? Tell me in the chat quickly. Animations or without animations? Quick, all of you. Animations? Okay, give me a minute then. Students, there is something called as inhibitors. Understand, there is something called as inhibitors now. There are 3 types of inhibitors. 3 types of inhibitors are there. Okay. What is the inhibitor first of all? Inhibitor is a substance which will stop the chemical reaction. or stop the enzyme reaction basically. It's like enzyme reaction is happening, it will come from nowhere and it will stop the reaction. Stop the reaction. There are three types called as competitive, non-competitive, uncompetitive. Students, tell me in the chat, students, how many of you find it difficult to remember this? How many of you feel that, sir, I cannot understand this? What is competitive, uncompetitive, non-competitive? How many of you find it difficult to understand? If you find it difficult, now I will teach you the most easiest way. Understand, students, understand. What is competitive first of all? See this animation. So, substrate, inhibitor. Instead of substrate going and joining, inhibitor is coming and joining. Okay. Instead of substrate going and joining, what is happening? Your inhibitor is coming and joining. And the scam part is here is that substrate and inhibitor both look alike. Both of them looking alike. Okay. Imagine there are two twins. Imagine the two twins. Instead of one twin going and writing the exam, the other twin who has studied everything, he'll go write the exam. Okay. So this is the substrate. Substrate is here. Instead of your enzyme going and binding, inhibitor is binding, and we get inhibitor, competitive inhibitor. So what do we do get here? Your competitive inhibitor resembles the substrate, competes with the substrate for the active site. So what is happening here is inhibitor is going and joining, and we get inhibitor enzyme complex here. Substrate is not coming and join. Your substrate is not able to join. Substrate is not able to join. How many of you understood? How many of you raise your hands? How many of you understood, students? Instead of substrate going and joining, inhibitor is going and joining now. That is called as competitive inhibitor. That is called as competitive inhibitor. Okay. Here there is an example also. The example here I'll tell you later on, students. I'll tell you. I'll write and show you. I'll write and show you, students. Okay. Second you see. Next one you see. Second is called as non-competitive. Okay. Non-competitive inhibitor is binds at the site other than the active site. Katappa, backstab it is doing here. Backstab. Okay. Change the shape of the active site such that substrate is not able to bind. Can bind to free enzyme or enzyme complex. See this. See the animation also. See the animation. Okay. First we have substrate inhibitor. Inhibitor will go and join other side. Change the shape. This cannot bind anymore. Cannot bind anymore. That's all. And all of you understood? It is not competing from behind, it is going. Changing the shape here. Now this cannot bind here anymore. And this non-competitive can bind to, it doesn't matter if enzyme is there or enzyme is not there. Okay. That is called as your non-competitive. Now what is uncompetitive? This is next level. Next level this is. See this. This starting not bind. Okay. It will wait. This is your uncompetitive is biggest backstabber than Katappa also. Uncompetitive will wait nicely. Like it will wait for the two people to join. It will wait in a corner, it will be standing. It will stand in a corner and it will keep seeing. As soon as they form a bond, as soon as substrate and enzyme, they're forming a bond, this will come from somewhere and break the bond. See this. All of you see the animation now. See the animation. It cannot bind to free enzyme. See, it cannot bind to free enzyme. Well, what is happening is, see, students. This is the inhibitor. It cannot bind starting. It cannot bind. Not able to bind. So it will wait now. It will wait. Once they form a bond, it will join and push it apart. Push it apart. That is called as uncompetitive. That is called as uncompetitive, students. Uncompetitive. So I hope all of you are able to understand the difference between competitive, non-competitive, uncompetitive now. Tell me yes or no. Friends, tell me yes or no, students, quickly in the chat. Tell me yes or quickly, students, tell me yes or no. Yes or no. Okay. Now competitive example is going to be succinate becoming fumarate. Succinate to fumarate. The enzyme here is succinate dehydrogenase. Succinate dehydrogenase. Okay. Now this is your substrate. This is substrate. This substrate is going and binding here. Substrate is going binding here. Okay. Now what is happening is, students, we have a evil twin here. The evil twin who looks like succinate is called as malonate. It is called as malonate. Now this malonate right now will go and bind with succinate. This malonate will go and bind with the succinate dehydrogenase, and this will not be able to bind. So inhibitor is going and able to join to succinate dehydrogenase. That is the example given here. That is the example given here, students. Okay. This is done, students. I finished everything. I finished everything. See, this is the question. See, the question comes like this. Malonate inhibits the growth of pathogenic bacteria by inhibiting the activity of what, students? This. Inhibiting the activity of succinate dehydrogenase. It is stopping the succinate dehydrogenase to function. Your succinate is not able to bind here. Succinate is not able to bind here at all. Okay, students. Students, this they will not ask you nomenclature. It's very simple. Nomenclature they don't ask usually, right? Thousands of enzymes have been discovered, isolated and studied. Most of these enzymes have been classified into different groups based on their reaction and they catalyze. Enzymes are divided into 6 classes. There are 6 classes. Sorry. 6 classes are there. 4 to 13 subclasses here. Can you see? Oxidoreductase or dehydrogenase is there. What or normal oxidation? Then there is hydrolase type. Right? There is a transferase is there. What is happening in transferase? If S and G is there, S is there. S will form a bond with here and G will be removed out. That is transferase. Hydrolase is there. Right? Enzymes catalyze the hydrolase of ester, ether and peptide glycoside. Okay. Then there is lyase enzyme. In lyase what happens? Right? There is double bond formation is happening directly. Okay. Like this you can read on your own. This is very easy. Isomerase, all of you know. Same but different. Ligase is joining together. This you can read on your own. It is not very difficult at all. You have to remember the examples, that's all. Okay. Now, but what I have to teach you is the last topic today. 5 minutes will be done, students. 5 minutes will be done right now. Last topic for today is going to be your conjugate enzymes, or what is the meaning of apoenzyme, holoenzyme, as well as what is the cofactor. So students, can we start now? Last topic from my side. Can we start now? Last topic from my side, students. Can we start? Last topic from my side, students. Can we start? Yes, all of you. Students, don't run away. Ma'am is still coming. Don't run away anywhere. Can we start, students? Can we start? Last topic for today. Last topic. Yes. Let's go. Students, do you realize we started 10 o'clock, 10 to 11, 11 to 12, 12 to 1. Almost 3.5 hours. 3.5 hours we have done the chapter today. 3.5 hours. And that makes you realize how big the chapter is and how fast the time is going. Right? Students, how big the chapter is and how the time is going so fast. Okay. Yes, you can, students. We are going as detailed as possible. Okay. Now, understand, students, understand. There is something called as apoenzyme and there is something called as cofactor. Whenever there is only apoenzyme, it is biologically inactive. You are right now apoenzyme. Okay. You are apoenzyme without studying. Students, all of you right now are apoenzyme without studying right now. All of you are apoenzyme without studying. Okay. They are biologically inactive. This is cofactor, let's say, studies now. Cofactor is your studies. Okay. Once the cofactor is usually non-protein part, apoenzyme is protein part. So, apoenzyme is inactive, that is you. Studies is here, cofactor. Now, what will happen if I join them? If I join them together, we get a doctor. So, if you study, you'll become a doctor. Yes or no? So, apoenzyme plus cofactor, U plus studies is called as holoenzyme. Holoenzyme, apoenzyme plus cofactor, and when it becomes a holoenzyme, it is complete and biologically active. It is complete and it is biologically active here. That is your holoenzyme. So students, here remember, every enzyme needs a cofactor. Without cofactor, many enzymes can't even function at all. They can't function at all. So we need a cofactor. Okay, we need a cofactor here. So there are mainly 3 types of cofactors in your NCERT. 3 types: prosthetic groups, coenzyme, and metal ion. Students. Okay, first one is called as prosthetic group. First one is called as prosthetic group. prosthetic group. Second is called as your coenzyme. And last part is called as your metal ion. Metal ion. What is the difference? Understand, students. What is the difference? Okay. First come first serve. We'll do first prosthetic group. Prosthetic groups are organic in nature. Coenzyme are also organic in nature, while metal ions are inorganic in nature. Okay. Prosthetic groups are always, students, prosthetic groups are always tightly bound to a coenzyme. Tightly bound to a coenzyme. Coenzyme are loosely bound to the apoenzyme. They form coordination bond. Coordination bond at the active site. Okay. Now, example of prosthetic group. Example here is a very simple. The example of prosthetic group, students. Okay. H2O2. Hydrogen peroxide gets converted to H2O plus O2. That is, water and oxygen will separate out. Okay. Now here the enzyme involved here is called as peroxyoxidase. The enzyme involved here is, students, peroxidase enzyme. Now this is the apoenzyme here. This is the apoenzyme. In this apoenzyme there is a prosthetic group. The prosthetic group here is called as your heme. Heme is the prosthetic group here. Without heme, peroxidase is going to be incomplete. Without the prosthetic group, without the heme, peroxidase cannot function at all. That is the importance of heme. Okay. Now under cofactor we have NAD. We have the NAD, nicotinamide adenine dinucleotide, and NADP. Right? These are vitamins present in vitamins. Example is niacin. They need niacin here. Niacin. Okay. Now metal ions. Example is zinc. Zinc is a metal ion in the enzyme called as your carboxypeptidase. That's all, students. That's all. So cofactors, three types: prosthetic group, cofactor, metal ion, organic, inorganic, tightly bound, loosely bound, coordination compound. Example is going to be heme here. It's a cofactor for your peroxidase. Here NAD and NADPH are the cofactors here in many enzymes. Here zinc is a cofactor here. It is a type of metal ion. These are different types of cofactors which can be found here, students. If you can read this, you will know everything is here, students. See, coenzyme nicotinamide adenine dinucleotide and NADP contains vitamin niacin. Okay, vitamin niacin. And students, with that, my time is done for today, students. That's it for my time, students. Okay. Now Gopika ma'am will come. Ma'am will teach you something very special. I took almost 3.5 hours. Ma'am will take next 4 hours. Can you believe that, students? So students, tell me in the chat, are you up for it, or do we end the class here only? Do you want MBI or not? Students, do you want MBI or not, students? Yes or no? Yes, we'll give you case. Puri will give you case study series. Today I'm teaching you human reproduction. Puri, today I'm teaching you human reproduction in KCET also. Don't worry, today I'm coming there. Okay, students, do you want MBI or not? Or should we tell ma'am to stop? Should, like, ma'am, students don't want to study. They're crying already. Huh? Want, right? Do you realize how important chapter is? Do you realize how important MBI is? Whatever you learn in this chapter is the foundation for the chapter, students. Okay. So, can I call Gopika ma'am then? Can I call Gopika ma'am, students? Should I call? Yes? All of you want? Yes. I'll call Gopika ma'am, students. Wait.
Hello students, welcome to Vedantu NEET English. I am Ms. Gopika, your own biology master teacher. So welcome all of you to another session of molecular basis of inheritance. I know all of you are a little tired because you just completed a 3.5 hour class of biomolecules, right? Yes, can you see me and hear me clearly? Please let me know in the chats if I am audible, visible. Hello, everything is perfectly clear. Okay, so we thought we will give you a lunch break because I know all of my students are very tired and I do not want to teach molecular basis of inheritance with dehydrated brain, saturated brain. So take a lunch break, okay, take a lunch break and you have to come back, okay, without just by studying biomolecules you will not be able to write a 40 marks paper on molecular basis of inheritance. So lunch break, got it, resume at 2:10. Okay, you have a half an hour break, so finish your lunch and come back. Okay, yes, done, fine, come back after lunch. So see you all. Okay, go fast and come. After that, don't ask me break. So am I audible? Am I audible to all of you? And everything is perfect? Yes or no? Okay, let's start. I hope others also will join. Good afternoon. Okay. Just give me a minute, students. 1 second. Okay, ready? Chalo, let's start. Let me just call others also. Okay, some lazy people are there in the class. They don't want to study. They just want to do something. Okay, time pass. Time pass they want to do. Okay. By just, yeah, the series, yes, you can score really well, but don't trust only one series. There are so many other series that has happened. Okay. Okay. Okay, students. So once again, welcome all of you to Vedantu. Okay, welcome all of you to Vedantu NEET English. I am Ms. Gopika, your own biology master teacher. Those who are new to the channel, do not forget to subscribe to the channel and also smash that like button. We have a target of 500 likes, and I know you people are capable of doing that. So today we are going to do molecular basis of inheritance. So for those who do not know the weightage of molecular basis of inheritance, it is very sad that you don't know the weightage of this chapter. So molecular basis of inheritance has every single year at least 9 to 10 questions coming from this chapter, and people have a notion that the chapter is actually very difficult, but it is not that difficult if you understand every single topic with esteem clarity. Okay, so today what you're going to get the most is going to be clarity. And students, with clarity, I want all of you to promise that after this session you will go and revise this chapter thoroughly. Okay, you have to revise this chapter thoroughly. You have to read NCERT, because there are few things in NCERT that has to be understood as such. So let's directly get into the video. I will be doing the chapter in detail, making you understand every single thing. Okay, all you have to do is promise me to stay till the end. Once you have entered this class, you have joined with me, you have caught my hands, I will not let you leave the hands. Okay, I'm going to take you till the end of the session so you can get the entire marks. Okay, clear to all of you? Okay, yes, you can get, but 620 is a lot to expect from just one small series. So what you can do is you have to watch this series and you have to watch the question practice that we will be doing further. Okay, yes, okay, done. Okay, done. Now let's start. Okay, so what are the topics that we are going to do, students, today? We are going to do nucleic acid. We are going to understand the structure of a polynucleotide, experiments based on proving that if this is the genetic material, and mechanism of replication, transcription, genetic code, translation, lac operon, HGP and DNA fingerprinting. So these are the topics that we are going to understand. Okay, done. Okay, from this minute, all I need from you people is concentration. Nothing else. No talking to each other. Any doubt, ask me. Okay, yes. Session duration, we will try to finish the chapter in 3.5 hours maximum. Okay, I will be in a quite good speed. Okay, I will not be very fast, but I will make sure that you understand everything. Okay, chalo, let's start. Okay, so students, we start with molecular basis of inheritance. First of all, what is this? You all know that whenever we go and talk to people, or whenever we go to meet someone for the first time, they usually try to find the resemblance between us and our parents. Why does this happen? How are we so many characters, so many features of us is exactly like our parents? The main reason for this is we have someone who has all the information of a cell, and that information gets carried on from generation to generation. That is why people very casually tell you that, oh, you look exactly like your mother. You might not see the resemblance and you might not even like those statements, but they do see the resemblance, right? They do see the resemblance. So a molecule that has all the information, that is what you have to remember. A molecule that has all the information of the cell. Imagine that one cell, in that one cell, one person has all the information of the cell, okay, of the cell. And now, when we talk, okay, when we talk about discovery, 1 second students, yes, don't worry, okay, yes. So students, this all the information is going to be with one person, that is none other than your genetic material. Now, in this genetic material, what you have to study, you have to understand about nucleic acid. Okay, this genetic material that we talk about is none other than your nucleic acid. Ma'am, what is nucleic acid? The two nucleic acid, all of you tell me in the chat box, the two nucleic acid. Come on, quickly. The two nucleic acid that all of you have been studying and just studied biomolecules. So these things should be easier for you. That is why we took biomolecules and genetics. Usually no one does that combination, but we have done it. So your foundation is set and I can build the entire building on top of that. Okay, extremely. Okay, yes, very good. DNA and RNA. DNA and RNA. Now, when I talk about DNA and RNA, or when I talk about nucleic acid, you should understand the discovery of nucleic acid, right? Who discovered it? How did the whole process happen? So, students, nucleic acid was discovered by none other than your Friedrich Mischer. Okay, he was the one who found out nucleic acid. The best way to explain this is, students, most of you would have seen that, you know, your mom would have asked you to take something else. Okay, I always talk about this example. Your mom would have asked you from the fridge to take pudina and cup, and mom would have kept pudina in one Amul ka ice cream dabba. You would have gone and found some other, because our Indian homes will always have 200 Amul ka dabba, 200 Boost ka dabba, because we never throw anything, right? So you would have gone and taken something else, and by mistake, you would have seen the, the dessert, or you would have seen the cake that you kept like, a day ago, and you had forgotten about it. So that means what? By fluke, you ended up getting something that is really valuable for you. So same thing happened with Friedrich Mischer also. Friedrich Mischer was working on pus cells or WBC, and by fluke, we can say, he came up to a conclusion that he found nucleic acid. Okay, so he called that, okay, first it was not called nucleic acid, he called it nuclein. He called it what? He called it nuclein. And then another person called Altman. Who, students? Another person called Altman. He was like, wait, this nuclein that you're talking about actually has an acidic property. So why don't we call this nuclein, okay, as nucleic acid? So from nuclein, it became nucleic acid. And why was this made? Because he noticed that this nuclein had the presence, okay, presence of acidic nature. Understood? The presence of acidic nature, right? Okay, yes. Biomolecules will come after I finish this session. Okay, biomolecules will come after I finish this session. That is how YouTube works. Okay, that is how YouTube works. So students, because of the presence of that acidic nature, Altman called your nuclein as nucleic acid after Friedrich Mischer found it. Clear to all of you? Now, when we talk about DNA and RNA, since you now already studied it in biomolecules, you know what's the full form of these people, right? It is called deoxyribonucleic acid. Deoxyribonucleic acid. Any doubt in this? Now, from the terminology, what do you understand? Deoxy means they are lacking one oxygen, right? Absence of one oxygen group. That oxygen group is absent where, students? Where is it absent? In the sugar molecule, right? In the sugar molecule. So when we talk about absence of this oxygen, you have to remember where it is exactly absent, because you are going to write MCQs. You are not going to write long answers. So here, absence of oxygen means you are talking about the sugar molecule, and in that sugar molecule, the second carbon, okay, this is the second carbon. Let me label it on the top. This is the second carbon, and in that second carbon, there is the presence of this H. Okay, there is the presence of this H. Any doubt so far? Any doubt so far? Can you see this H? Yes? No oxygen. Okay? No oxygen. Clear? Yes? Now, when we go further about your RNA, about your RNA. RNA's full form is what? All of you in the chat box. I don't want this energy. I want the energy that you had in the morning. Okay, otherwise we are going to stop this long marathon. I want the energy as that in the morning. Clear? No, it's not like one class you're fully energetic, next class you're not energetic. Come on, quickly. So, RNA means what? Ma'am, RNA means ribose, right? Ribose nucleic acid. Ribonucleic acid. And this ribo, we talk about your ribose sugar. Okay, we talk about the ribose sugar. This notes you will be getting it on Vedantu NEET English Telegram as well as Biology by Gopika Telegram. You can join both the telegrams to get the notes, okay? So ribose sugar. Ma'am, what is this ribose sugar, ma'am? Obviously, I understand that here if there is something that was there, here there is something that is present. So here we go with the same diagram and here we understand in the 2 dash, okay? In the 2 dash, there is a presence of an OH group. There is a presence of an OH group which is not here. Clear to all of you? Entire introduction is clear. Entire introduction is clear. Done? Pakka? Yes. Okay, very good, very good. So this is the entire introduction of your chapter, that is your what is DNA, what is RNA. Now that you have already studied it in biomolecules, it's not going to be that hard for you to understand. Now students, when we talk about your nucleic acid, that is your DNA and RNA, we should understand the components that make the entire thing, right? You already understood that your DNA is deoxy, okay? Deoxyribonucleic acid, correct? Deoxyribonucleic acid. Let's just decode these words. Let's just decode this word to understand what are they talking about. So they are telling that your DNA is made up of something called as your nucleotide. Something called as your nucleotide, and nucleotide has components. All of you tell me, does nucleotide have components? Come on, quickly in the chat box. Quickly in the chat box. 1 second, students. Okay, yes. So, nucleotide, right? Nucleotide has components, and those components are how many of them? They have 3 components. They have 3 components. Got it? What are the 3 components, ma'am? The 3 components are a pentose sugar. All these words you are aware from your chemistry classes, now from biomolecules. Pentose sugar, nitrogenous base, and lastly, what do we have, students? Pentose sugar is there, nitrogen, so PNP, right? PNP, so phosphate group. Okay, phosphate group. Understood? So pentose sugar, nitrogenous base and phosphate group. Correct? This is exactly the 3 components that are present. These are the exact 3 components that are present. Now if I go into understanding each of the component, you will notice that pentose sugar, 2 types are there. What are they? Deoxy, okay, deoxy sugar and your ribose sugar. Okay, deoxy, ribose sugar and ribose sugar. Now from this term itself you understand ribose means what? Obviously you understand that in the second carbon they have a presence of an OH. Deoxy means in the second carbon the presence of H. And this H is not that simple. Okay, you will be like, oh, you Pavan, that fellow only has an H, this fellow has oxygen. That has actually come as a benefit. Why? Because you should understand, if you're talking about DNA and RNA, you should know that most of the organism, or let's say majority of the organism, have this as the genetic material. But on the other side, your RNA is genetic material only for a few organisms. Okay, few organisms, especially your viruses. Clear? Done. Majority of our organisms have DNA and very few organisms have RNA. So you shouldn't feel bad. You shouldn't feel bad that DNA has does not have that one oxygen group, because of which the DNA is more chemically and structurally stable. Okay. Now when you talk about nitrogenous base, students, what will you remember? You remember PP. Okay, you remember PP. Okay, nitrogenous base, you have two people, purines and pyrimidines. Today you are going to get a clarity that you have never got while studying this chapter. Let me tell you, that much clarity I will give you. Okay, purines and pyrimidines. Then when you talk of phosphate group is like, I don't want to complicate anything. I will just be simple PO4. Okay, I'll just be a simple PO4. Clear? Yes. Now students, ma'am, how do these people make this entire chain? So when you talk about DNA, students, when you talk about DNA, your DNA is something like this. Now how this is formed? How does this happen? This happened because of your nucleotide, many nucleotide attaching like this. Many nucleotide attaching like this to ultimately form your entire polynucleotide chain. Is this clear to all of you? Is this clear to all of you? So this entire thing ultimately made your polynucleotide. Understood? Poly means many, nucleotide means you know. Nucleotide means you know. Okay? Understood? Yes or no? Okay, Pavam is Malayalam word, yeah? Pavam is Malayalam word only. So entire DNA, we notice that many nucleotides, with the help of bonds, they form the polynucleotide. Okay, polynucleotide. Now you understood? Now you know this two DNA strands are complementary also, no one has doubt in that, you know, basic things. So this is understood. What is the components of your nucleic acid? What is the components of your nucleic acid? Now when we go later to understand the nitrogenous base, you will understand that what is different in RNA and DNA. Okay, RNA and DNA. Now moving forward, students, nitrogenous base you have to study a little more than you actually have it in NCERT. Okay, this chapter you have to study more because more is better. More is better. Clear? Chalo, let's do this. So nitrogenous base. Nitrogenous base. So nitrogenous base means what were the two things I told you? PP. Okay. PP, like that PP you remember, purines, okay, and pyrimidines. Purines and pyrimidines. Done. Now, purine students, name small, ring bigger. Name small, bigger actions. Have you seen people who are name is small, their actions are very bigger. Name is big, but no, not that much of an action. So purines here, you just now studied that these people are a 9-membered ring. Did you study this? Yes or no? You studied that these people are a 9-membered ring. Now this 9-membered ring, more than the 9-membered ring, what could come as a question point of view is that in this 9-membered ring, where are the nitrogen groups present? Where is the nitrogen groups present? Okay. Okay, where are the nitrogen groups present? That is the most important. So in this, okay, in this 9-membered ring, okay, in this 9-membered ring, you have to know which are the places where nitrogen is present. So what are the places? Come on, all of you in the charts. It's odd numbers. 1, 3, 7. Sorry. Yeah, 1, 3, 7, 9. The nitrogen groups are present. This is a question. Okay, it's a question. Done. Question small, answer big. Yes, something similar to that. Okay. Now, students, pyrimidine. Ma'am, name is so long, ma'am. Will that structure be that long? No. It is a 6-membered ring. It is a 6-membered ring, and since it is only 6, we have only spaces for 1, 3 nitrogen groups. Okay. 1, 3 nitrogen is present. So odd numbers you have to remember, and you have to remember 1, 3, 7, 9 has a nitrogen, 1, 3 nitrogen. Clear to all of you? Yes or no? But ma'am, you did not tell us only what is this purine and pyrimidine. You are telling about the shape, structure. You're not telling who these people are. Yes, let me go into making you understand who these people are. So students, when I'm talking about purine, you people already know the trick. Okay, you people already know the trick. Pure as gold. What is it? Pure as gold. My student's heart is pure as gold. Okay, pure as gold. P got cut, no? Okay, P got cut, no? So I'll write it the other side. Okay. So we call it pure as gold. Now P for obviously ma'am purine. A for adenine. Students, you can remember like this also. Adenine, 9 means 9-membered ring. Adenine, 9 means 9-membered ring. Okay. Then G for, don't write my name. I know you people like me, but still. Okay. Guanosine. Okay. Guanosine. So adenine, guanine. Okay. Sorry. Guanosine I wrote. Guanine. Okay. Guanine. Guanine. So adenine and guanine. Clear to all of you? Yes or no? Yes. Now, to remember your pyrimidine, okay, to remember your pyrimidine, you remember C-U-T, cut, C-U-T, C for cytosine, cytosine, U for uracil, and T for thymine, thymine. Now, a potential PYQ, okay, a potential PYQ. What is a potential PYQ? Ma'am, everything is a potential PYQ. No. The potential PYQ is in your pyrimidines. Okay, we just continue this. In your pyrimidines, your C, U, T are important, right? Yes, ma'am, C, U, T are important. So, they will ask you, cytosine is present in RNA or DNA or RNA and DNA. Tell me the answer for this. Cytosine is present in RNA. Option B, DNA. Option C, RNA and DNA. Come on, quickly. Let's see how many of you can answer. How many of you can answer? Yes, faster. Answer should come faster. Fast and furious answer should come. Or A, B, C. Just say A, B, C. A, B, C. Yes, very good. C is the answer, right? Cytosine is present, okay? Those who told mistake, you should understand that you have a lot to learn in this chapter. So, stay till the end. Cytosine, students, it is present both in DNA and RNA. Yes or no? C is going to be C. C is going to bind with G. That is going to remain. Right. But when you come to uracil, the question again comes. The same question comes. Uracil is present in DNA, RNA or DNA and RNA. Your answer will be this fellow is only present in RNA. This fellow is only present in RNA. Then when you come down, you understand thymine. Thymine. Again the same question comes, but your answer should be here DNA. So from this, what do you understand? You understand that thymine is replaced by uracil. Thymine is replaced by uracil in RNA. Okay, thymine is replaced by uracil in RNA. Clear to all of you? Yes or no? Did you understand? Okay, this is the main thing. Now, students, one more thing that you need to understand is this: where are these people present, ma'am? You keep telling DNA, DNA. So this is your DNA. Now, if I take this DNA like this, okay, if I take your DNA like this, okay, your DNA will be something like this. Now, where are these people present? Students, understand these people are present projecting inwards like this. Projecting inwards. In salient features, you will be studying this, but understand these people are projecting inwards. Done, done, done. All of you understood so far? Any doubts? Any doubts? Okay, now again doubt will come for you people. Ma'am, here you told that 2 people are present. Here you are telling 3 people are present. Now how do their bonding happen? So all of you know, according to your Chargaff rule, okay, ratio we will come into, but generally you have to understand purine and pyrimidine has to bind, make bond between each other. So how will the bonding happen? How will the bonding happen, students? The bonding is going to happen at Gopika ma'am's class. Yes, in my class it's going to happen. So at, okay, at, right, at separately. Gopika ma'am, Guru Dakshana should be inside, okay. Guru, what is that called? Guru, that this one, respect, okay, should be in your head. So write Gopika and write class. So at Gopika ma'am's class. Got it? Now, ma'am, what is this? Yes. Adenine will bind with thymine. Okay. Let's see if you remove. Yes. Adenine will bind with thymine with 2 hydrogen bonds. Guanine will bind with cytosine with 3 hydrogen bonds. Understood? So, at Gopika ma'am's class is going to be very important for you people. Okay, at Gopika ma'am's class is going to be very important for you people to remember. Done, done, done. Done, done, done. Any doubts so far? Yes, yes, very good. Okay, now let's go forward in understanding the bonds. Okay, in understanding the bonds. Now, students, before bonds, there's something more that you have to understand. Okay, what is that? That is, there's something called as nucleoside. Many students get confused with nucleoside and nucleotide. Ma'am, tide, ma'am, side, ma'am. Can't understand. So, students, nucleoside means pushing one person to the side. Nucleoside means pushing one person to the side. Whom will you push to one side? P and P, last P you push. That is not pentose, but you push the phosphate. Okay, I've always told this example also. In a trio, there's always a duo. So here also, nucleoside means you're pushing phosphate to one side, and that is exactly here what is happening. When a nitrogen base plus sugar makes a bond together, it will be called a nucleoside. Now, how do you spot a nucleoside? I gave you so many of them, and then NTA is given a match the following, and NTA is expecting you to identify the side and the tide. You don't know how to identify, okay? So here I will tell you how you can exactly identify. If the suffix is "-ine", that means it's a side. If a suffix is "-ine", that means it's a side. That means adenosine. That means this is what? A nucleoside. Clear to all of you? So this is how you will understand or spot a nucleoside and a tide, because they can give it in a box and they can expect you to answer. You are supposed to answer, right? Now, coming forward, you should understand a nitrogenous base, a sugar has already made a bond. Now, phosphate also is like, please, yeah, make me also part of this. So, phosphate also came in. So, we can call that nucleotide. No one is going to question us. We call it nucleotide. And how do you identify a nucleotide? With the help of 8, ATE. Okay. So, adenate, okay, adenylate, we tell, no? So, like that, at 8 is that. Now, students, one student is asking me, ma'am, why can't I call it nucleoside monophosphate? I was like, yeah, that is also correct. Why? Because this nitrogenous base, so students, it's like this, NB plus sugar. To that one phosphate is added. So, this is monophosphate. Okay, this is biphosphate, this is triphosphate. So, as and when the phosphate is adding, I can keep adding the monophosphate, triphosphate terminology. That is also right. Nucleoside, monophosphate, right? We will study later DNTP and all. When we study, you will understand that. So, is this clear to all of you? Okay, is this clear to all of you? Come on. All of you, tell me quickly. Okay. Yeah, 8 also, IC also we can use. Yes. Yes. Okay. Now we are going to learn about the bonding. Okay. We are going to learn about the bonding, because I kept saying that, okay, nucleoside is going to be formed, nucleotide is going to be formed. But I never told you how these people are going to make bonds. So listen to me carefully. If a nucleoside has to be formed, okay, if a nucleoside has to be formed, then there has to be a bond. Yes, ma'am. If two people have to come together, there should be a bond. So here you understand, students, a sugar molecule and a nitrogen base, if they are going to come together, the bond formed between them is an N-glycosidic linkage. What is it? An N-glycosidic linkage. If it is a purine, it will be 1-9 glycosidic linkage. That means the first carbon is going to bind with the 9th carbon. Understood? The first carbon is going to bind with the 9th carbon. Here comes one more question. Ma'am, why there is only in carbon, that means in ribose sugar or deoxyribose sugar, you have told 1-, 2-, 3-, 4- and 5-. Why not in pyrimidine or purine? That is, students, just to make the differentiation very clear, right? If here also it was 1-, here also it was 9-, it wouldn't be correct, because if there is a bonding with 1, then again it will be 1-. So to make the differentiation clear between nitrogenous base and sugar, we put a dash on the sugar. Clear? We put a dash on the sugar. Understood? Is it easy to understand? Now, moving forward, this sugar molecule has made a bond with your who? with your pyrimidine here or any nitrogenous base with the help of an N-glycosidic linkage. But phosphate also wants to come. Phosphate is like, even I want to make a bond. So phosphate will be coming, and then we will tell, okay, don't worry, you do one thing with the 5' carbon. This is the 5' carbon, okay, 1, 2, 3, 4, 5. With the CH2OH will be there, no? So with that, it will going to combine and make the bond. Now this 2 bond, that is between the sugar and the phosphate, will be called as phosphoester bond. Okay, clear? Yes? Okay, clear to all of you? Yes or no? Okay, now bonding is clear, no? Sugar, nitrogenous base, N-glycosidic linkage. Sugar, phosphate, phosphoester linkage. Now, ma'am, you told that many nucleotides together form polynucleotide chain. So, we have to understand, no, how many nucleotides are going to fuse. Yes, definitely we have to understand. Just look here, students. This is a pyrimidine, okay? Again, a sugar molecule. Same thing is continuing there. Now, look here. These two made N-glycosidic linkage, understood. These two made your phosphoester linkage, no problem. But also you have understood that your DNA runs anti-parallelly. That means if one is going from 5' to 3', another will go from 3' to 5'. Now, how do we know which is the 5' end and which is the 3' end? To understand that, okay, to understand that, here you should remember that, students, on the 5' end there is going to be a free phosphate. Why this free phosphate should be there? So that the, the binding, the bond formation can continue. Now, when you come down, you understand that in the 3', okay, 3', there is a free OH group. That 3 OH group is going to combine with the next nucleotide. So, between two nucleotides, there is going to be a bond. Okay, this is one nucleotide. Okay, so I am writing it here, nucleotide 1. Okay, nucleotide 1. Then there is another nucleotide, okay, N2. Now, between these two nucleotides, we have made a bond. That bond is called as phosphodiester bond. Phosphodiester bond. Clear to all of you? Yes or no? Phosphodiester bond. Clear? This is the bond between two nucleotides, and in your NCERT, clearly it is mentioned, we can call this dinucleotide. Dinucleotide. Like this, many nucleotides will combine together to form your polynucleotide chain. Okay, understood? So there should be a free OH for the bond formation to continue. Again from here, the OH will continue. Again from here, the bonds will continue. So on the 3' end, there is going to be a free OH group. Why this should be there? So the bonding can continue. Clear to all of you? Yes or no? Understood? Understood? Okay, the diagram might look complicated, but it is not that complicated. Okay, is this visible, students? Is this visible? Okay, I have just added the examples of your nucleoside and nucleotide so that in case a question comes, you will be able to answer. Okay, so look here, students, adenosine, okay, sign. Again, guanosine, cytidine, uridine, thymidine, INE is there. So it is a nucleoside. Now, if you move further and you understand adenosine monophosphate, AMP, guanosine monophosphate, GMP. So these are your, what is this? Your nucleotide. Okay, it is given ribonucleotide and ribonucleoside, because we have, so here it is in RNA, here it is in DNA. Is this clear to all of you? Deoxyadenosine monophosphate. Okay, clear? So 8 is coming, it is going to be tide, and ine is coming, it is going to be a side. That's all. If in case this question comes, you should be able to answer. You are in a position, you have understood it already. So bonding is clear. Any doubts in bonding? Any doubts in bonding? Any of you have? Please raise your hands. Now, salient features of DNA. Come on, anyone has doubt? N-glycosidic linkage, anything? So remember like this, a phosphate. Okay, a phosphate. If I draw a sugar molecule, it will be confusing. So let me draw a box. Okay, let me draw a box, sugar. Right, so this 2 bonding is going to happen. This is at the 5' end. Okay, this 2 bonding is going to happen. This is at the 1' end, and this is going to be with an NB. Okay, with an NB. So this bond is going to be called your phosphoester bond. Phosphoester ester bond, and this 2 bond is going to be called your N-glycosidic linkage. That's it. That's it. There's nothing to be confused. There's nothing to be confused or worried. Okay, understood? Now let's go to the salient features of DNA. Salient features of DNA, students, first of all, you write the salient feature of DNA is that your DNA is a double helical structure. Before you write that sugar plus phosphate. Sugar plus phosphate makes the backbone of DNA. Makes the what? Backbone of DNA. And the bases project inwards. Understood? This is the first point that you write. So I just told you that if this 2 is your DNA, I separate this DNA, who is going to make the backbone? The backbone is going to be made by your sugar plus phosphate. Okay, and who is going to project inside, students? Obviously, your bases are going to project inwards like this. Understood? Both the sides, bases are going to project inwards, and this is going to make the DNA stronger. Why? Because this bases have to make the bonds. Okay, the bonds are going to hold these 2 strands together. So the bases project inwards. Clear? Any doubts in this? Now, definitely you will go to the second point, that is your DNA is a double helical structure. DNA is a double helical structure. Now, double helical structure was found by whom? Double helical structure was found by 4 people mainly. Okay, 4 people mainly. What was their name, students? Watson. All of you answer. Watson. If you sit silently, you are not going to understand anything. Okay? Come on. This is MBI, da. Who is this girl? This is MBI. You missed biomolecules, you tell. Biomolecules will come after my class. Biomolecules will come after my class. Okay? So, students, Watson, Crick, okay, Wilkins, and Rosalind Franklin. These 4 people, with the help of X-ray diffraction, got it? With the help of X-ray diffraction, they came to a conclusion that our DNA is actually a double helical model. Okay, with the help of X-ray diffraction, they all understood the same. Actually, Wilkins and Rosalind Franklin started it. Watson and Crick also later found it out. With the help of X-ray diffraction, they came to a conclusion that this is a double helical structure. Okay? Yes? Clear? Clear? So, Watson, Crick, Wilkins and Rosalind came up with the model, and that is how we know DNA is a double helical structure. Then what do you know about DNA? You should know that the DNA is wound around in a right-handed fashion. Okay, and students, with that we also know that DNA is anti-parallel. Okay, anti-parallel polarity they have. Done? Done. All of you? Pakka? Okay, tell me about the turn, students. So, students, in this one turn, there will be 10 base pairs. Okay, one turn of the DNA will have 10 base pairs. Okay, and the pitch of the DNA is 3.4 angstrom. Okay, 3.4 nanometer. 3.4 nanometer. Done? Yes or no? Now, the distance between the base pairs can be understood by dividing these two. That is, you will get the distance between the base pairs is going to be 0.34 nanometer. How did you calculate this, ma'am? This divided by this. Correct? Anti-parallel means if one is running from 5' to 3', another is running from 3' to 5', and they're never going to intersect like this. They're never going to go like this. Yeah. So, I mean, they're anti-parallel. Okay. Parallel means what? Like this. Okay. These people are anti-parallel. Understood? They have anti-parallel polarity. Polarity. Yes, exactly. If one is going from 5' to 3', another one is going from 3' to 5'. Clear to all of you? Yes or no? Yes or no? Any doubts? Okay, moving forward. Moving forward. Okay. Yes. Now, here comes a very important topic where a direct question can come. Okay, not even very difficult, direct question can come. What is the direct question? Bacteriophage 5174 has 5386 nucleotides. Okay, students, many people find many tricks for this, but the problem with the trick is you will not remember the trick. Okay, that is the biggest problem with the trick, that you will not remember the trick. Correct? So, what we have to do is don't find any trick, just write and learn. 5386. Okay, phone numbers you remember, no? Many people like that only. Bacteriophage lambda students 4850. Now look here, this is base pair. This is nucleotide. Okay, that means this is happening what? This is SSRN. That means it's a single stranded DNA. Okay, single stranded DNA. Here it is double stranded DNA. That means here base pairing is happening. Here it is just nucleotide. So that means it's a single strand. Clear? Here 4.6 into 10 to the power 6, that is E. coli has 4 point. This is also a lot of times repeated topic. Okay, 4.6 into 10 to the power 6 base pairs. Haploid content. Now listen carefully. Haploid content of human DNA is going to be 3.3 into 10 to the power 9. Now give me the diploid content. If haploid content is so much, then give me the diploid content. All of you in the chats. Quickly. If haploid content is so much, then what is the diploid content? Faster, 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 faster. Faster, faster. Easy to remember, no? Easy, no? What do you have to do? Don't know, ma'am. Yes, very good, Dinesh. Very good. It's going to be 6.6. Right? It's going to be 6.6. Okay, that is the, many students make mistake. Many students make mistake. They'll think that, okay, they have given content of DNA, so wherever they ask diploid, they'll write haploid and keep. Wherever they ask haploid, these people will write diploid and keep. Understood? Abhishek, 1.5, how did you come to the conclusion that like that? Did you divide it by 2? Did you divide it by 2? Okay, next one is Chargaff rule. Okay, Chargaff rule. Now students, this is also a part of the salient features. In the last line of salient features, you can write this also. But I wanted to take it separately because many students, lot of problems come, numericals come from this. That is ratio of purine should be equal to the ratio of pyrimidine. That means what, students? If I am trying to pair, okay, let's take this is a classroom. This is a classroom and there are 2 boys, okay, 2 girls, okay, 2 girls. Now, if I am trying to pair, it is easy, ma'am. One, this boy, this girl, over. Okay, I made 2 pairs so that I want them for a dance program. Now, let's imagine the same scenario happens, but in a different classroom. Okay, different classroom. I want students for dance. Okay, 1, 2, 3 boys are there. Okay, but unfortunately, 2 girls are only there. Okay, girls have too much demand, so they didn't come. Okay, 2 girls are only there. Now, can the bonding happen? No, ma'am. This 2 pairs can be done, but this boy will be lonely, and so lonely, this boy will be left alone. Now, I don't want this to happen when I am talking about A binding with T and G binding with C. How many A is there? That many T should be there. How many G is there? That many C should be. Understood? If this is the rule, then only we will be able to have proper base pairing. Then only we will be able to have proper base pairing. Now what students confuse? Now what students confuse is they assume that A equals T ratio, okay, A equals T ratio should be equal to G equal to C ratio. Is it written anywhere that AT combination and GC combination should be the same? No. So they need not be equal. In the DNA itself, there are places where AT rich is there and there are places where GC rich is there. So it is not mandatory that A and T and G and C as a pair, they should be equal. Clear to all of you? Yes or no? Is it necessary that in this class also I should get the same amount of pair? this class also I should get the same amount of pair, or is it necessary that this pair dances exactly like this pair? Not necessary. The only thing necessary is the number of boys and the number of girls should be equal, so I can make the base pairing. Understood? Any doubts? Any doubts? Okay, this is what your Chargaff rule speaks about or talks about. Okay, now what kind of questions come from this topic, students? The question can be, if adenine, okay, if adenine is 20%, what is the percentage of cytosine? This is the question. This is the question. All of you answer this question. If adenine is 20%, what is the percentage of cytosine? This is the question. Okay? Yes. Answer the question, all of you. It'll be easy for you to. Yes. And what are we on the attendance? There's my phone. What's that attendance? Have we reached the target? Those who haven't liked the video, quickly like the video. Okay? So it gives us the motivation, and many students also will open. Okay, very good. Okay, let's do it for students who did not understand. Okay, see students, I just now told you, okay, how much adenine. So let's just write what is given to us and what is asked to us. So they told us adenine is 20% and they asked us to find cytosine, right? If adenine is 20%, I know thymine also will be 20% because A is equal to T. According to Chargaff rule, if adenine is 20%, then thymine is also going to be 20%. 20, 20, 40% happened. Then what is left after this? 60% is left, right? So they have asked cytosine. So 60 divided by 2 is how much? 30%. So if cytosine is 30%, then guanine also is going to be 30%, approximately making it a total of 100%. Clear to all of you? Okay? Yes or no? So this is how you will find it. Lot of questions can come on the similar basis from this topic. Okay? Now, packaging of DNA. Very easy topic, very simple topic. Recently only we studied under concept. So this topic also is going to be easy. What is packaging of DNA? Now students understand, it's a 2.2 meter DNA, right? Approximately 2.2 meter long DNA. Now if I have to put this 2.2 meter long DNA, okay, long DNA into a small nucleus, okay, inside a cell, okay, inside a cell, there is a small nucleus, right? A small, not even this big, it will be this much, right? It will be this much. Let's assume, okay, from the values given in your NCERT, 10 to the power minus 6. Okay, this small nucleus, I have to put this fellow. Will this fellow go in? Will this fellow go in? If I tell you, take a 2.2 meter rope and put it into one glass, you'll be like, ma'am, taking classes, you have become crazy or what? Right? You will also laugh at me. The same thing, students. Then body will obviously think of a solution, and that is when the body thought that, okay, if we are not able to put this DNA this way, let's bring some external forces. Who are the external forces that they bought? So for the packaging of DNA, they bought histone proteins. They bought whom, students? Histone proteins. Now tell me the charge of DNA. All of you know the charge of DNA is positive. So we had to bring someone who is, okay, sorry, the DNA is negative. So we had to bring someone who is positive. So we got positive. We got positive, right? So histone proteins positive, right? We got the positive proteins. Now we told the proteins, okay, you people come. Let's do packaging of DNA. So they were like, okay, fine, we are not going to just come as one. We are going to come, almost 5 people are going to come, okay? In that one person will have a different job. So they bought H2A, they bought H2B, they bought H3 and H4. So these 4 proteins came, okay, they were like, okay, fine. Then they bought one more fellow, that is H1 protein. They bought one more fellow who was the H1 protein. Okay, just give me 1 minute until I finish drawing this. Okay, we should be artistic whatever we do. Yes, students who are in Bangalore, don't forget 30th March we are meeting. Okay, we are meeting. So come to JP Nagar Vedantu Center. Fine? Yes, ma'am. Possible? Possible for all of you? One second. Let me just finish working on this. Okay, my artistic piece. Okay, done. So 4 circles you can see. Okay, 4 circles you can see. Now look here. These 4 people came, but then they were like, no, it's not enough. So what they did? They made 2 copies. Okay, they made 2 each. They duplicated. Okay, they duplicated, and now what happened, students? We got an octamer. What did we get? An octamer. What is an octamer? Maths you have studied. No, what's an octamer? That means 8 of them together. Okay, I'll come to Hyderabad. I know many of them has been calling me to Hyderabad. I feel I should come to Hyderabad. Okay, I will. If you people do really well in examination, I will have a chance to come and meet you all. Okay, yes. So this is what happened. They came, they duplicated. Now what happened, students? These became octamers. These became octamers. So can we label them? Yes, ma'am, we can label them. So I will call this H2A. I will call this H2B. I will call this H3. I will call this H4. Then you will be thinking, ma'am, where did your linker protein go? I will bring it. Okay, I'll bring it. So now let's assume that this DNA has to be wound around like this. Okay, wound around like this, and like this we are winding it. So can you see the DNA is going around? Yes, the DNA is going around. Now students, have you noticed whenever this flower, okay, the lady who ties the garland, the flower, mala we tell, no? She always ties a knot. After she keeps one flower like this, one flower like this, one flower like this, one flower like this, she ties a knot here. Right? Again she'll do here, one flower like this, one flower like this, one flower like this, one flower like this, she ties a knot. Why? So that the chain doesn't get loosened. The chain doesn't get loosened, right? So same thing happens here. To make sure that the entire, okay, this entire system stays intact, we put one protein which is called as your linker protein at the end, just to make sure that everything is staying intact. Clear to all of you? Understood the job of all of them? Understood the job of all of them? That is why we call this fellow as a H1 protein, or in other words we call it linker proteins. Linker proteins. Okay, linker proteins. Now these people, when they came, obviously these are proteins. They are made up of amino acids. So the basic amino acids, they are made up of basic amino acids, and in that the 2 amino acids which are rich is going to be lysine and arginine. Lysine and arginine. PYQ question. Okay, PYQ question. Okay, yes? Yes or no? Understood? Sir, PYQ. I think my voice is fine only. Just rejoin and see. For others, my voice is fine. Clear? Now with this method, I can easily put this genetic material, okay, put my DNA into this Kuti nucleus. Yes, ma'am, you can put it into this Kuti nucleus. Okay, so into this Kuti nucleus, I will be able to add this fellow. Understood? Like this, I will be able to add this fellow. Yes, fine. Is this clear? Any doubts in this? Any doubts in this? So we bought histone proteins who are positively charged. DNA is negatively charged, and this negatively charged DNA will bound around the positively charged protein because opposite charges attract. Now this histone proteins came as 5 people: H2A, H2B, H3, H4 and H1 protein. They made an octamer. Okay, so this is an octamer. Clear? This is an histone octamer. This is a histone octamer. Understood? Octamer means 8 in number. Okay, 8 in number. Now students, finally they ultimately made it. Okay, ultimately made it. Understood? Now the thing is here, how did all of this come together, right? All of this come together. So your 2.2 meter long DNA started wounding around, and students, when it is just the histone, I call it histone octamer. But they told me that no, you cannot do that. If it is histone octamer plus DNA, you call it a nucleosome. So I told them, okay, fine. So when a DNA wounds around a histone octamer, you call the entire thing a nucleosome, and one nucleosome can have around 200 base pairs. Again, a PYQ question. Again, a PYQ question. Okay? Clear to all of you? Yes or no? Yes or no? I don't think the voice is low. It's a normal voice. Students, it's a normal voice, students. Normal voice. Yes. This is the maximum voice. Okay? Yes. So, students, after that, what happened? This condensation happened. Can you see many histone octamer or the nucleosome have got condensed, and finally that is how you get to see your chromosome inside the nucleus. So, it is a part of condensation. So, before that they will form chromatin fibers, then from chromatin fibers they ultimately form your chromosomes. Now, two important things that you have to remember, okay, is that NHC, non-histone chromosomal protein. Okay, non-histone chromosomal protein. This non-histone chromosomal protein is actually used for hypercoiling. Hypercoiling. Correct? Students, others are facing an issue. 1 second. Mithun, is there a way to increase the voice? Yeah. Yay, I'm getting a new mic, students, because I called at the right time. Okay, 1 second, we will increase the voice.
Already I have removed it. इधर इधर ये इधर
I just got this mic. Yeah. You are the one who is just called at the right time.
Hello, 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 hello. Hello, students. Is it better?
Is it okay? I think it should be okay. No.
It's not okay, students.
Yeah, it's not okay, students. Is it okay, guys, now?
Where is the pin?
Pin is not there.
Nah.
Take
This one.
Give it. I'll take it out. Ask students.
Students, how is it? Your voice.
Better?
Can't see one second.
Oh, just that. Yeah, it's very loud. Loud and clear?
Okay. Yeah. Okay. Yeah, it's better, no? Yes. So say thanks to Mithun sir and Akshay sir. They came for rescue.
And this is a long bag as well.
Yeah. Okay.
Okay, guys.
Yes, students. Ready? Very clear? We got a new mic, students. Full clear. Okay. Shivani, better? Yes. So you tell the problem, we'll solve the problem. Okay. Yes. Okay. Now listen. Come here. HSC, students, it's a non-histone chromosomal protein. Ma'am, why do we need this non-histone chromosomal protein? For that additional coiling. Okay. So it is an additional set of protein which we use it for hypercoiling in higher organisms. Clear? Yes or no? Yes or no? Okay. Now moving forward to central dogma, we are going to start the actual chapter because the introduction of the chapter is over. Now we will actually start the thing. Okay, actually start the. I'm so sorry. I'm so sorry, students. Okay, the people who put earphones, we are very sorry for all of you. Okay, your pain and loss has been heard. Okay, now students look here. DNA's information has to be copied. Okay, has to be copied. To form, that copy has to happen in the RNA. From there, it has to form a protein which will ultimately do the job of what I was telling in the starting, called as inheritance, right? Inheritance. So here, what is going to happen? Okay, what is going to happen? DNA will become mRNA, and that process is called as transcription. That process is called as transcription. mRNA will become protein, and that process is called as translation. Okay, translation. Clear? Yes or no? Perfect. Okay. Now students, DNA can replicate, self-replicate. No, it can make its own copies, and that is called as replication. That is called as replication, and our DNA replicates in a semi-conservative manner. Semi-conservative manner. Clear to all of you? Central dogma is clear. Central dogma is clear. So transcription, translation. Transcription, translation. This is your central dogma. This is going to rule our entire molecular biology. This is exactly how everything happens in our body as well. Okay, perfect. Now we will start with the Griffith's experiment. So Griffith's experiment, students, I will just tell you the general things, like general things, what you're supposed to learn in this most importantly. So Griffith was working on a bacteria. What was that called? Streptococcus pneumoniae. From the word itself, you understand many things. What is the many things that you understand? First of all, you understand coccus means spherical, right? Coccus means spherical. Okay, pneumonia means it is a pneumonia causing. Okay, it causes pneumonia. Okay, pneumonia causing bacteria. Two things you have understood from the word itself, Streptococcus pneumoniae. Now, when he was working on this, he did not just use one strain. He used multiple strain. Okay, he used multiple strain. So, Streptococcus pneumoniae, students, he used two strains. Okay, two strains. One was, okay, one was a rough strain, one was a smooth strain. What did he use? One was the rough strain or the R strain, and one was the S strain or the smooth strain. Understood? R, rough. I have to sit down and write. Okay, 1 second. S was smooth. And it is known that the smooth strain, okay, the smooth strain is because of the presence of, okay, the smooth strain is because of the presence of the mucopolysaccharide. Okay, mucopolysaccharide. Done? Yes? Understood? Oh yeah, we didn't do euchromatin and heterochromatin, no? So sorry students, forgot. Okay, here only we'll do. Euchromatin and heterochromatin, we'll draw one chromosome. Okay, yes. So here what is going to happen? Euchromatin is the loosely packed one, and heterochromatin is darkly stained. Okay, so here only you can see that this is loosely packed. Okay, euchromatin, U is loose. Okay, loosely packed. Students, I told you whenever something is loosely packed, it will be lightly stained. And these people are transcriptionally active. Understood? Euchromatin. U is loose. Euchromatin. So remember like that. Okay. When I was in college also, I used to remember, okay, I am loose. Euchromatin. Euchromatin is loose. So I used to look at my friend also and tell this, and it used to be very funny, but we used to never forget in any of the exam, because the moment that question used to come, we used to look at each other and we used to be like, you, okay, yes, and we have never got caught, okay, because of doing that action. Yes, now again students, here it is densely packed, okay, and loosely packed, okay. So here what is going to happen? Here we have heterochromatin. The densely packed portion is going to be called the heterochromatin. Okay, heterochromatin. Opposite of this you write here. What is loosely packed means? Densely packed. Densely packed. Densely packed means darkly stained. Okay, darkly stained. And here it is active means here it is transcriptionally inactive. Okay, inactive. Understood? Understood? No comments on that. Students, it's just a way to remember, okay? Just a way to remember. I'm not calling any of you anything. Okay, I just told you can call your friend and remember that. Okay? Yes? Got it? Correct? Okay. Now, moving forward here, okay? So, students, the smooth strain, that is the S strain, is smooth because of a presence of a mucopolysaccharide, or you can just write a polysaccharide. So, they say that this polysaccharide or this mucopolysaccharide could be the reason why the smooth strain is virulent. So, virulent means what, student? The one that can cause a disease. Okay, virulent means the one that can cause a disease. This fellow is power, non-virulent. Okay, non-virulent. Non-virulent. Now, what happened exactly is, if I am using S strain, what is going to happen? You all tell me. If I am using S strain, ma'am, what a question, ma'am. You told that S strain is virulent, so obviously the mice is going to die. If I inject, the mice will die. If I use the R strain, ma'am, you only told the R strain is pavam, so obviously the mice is going to live. Okay. Then Griffith, no, everyone has to think out of the box. So he thought, let me do an experiment. Let me heat kill the S strain and see what could happen. And for his shock, as he expected, what happened? The mice was alive. Okay, the mice lived. Then he was thinking, let me take both of the process. Okay. No, they will not undergo. They're transcriptionally inactive. Okay, they're transcriptionally inactive. Okay. Now students, look here. Now students, oh, 27. Wow, nice. We are very close to the target. S strain, R strain, understood. Heat killed S strain. The mice live. Then Griffith thought, okay, let me do one thing. This fellow also made the mice alive. This fellow also made the mice alive. So I will mix these two combinations and I will make one more combination, that is heat killed S strain plus R strain and see what is going to happen. Students, if you were Griffith, what would you expect? If you were Griffith, what would you expect? Tell me. If you were Griffith, what would you expect? Ma'am, if I was Griffith, I would expect that since I took two results which were allowing the mice to live, that means transformation or whatever did not happen, I would expect that the mice would live. But unfortunately, students, here the result came ulta. The mice died. Then Griffith was like, oh my god, what just happened? And then he thought, okay, let me do one thing. I understood that something from the heat killed S strain went to the R strain, because of which the R strain became virulent. He does not know what it is, so he took a good move. He called it the transforming principle. He called it the transforming principle. Understood? He called it the transforming principle. Done? Right? Okay? Okay. Now, this transforming principle, definitely students, the entire segment did not stop there. Many people, okay, many people came to, that understanding that, okay, there is something that has got transformed. So, we should actually find more about it. We should actually find more about it, right? Right? Okay. Okay, yes. Okay. Now look here students, rough strain, non-virulent, mice lives, virulent, mice dies. Smooth strain, again heat kills smooth strain, the mice lives. He combined these two, the mice did not live. So this was the combination that everyone was thinking of working on. Everyone was thinking that okay, we should actually work on this. Okay, we should actually work on this. And then what happened, students? They called it the transforming principle, and the transforming principle was researched by many other people to understand what was the thing that got transferred from the S strain to the R strain that made R strain virulent. Understood? Yes or no? Okay. Now, coming to the next topic, that is Avery, MacLeod and McCarthy's experiment. Anyone has any doubt? Live will end when you come at the end. Okay, you join at the end of the session, that time the live will end. Don't take tension. Done? No, only heat killed S strain plus R strain. Okay, yes. Okay, this is one of the biggest chapters of your entire, if you say entire biology itself. Okay, entire biology's biggest chapter this is. Now, if you ask me when will it end? Okay, now Avery, MacLeod and McCarthy. Avery, MacLeod and McCarthy. Okay, yes. So Avery, MacLeod and McCarthy students, they did a biochemical nature. Biochemical nature. Biochemical nature of who? Of the transforming principle. See, everyone was after transforming principle. That okay, Griffith called this the transforming principle. We have a scope to find what is the transforming principle. So Avery, MacLeod and McCarthy came first, and they were like, you know what? Let's do a biochemical nature of your transforming principle. Understood? Yes or no? So then they started the experiment. But for the experiment to start, there should be some setup, no? There should be some setup, no? So they started with taking few enzymes. Okay, they took few enzymes. What were the enzymes, students? One that can degrade RNA, that is RNase enzyme. Okay, one that could degrade protein, so they took protease enzyme. One that could degrade DNA, they took DNase enzyme. So these were the three enzymes that they took, and they were thinking of starting the experiment. Now look here carefully, and you people should tell me the answer. You people should tell me the answer. Okay, I am not going to tell anything. I have taught you this recently also. Okay. Oh, what is this? No. Okay. Okay, wrong keyboard. Yeah. Students, here, these are the three circles. Okay, the experiment setup. Now, in all the three experiment setup, I am putting RNA orange color. Okay. Protein green color. I think it will become a national flag now. Okay. And DNA blue color. Got it? These three things I put. Now you tell me, how did the experiment go about? First, they were trying to find something. No, obviously they are trying to find the same thing. What is that? To find the biochemical nature. Who got transformed from S strain to R strain is what they are trying to find. Right? So here, first they used RNAs. First they used who? RNAs. RNAs would do what? Degrade the RNA. RNAs would do what? They would degrade the RNA. One second. Look here. They would degrade the RNA. So here, if I degrade the RNA, you tell me the mice will be alive or dead. All of you tell this. If you know one answer, you will be able to do the everything. Tell me this. If I degrade the RNA, from which combination? Students, this is one setup, plus they took the heat killed S strain plus R strain combination. These are the two experimental setups that they took. Clear? Now you tell me, if I remove the RNA, will the mice be alive? Think properly and tell me, if I remove the RNA, will the R strain become virulent or not? Come on. It's not that costly, yaar. What are you people telling? It's not that costly. It's just me drinking water. Because of the bottle, I'm drinking more water. If I don't see water, I will not drink. Think properly and tell me. I removed RNA. If you understand this one thing, rest is easier for me. If I remove RNA, still something will get transformed, no? Still something will get transformed from S strain to the R strain, making the R strain virulent. Because RNase is not the one who is getting transferred. So if I degrade the RNA, how is it going to matter? How is it going to matter? Exactly. So, exactly what? Yes, exactly. Very good. DNA is the one who is getting transformed. DNA is the transforming principle. So, if I remove RNA, it is still not going to make any problem, right? So, here also students understand that the mice is going to die because DNA is still going to get transformed, or I would say in other words, no transformation. No transformation. Okay, yes. Now here what is going to happen? So first they rejected, okay, RNA is not the genetic material, they understood. Then they went to next fellow. Who is the next fellow? Protein. So they went to protein Baba and they told we will add protease. He told we will add protease. Here also they noticed. What did they notice, students? Here also the mice died. That means still some fellow is getting transferred from the S strain to the R strain. So here also no transformation. No transformation. Then last step. What is the last step? This fellow also got cancelled out. So 1, 2, last step we took DNase. DNase will do what, students? It will obviously degrade the DNA. But here the mice will live. The mice lives because there is nothing to, make it virulent. So here students, they tell that transformation happened. Proving, or let's say they came to a conclusion that DNA is the genetic material. So after this, hence proved DNA is the genetic material. Understood? This is what Avery, MacLeod and McCarthy's experiment was. But this experiment did not have clarity. There were so many things that was missing in the experiment that many people were like, no, we should maybe go to another experiment to understand it, and that is when Hershey and Chase experiment came. Okay, Hershey and Chase experiment came. Hershey and Chase experiment also, they took some equipments. Let's learn about the equipments first. First they took bacteriophage. The bacteriophage or phage. So from the terminology you understand bacteria is there. Okay, we usually use the word phage also, for virus. So a virus that infects bacteria. Okay, so bacteriophage, bacteriophage is something that is virus that infects bacteria. Understood? Virus that infects bacteria. Clear to all of you? Yes or no? Okay, yes or no? Now, second thing they took was E. coli cell. Okay, they took E. coli. Why? Obviously we need someone to affect it. Okay, so for infection we took E. coli. Then two main things that they took was okay, they took 2 Petri plates which had radioactive substances. What was the radioactive substance? In one it was P32. Okay, doesn't look nice. Okay, I'll just write it outside. In one it was P32. In another one it was S35. P32, why ma'am? Because phosphate, this is only present in DNA. That means phosphate P is only present in DNA. It's not present in protein. So ultimately, if I get a result, I will be able to confirm if it is DNA or protein, right? If I asked you to do 2 jobs, I want proper differentiation of the questions and solutions. What will you do? You'll properly segregate the solutions and the problems, right? That means you'll make a separate PDF so there's no confusion. or you label it, right? You label it. You label the PDF as question PDF. You label the PDF as solution PDF. That is called labeling. So in this experiments, if we have to label them to understand, what do? We do radioactivity. Okay, so to radioactively label your DNA, we took P32. These are radioactive. Now here, students, we understood that it's only present in protein. Only present in protein. Understood? Understood. So these both are radioactive labels so that we can understand the labeling. Now let's go into the steps. So is this clear to all of you? Now what are we going to do with the bacteriophage? In this bacteriophage, you can see that the DNA is radioactively labeled. Here you can see the protein is radioactively labeled, because the entire bacteriophage, the virus, the genetic material is going to be inside. Outside there is going to be a protein coat. Okay, the genetic material is going to be inside, outside there is a protein coat, and depending on P32 and the protein and DNA, labeling is going to happen. Okay, thus understood? Yeah, confused only. Now, students, the first step that is going to happen is infection. Infection means with the help of bacteriophage, we are infecting the cell. Now, you know that whenever a virus is infecting, what will they do first? What will they do first? They will release their genetic material. They will release their genetic material into the cell. Right? We know this from HIV. We have studied it so many times. They'll release their genetic material. Same thing happened here also. Can you see? Now the genetic material is both inside the cell. After the genetic material is inside, that is after infection, we do a process called as blending, where we remove the protein coat. And then at the last, we do centrifugation, students, just to understand where are we getting the P32 and S35. Where are we getting the P32 and S35? So look here. No radioactivity detected in the cell, because we know protein is not the one who is going to enter into the cell. It is the genetic material. Genetic material is going to be DNA. So where are you going to get the S35? It is going to be seen in the supernatant. Okay. Now here what is going to happen, students? Obviously the radioactivity entered into the cell, because DNA it is, and here no radioactivity detected. So here we can conclude that DNA is the genetic material, and this is an unequal proof that DNA is the genetic material. It is a 2023 PYQ. It is a 2023 PYQ. Naturally, they have the protein code. They do not have radioactivity. That's why with the help of P32 and S35, we are making them radioactively labeled. Labeling we are doing, okay? So this is normally how your bacteriophage, you have studied it in, biological classification. Like the tail fibers will be there. So this is the protein code. Inside the protein code, the genetic material is going to be there. Okay, genetic material is going to be there. Now, radioactive labeling means we are labeling it so we know. Okay, we understand. Now, students, what is supernatant and pillet? If this is your centrifugation tube, okay, there will be something that is attached, okay, heavier, that will be attached to the bottom of the tube. Okay, bottom of the tube. And there will be something that is floating, lightweight, something that is lightweight. That is called as the supernatant. This is called as the supernatant. Okay, and this is called the pillet. This heavier part is called the pillet. So in the supernatant, we noticed that there was S35, that means there was protein, and here we noticed that it was P32. Understood all of you? Simple experiment, yes or no? Okay, that is how a Hershey and Chase proved that DNA is the genetic material. Now coming to the properties of a genetic material. Now let's take an example. I am telling Chaitra, tomorrow you have to stand as the MLA of this area. Now Chaitra will be like, ma'am, can I seriously become the MLA? I'll be like, yeah, you kind of have the qualification to become or you follow all the criteria to become an MLA. Now she'll be like, okay, fine, ma'am, tell me the criteria. So I give her a certain criteria, and Chaitra is tick for everything. So I will make her the MLA, right? I will make her as the candidate for the MLA, and then depending on the election, she'll become the MLA. Now, if there is a characteristic, so there should be a property to become the genetic material for majority of the organism, then there should be a criteria. There should be some properties that are solid for this genetic material, right? So here also you will see that the properties that the DNA has. Yes, understood? Okay, now look here. Yes, very good, very good. Okay, look here. Students, chemically and structurally stable. Do you want your DNA to be chemically and structurally stable? Do you want that something happens and then suddenly, you know, the DNA itself will be no more stable? Extreme heat is there. Okay, extreme heat is there, extreme cold is there, DNA gets manipulated. You do not want a genetic material who will get manipulated because of a change in the environmental condition, or let's say some reason burn happened. Immediately genetic material will get changed. We do not want that kind of a genetic material. We want a genetic material that whatever happens, we will be able to find the DNA. Like with the help of DNA, we will be able to identify a person. Now also murder happens, we will be easily able to identify a person. So here students, what happened? Chemically and structurally stable because of the absence of O. In the second carbon, the DNA has taken up a tick mark. Okay, DNA has taken up a tick mark. You people are not supposed to torture her, okay? She's not become the MLA. She's just stood as a candidate. Understood? She's just stood as a candidate. She has to win again. You people have to make her win. Okay? Chalo. Now, students, other than that, the presence of thymine. The presence of thymine in DNA is also one of the reasons for them to be really stable. So, DNA got 1 tick, RNA lost 1 point. Okay? How many of you are with RNA? How many of you are with DNA? Quickly tell me in the chat box. Anyone who is with RNA? Anyone who is with DNA? Yes, quickly tell me. Yes, very good. Now, mutation students, mutation has to be at slower rate. Today you want to sleep as a human and tomorrow you want to wake up as a penguin. No, we want mutation to be very slow. In DNA, the mutation is slow, but in RNA, the mutation is faster. Okay, replicates itself. Both of them will replicate itself, expressed by the Mendelian characters. Both of them will express itself also. Okay, so here what is going to happen? Here, oh yeah, we have DNA and RNA batch, no? Correct. Okay. So students, because of this, because of all ticks, just like Chaitra, I gave criteria and everything was a tick. Here also DNA, everything is a tick. So because of that, DNA is going to become the genetic material. Clear to all of you? Yes. Now one MCQ question. Okay, one MCQ question. Ready? Let's put some fire emojis in the chat box. Come on, we need some energy. Okay, we need some energy. I don't know why you people have less energy. I should be the one who is talking continuously. I should have less energy. No, but you people have less energy. Okay, chalo. Now students, RNA world. Okay, even though RNA is not a genetic material for many organisms, okay, is not a genetic, okay, not a genetic material for all organisms or majority organisms, still it does other jobs. What job? It acts as an adapter, like your tRNA. It acts as a catalyst. Okay, it acts as a messenger. So this kind of jobs are taken up by your RNA. Even though, very good, even though they are not the genetic material for all the organisms, they still are capable of doing other jobs like catalyst, messenger, adapter, right? So it's important. Now students, one very important PYQ. You would have seen it at least 1 or 2 times in your mock paper also. It's a PYQ. It can become an MCQ. Okay, now there's a trick to remember this. Just like how you remember MTR masala. Okay, you are going to remember RMT. After you write RMT, just write 1, 2 and 3. Okay, just do this. Now what does this mean, ma'am? Understand that RNA polymerase 1. Okay, so just write here RNA polymerase. RNA polymerase 1 will transcribe. Okay, transcribe for which one? rRNA. So RNA polymerase 1 will transcribe for rRNA. RNA polymerase 2 will transcribe for mRNA, snRNA and miRNA. Okay, next one, RNA 3 will transcribe for tRNA, small RNA, some snRNAs and miRNAs. But this is very important, because from this only you will be able to identify the match the following. From this story, you will be able to identify the match the following. Understood? So RMT 1, 2, 3. RMT 1, 2, 3. Repeat after me. Repeat after me, all of you. Quickly. Repeat, 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 repeat. Yes. Okay. Repeat after me. MTR. Yes. MTR Vedantu Masala. Now, not like that. This is RMT Vedantu Masala. Okay. RMT Masalas. Okay. I am only selling. RMT Masala. Okay. Yes. So, RMT 1, 2, 3. Now, students, coming to a very important topic. Now, I want next 5-10 minutes, no more talking. Take your pen, take a piece of paper which you can stick to your NCRT or take sticky notes, write whatever I am telling. Write whatever I am telling. Replication is one of the most important concepts because replication will lay the foundation for many other concepts further. Okay? Yes or no? Clear all of you? Yes or no? Clear all of you? Ready? Okay. Okay. Now, morning also this sir spoke about biryani. Now he is talking about food. Sir's only job is to make other people hungry. Okay? Right? Other people hungry. I'm hungry now. No more food conversation in the chat box. Okay? Anyone talks about food, they'll be removed, including some teachers. Okay, let's start, students. Okay, 2 minutes. All of you go take pen, paper, everything and come. Ready, steady, go. Ready, steady, go. Ready with pen, paper. Once ready, put a thumbs up. I'm waiting for you people to take pen, paper and come. Pen, paper and come. Okay, fine. Okay, fine. Yes. Okay, should we remove sir, students? Should we remove sir? Okay, now replication. Replication means what? I told you DNA has the ability to self-replicate, right? It can make its own copies and that is called as replication. Now, I told you one more thing, that DNA can replicate in a semi-conservative manner. Now, how do you understand semi-conservative manner? I have always given an example. This is the parent, this is the daughter, right? This is the parent. Let's do one thing. Let's draw it like this. Parent, okay, daughter. Now, I have to separate these two strands, right? I have to separate these two strands. Now, students, what is exactly happening is that if a DNA has to replicate in a semi-conservative manner, what is the terminology meaning? The terminology is simple. I take one parent strand. That parent strand acts as a template and I get a daughter strand. I took a parent strand, I got a daughter strand. Simple. You want to take a Xerox. Okay, you want to take a Xerox. This is a pen. Okay, this is the pen. Now, this pen, let's assume this as the template. This is the actual Xerox copy that I have. Now, if you want to make a copy out of it, what will you do? You'll take the Xerox copy, make a copy. Now, I want to make a new strand. What will I do? I already have my parent strand. I will utilize one parent strand to make another new strand. Same thing goes with the second one, right? Second one. Now, let's just assume these two, okay, these two, this is the parent strand, parent strand. These two are together. Okay, these two are together. I cannot bound around it. So, these two are together. Now, I am telling that I want to do replication. I want to make new templates. So, what will I do? I will separate these strands. I will separate these strands. This strand can give me one daughter DNA. This strand can give me one daughter DNA. Obviously, after they make the daughter DNA, their purpose is over. So, what they will do? They'll again come back together. But here the twist comes. In our DNA, instead of coming back together, just give me a minute. Okay. Yes. So, students, I have 4 pens in my hand. Okay. Now, which are the parents? Let's do one thing. Let's keep parents very simple. Did I lose that pen? Okay, I lost that. Okay, never mind. Okay, students. So, these two are the parent, the gray and the pink. These two are the parent. Okay. So, parent I am using for what? To make my new template strands. Okay, to make my new template strand. So, this pink fellow gave me a purple strand. This pink fellow gave me a purple strand. So, this is daughter plus daughter plus parent. Okay, this gray fellow gave me a green strand. This gray fellow gave me a green strand. Now these 4 strands are there. What do I expect? I expect that the parents go back together and the daughters go back together like this. But what happened? What happened? Parent and daughter combined together, and this is exactly called as semi-conservative manner. Did you understand? Did you understand? All of you understood or not? Which is the parent among this? Tell me the colors of the parent. Tell me the colors of the parent. Quickly in the chats. Come on, faster. Faster. So I took a parent strand. This is my parent strand. I took my parent strand. I got a daughter strand. But instead of the parents going back together, what happened? The parent and daughter came together, and this gives me a hybrid strand. This gives me a hybrid strand. This is called as semi-conservative. Yes, semi-conservative. Ma'am, once again. Okay, let's take some. Okay, some more visible colors. Okay, more visible colors. Okay, now these colors are visible. Okay, let's do one thing, students. Let's make the parent also a little different. Okay, yeah, fine. Okay, gray and pink. Okay, see now look here. Parents are different pens. Okay, daughters are similar pens. Okay, daughters are similar pens. Now what happened? These two are the parents. These two are the parents. My actual copies that I have. These 2 parents I can use to get new 2 strands, right? They are complementary. I separated them. Now I can get new strands. So normally what will happen? I take this, I get a strand. I take this, I get a strand. That is what happened here also. The gray gave me an orange color strand. Can you see the orange color? The gray gave me an orange color strand. Remember the colors. And this fellow gave me a green color strand. Now after the formation, I expected that just like any other form, these 2 will go back together. The parents will go back together, and the daughters will come back together. But what happened, students? Twist happened. The twist is that parent and daughter strands, they became like this. They became like this. Clear to all of you? Clear to all of you? They became like this instead of going back. So if they would have gone back, it is called as conservative. Since they did not go back, this becomes a hybrid, right? One parent, one daughter. One parent, one daughter. This is a hybrid, right? So I got a hybrid strand, okay, and that is called as a semi-conservative method. That's called a semi-conservative. Semi-conservative. Conservative means what? Parents would have helped, right? Let's assume this is the parent strand. I would have separated the parent strand. I got one strand. Okay, I got another strand. This strand would have helped me form the daughters. Yes, they helped me form the daughter strands. After that, what would have happened? After that, the parents went back together. Parents went back together. The daughters went back together. This is called as conservative. This is called as conservative. But in our DNA, what is happening? Semi-conservative is happening. That's all. That's all. Nothing to get confused. Is it clear to all of you? Yes or no? Tell me quickly in the chats. Our DNA is like this. Colorful our DNA is little. Okay, this fellow is different. Okay. Yes, clear? This is called as semi-conservation. Okay, semi-conservative. Okay, semi-conservative. Now, we are going to come to the major portion of the chapter. Okay, major portion of the thing. Okay, major portion of the thing. That is your Michelson and Stahl experiment. Before going to Michelson and Stahl experiment, first I'll explain you and then we will come here. Okay, we'll come here. So, students, Michelson and Stahl experiment main goal was to prove that our DNA is semi-conservative or not. So, what did they do? First they took, so here, please make a note here in your diagram itself, write it down that they are not radioactive. Many people teach it wrong, they are not radioactive. Understood? This NH4 and N15 are not radioactive, okay? They are just chosen on their density gradient. Who has the higher density and the lower density? That's it. They are chosen on the density gradient. Understood? The higher isotope and the lower isotope is taken. Clear? So, not radioactive but based on the density. So, first we took N15 DNA. If you remember this as parent also, it's okay. Just keep it in your mind. After 20 minutes, we have taken E. coli. Why? Because E. coli replicates every 20 minutes. So, we have taken E. coli. After 20 minutes, I noticed that I got a hybrid strand. Okay, how did I get a hybrid strand, students? First of all, understand, After dipping it in N15 DNA, okay, after dipping it in N15, that is the whole thing is N15 H4Cl. After that we take it up, okay, and we dip it in N14 H4Cl, okay. Then I noticed that I got hybrid. I got hybrid because my DNA replicates in a semi-conservative manner. So I got 100% hybrid after 20 minutes. I got 100% hybrid after 20 minutes. After 40 minutes, I'm seeing I got 2 light DNA and 2 hybrid DNA. That means I got a ratio of 50% light and 50% hybrid. Clear? Clear? Now, to make this more clear for all of you, let's take it here. Let's take 2 bright colors itself. Okay, so students, first I dipped it in NH15 NH4Cl. Okay, that time whom did I dip? I dipped the E. coli. Okay, because E. coli replicates in every 20 minutes. Every 20 minutes. Every 20 minutes. Understood? Every 20 minutes. Now, I'm going to dip this, okay. After this, I'm going to take it and dip it in NH14 H4Cl. Okay. Again, I'm taking my E. coli, dipping it here. Now, you tell me what will I get? What will I get? I'm supposed to get a hybrid, right, after 20 minutes. So, after 20 minutes, when I noticed, I saw that both, okay, let's say 2 bright colors, I saw that I got 2 hybrids. I saw that, students, if I put pink and which color it will be visible? Blue I'll put a, is it visible? Yeah, I got 2 hybrids. It's very important to know this, questions come a lot from this topic. Okay, I got 100% hybrid after 20 minutes. Then I did not stop in 20 minutes. I went further. After 20, I went for 40 minutes. In 40 minutes, what did I notice? I noticed that I got, again, 2 hybrids I got. But not only 2 hybrids I got, I also got light. I got the light strands. Why? Because it is still dipped in NH4. From there, the parent, no, after this new one only will exist longer. So, it will, I got the light. So, here what am I getting? I am getting 50% hybrid. Okay, 50% hybrid. That is this and this. Okay, and I am getting 50% light. Clear to all of you? 50% light. Understood? This is also light. Done? Easy? Simple? Now, the question is, in second generation, what is the percent of hybrid? So, this is the first generation. You get 100% hybrid. This is the second generation. How much did you get? You got 50% hybrid, 50% light. This is how your questions are going to come. Clear? Yes or no? Is this clear? Thank you so much, Madhumati. This is clear? Now, students, I am not stopping it here also. I am going for a 60 minutes. And you tell me in 60 minutes, how am I going to get? If you are finding it difficult to find 60 minutes, what you can do is, you separate all the strands. What are you saying, ma'am? See, 2 strands of blue are there. So, 1, 2. Again here 1, 3. Okay. One pink is going to come here. 4. One more pink is going to come here. Yes. Okay. Again blue is coming. Yes, ma'am. Blue is coming. Okay. Again 2 more blues are there. So, I am writing it here. 2 more blues. So, to all of this you put the blue. Because light is going to be more. Because we are still dipped it in NH14. Okay. Okay, continue. See this? Understood? See this? So, here you tell me 1, 2, 3, 4, 5, 6. Out of 8, 6 of them are light, 2 of them are hybrid. That means what is going to be the percentage? That means you are going to get 75% light and 25% hybrid. Correct? Correct? Yes or no? Is this clear to all of you? Is this clear to all of you? Okay. Is this clear to all of you? Yes. Then the next one will be what, students? It will be somewhere around, 87.5% light. Okay, just do the calculation, and around 12.5% hybrid. Like this, it will go to your 100 minutes. Okay, 100 minutes. So if you have doubt, just separate the strand and do it. Okay, perfect. Understood Messelson and Stahl's experiment. Now, to make sure that the density gradient, is, perfect, or to make the differentiation proper, they have used cesium chloride gradient. So students, this is an entire experiment based on the density gradient, not on radioactivity. When you study, you think that, okay, this is also radioactive because in Hershey and Chase you studied it. But these are not radioactive, these are density gradients. These are density gradients. Done, done, done. Done, done, done. Any doubts? Any doubts? So this happened in 1958. Okay, 1958. Okay, this is what Messelson and Stahl's experiments calculations are. Now going into replication. Okay, going into replication, more clear. Okay, more clear. There are so many things that you have to study. There are so many things that you have to study. Listen to me carefully. Okay, listen to me carefully. Now, when you study this topic, students, there are so many places that you can get confused. Okay, so to avoid any kind of confusion, let's go slowly. Let's go slowly. Okay, first we will understand that replication is semi-conservative. Yes, you understood that. Now we want to understand exactly how replication happens, right? How am I making the strands separated? How am I utilizing the strands to make my daughter DNAs or the new template, right? So here in replication, let's first understand how it happens in prokaryotes and how it happens in eukaryotes. I know all of you might be exhausted because you're sitting from morning, but hats off to all of you who are sitting here, because students, please understand, I always say this example. Okay, I always say this example. You might be thinking that you are the biggest warrior here because you're sitting for a 6 hours marathon or a 5 hours marathon. But just think of students who are preparing in Kota and other offline centers who are sitting 13 hours, 14 hours continuously without even taking bath, without even, looking into the social media. They're sitting there and studying. And when you want to fight with them on May 4th, you should be a capable warrior. You might be thinking that you're a warrior. But when you compare with the outside world, students, in our territory, we will always feel like the king and queen. But when do you actually know the reality? When you go and compete with others, right? So when you are sitting here and thinking that, my God, I've sat for 6 hours of marathon, I'm the biggest warrior. No. Think that there is another person who's sitting past 12 hours in a marathon or 12 hours in an offline class, sitting continuously. At least understand, offline and online, we try to interact with you. Okay, in offline, all these things don't happen. They teach continuously. Information will be given. You have the choice to leave the class. You have the choice to keep your phone and go take coffee, drink everything. Those students don't have those privileges, but they're sitting and doing it because their aim is to study in that 5 years with the 6K, 7K names. So please don't consider yourself a warrior until you fight or come to the real battle. That is when you are a real warrior. Please understand, okay? You have to be competing with them and you should be prepared for that. Fine? Okay? Understood? Yes. Okay. Now students, prokaryotes and eukaryotes. When I'm trying to make you understand about prokaryotes and eukaryotes, let me just first take the DNA. Okay, in prokaryote students, all of you know your DNA is circular like this, right? Okay, circular like this. Now, how do I select this? Okay, so in this students, in this there is, for replication to happen, you need an ORI site. What do you need? One ORI site. So in prokaryote, since it is a circular DNA like this, there will be only one ORI site, that is one origin of replication. One origin of replication. Okay, this you remember and keep. Then the second most thing is students, these people, the replication will happen in the cytoplasm. Replication will happen in the cytoplasm. Okay. Now, what is possible here in eukaryotes? What happens? Let's take a similar example here. You take your entire 2.2 meter DNA. In this 2.2 meter DNA, students, is it necessary that every portion we are going to take? No. We should understand that small segments, okay, small segments of the DNAs are going to undergo replication. Okay, like this, small portions we are going to take for replication. Now you should remember that whichever segment we are taking, that segment we will have an ORI. So in eukaryotes, what I am trying to make you understand is there are many ORI sites. Many ORI sites. Because here we can't do it like this. Right, we can't do it like this. This is long stranded DNA, so we can take only segments, and in that segments ORI will be there. In that segments ORI will be there. Correct? Okay. See, exactly. See what Madhumita is telling. As an offline student, I know about the competition is so hard to compete with other students, but I'm perfectly doing, ma'am, because of the RNA classes that happened prior. Okay, thank you so much, ma'am, for the support and hard work. Okay, clear, right? So this ORI, many ORI sites will be present, and students, this process is going to happen. At where is it going to happen? It is going to happen in the nucleus, but in which phase is going to happen? The phase is going to be the S phase, right? S. Okay, phase is going to be S. G1, G2, S and all of that you have studied, no? So S phase it is going to happen. This is given in your NCRT. So remember this, PYQ can come. So this is your general understanding of what is going to happen in what is going to happen in eukaryotes. Clear to all of you? Clear to all of you? So students, when this each segments, we can call it as replicon. We can call it as replicon. Okay? Each segments. Now keeping this each segments, let's just take. So let's say I am telling you that wherever the thing is going to open, that is going to be your ORI site. Okay, that is going to be your ORI site, because where origin of replication is there only your replication is going to start. Right. So here you remember this one thing. When we draw the replication diagram, okay, we usually draw it like this, no? We draw like this. But how did it reach to this situation? You should know. How did it reach to this situation? You should know, right? So for that, understand, if I take those segments, okay, if I take that segment, this is one segment. I told you that this is the ORI site. Now students, from the ORI site, the opening will happen. So something like this, okay, something like this you will see in most of the textbook. These diagrams are there, like when you study in masters and all, like this it will open. Okay, like this it will open. So in this, what we are going to do? We are going to take it as this one portion like this. So that is how you get the Y shape. Okay, that is how you get the Y shape like this. Understood? Understood how you landed here? Because you will have doubt, ma'am, like that, how did it become like this? We are taking one segment of it. We draw it like this so that it is easier to understand. But otherwise, how it will be, students? Like this we can draw, like this we can draw, like this we can draw. Like this, okay? And this portion is exactly called your replication fork. Clear? Replication. 10 minutes, let's assume 10 minutes. I'm going to teach you the entire replication. I'm going to teach you the entire replication machinery. That means which are the enzymes that is going to help. How am I going to separate the parent strands? Now, when I'm starting this, I want all of you to remember this one picture in your head. What is the picture that you have to remember? Just now we did meson and star experiment. Just remember that this is the parent strand. The blue color one is the parent strand. Okay, the pink color one is the daughter strand. Okay, and we know since our DNA is semi-conservative, we got something like this. Okay, we got something like this. Can you remember this till the end? Can you remember this till the end? Yes, ma'am, we will remember this. That is the thing that you will remember. Now, to make this, I have to separate this. For that separation only, I am going to start the process. So, as I told you students, this is how your DNA, because many replication folks are there, we are taking segment by segment. So, this is how your DNA will be there. Okay. Now, from that, I am taking one replication fork segment, that is, I am taking this kind of a segment and I am opening it and showing to all of you. Okay. So, here, what is going to happen? Like this. Okay. Replication fork that you studied like this. Okay. You go like this and like this. Understood? This is your replication fork. Now, for me to do this from this, I needed one person who would unzip this, right? I would need someone who would unzip this, correct? So, here if I go here, let me just bring it a little more closer for all of you so that I can, draw the, yes. So, students, to unzip this people, I needed some enzyme which was called the helicase. Okay, I needed some enzyme. I am just drawing part by part. Otherwise, what will happen? I will not be able to, I will not be able to, oh, it does not feel like that. Huh? Oh, yeah, it feels. Okay, like this. Okay, I got the helicase. Helicase is called the unwinding enzyme. What is helicase called? The unwinding enzyme. I will just write it helicase here because a lot of things will come here. First, let's label it 5 dash, 3 dash, 5 dash, 3 dash. Done? Okay, helicase. Now, what am I going to write about helicase? I will write helicase is unwinding enzyme. Unwinding enzyme. Unwinding means I have to separate the strand. I have to unzip. Exactly. I have to unzip. I have to separate the strand. Now, students, it is going to act like a sieve. It is going to act like a sieve. Now, this is the pouch. Let's just assume this is your strand. Now, what am I going to do? I am going to unzip this, right? The strands are together. Now, as I unzip, can you see it's opening? Can you see it's opening? So, as it opens, you will notice that the shape is also coming, the Y shape. So, here it is. As I am opening, I will need helicase to keep moving, right? First, helicase was here. So, after that, I want the helicase to move further. As it moves, it is going above and it is going to unzip the entire strand. Now, I will get this entity separate, correct? So, keeping this in mind, you understand that your helicase is going to continuously unzip. Are you all understanding? As you are understanding, please put thumbs up. Now, this is clear. First enzyme that you have studied is helicase. Now, students, here, the main person who has to form the new template, is going to be DNA dependent, which is mentioned in your NCRT, DNA dependent DNA polymerase. DNA dependent DNA polymerase. Understood? DNA dependent DNA polymerase. But there is one problem. This DNA dependent DNA polymerase only works or does polymerization, as mentioned in your NCRT, it does polymerization in this direction. Polymerization in 5' to 3' direction. 5' to 3' direction. But there is one more problem. DNA polymerase does not know where to start. Why it does not know where to start? Because of the absence of the OH group. I told you there that we need that OH group to continue the formation. That is going to be absent here. So, for that very own reason, we are going to take the help of one person. Whose help are we going to take, students? Whose help are we going to take? Come on, tell me whose help are we going to take? All of you know the answer. Faster. We are going to take the help of who? Who? We are going to take the help of a primer. We are going to take a help of a primer. So, the primer will come and attach here. Okay, the primer will come and attach here. The primer is going to be an RNA material. The primer is going to be what? An RNA material. Ma'am, why have you taken an RNA primer? Okay, primase enzyme is going to add the primer. The primer is going to be RNA. Because if I take DNA, students, it is going to combine with this template. That means it is going to be wrong. So, I can only take an RNA which can be separated faster. Right, I need to take someone who can be differentiated. Now imagine I send all the NEET students into one room and I tell that if I send 10 standard students, all of you will understand the 10 standard students? Yes. If I send one more NEET student inside to do a spy work on you people, the NEET students also will start clubbing up with you. Right. So if I take a DNA primer, DNA will continue in this template formation. I do not want that. So I will take an RNA primer. Right. RNA primer, and that RNA primer, since it is 3' here it is going to be 5', right, and this portion is going to be 3'. So here the DNA will aram se do polymerization because it polymerizes from 5' to 3'. It will continue with the help of primase. And what a primer is? It's an RNA. It's an RNA. I wanted to mention this before I used to not mention this. Yeah, it's working now. Okay, so students, what I was trying to say is, since DNA will do polymerization in 5' to 3' direction. So when you add a primer, it should be from 5' to 3', right? So 3' against I added 5' and 3'. So the polymerization will continue aram se in this way. Lag is over, no? It will continue like this. Now you tell me here, since my DNA is going to do polymerization in 5' to 3', can I add here 5' primer? I cannot, because 5' and 5' is not possible. It's just 2 seconds lag. It looks. Internet issue undo? No. Okay. Now fine, right? I think there's a slight internet issue, students. Now it's fine? Yeah, okay. I'll continue. Wherever you feel like it's lagging, just tell me. Okay? It came now? Yeah. Okay, now it's fine. Okay, chalo. Now students, what has happened here? Once again, I'm repeating. Primer we added. The primer is an RNA material. Why? Because in a crowd of NEET students, I'm telling one student that you have to be a spy. You have to tell me that if these people are studying or not. Okay, I've put you in one room. Now, what will happen? What will happen? Okay, what will happen is that, if I am taking a group of NEET students and I'm sending a NEET student itself inside, the NEET student will automatically start, talking to each other, and he will become a part of that. So I don't want that to happen. So that is why I am going to use an RNA primer here, so that this clubbing will not happen. Is this clear? Is this clear? Still there is lag? So I don't want that to happen. So that is why I am going to use it. Fine, no, now? What is the issue? What is the issue? So that this clubbing will not happen. Is this clear? Is this clear? Still there is lag? Just let me know, it's fine? Okay. Okay, fine. So this primer is going to be an RNA. Okay, one second, students. Okay, 1 minute. One important concept I am teaching, the internet cannot be proper. Okay. I wanted to call him only. Just 1 minute. Just give me a minute. 1 second. Is it better now? Yes, students, they are checking. Okay, they're checking the internet. Just give me 2-3 minutes. Okay. I've become a national problem in the office. Okay, every 5 minutes I call them. All the nazar, go away. Okay, such an important topic, students. I don't want lag to come. Okay, lag to happen. Is it better now? Is it better now? Yeah, right? Internet is fine, no?
I'm sitting here.
Okay.
I'll see.
Yes. I did again streaming once again. Okay. Yeah. There's some problem. Okay. Students, every day something will happen in the office, students.
Internet is not there. There is no lag.
Okay, fine. I'm starting from the start. Okay.
Starting from again.
Yeah. So the machinery and the enzyme. That means how does the DNA, both of the strands separate? Because I told you the parent strands have to separate for us to form the new daughter strands. How does this happen? First, when I am separating the strands, students, obviously there should be an ORI site. That no one has a doubt, no? ORI should be there. Origin of replication should be there. And I told you how it happens in prokaryotes. At each segment there will be an ORI, and from there this opening will happen. So that is why this kind of opening happens, and then you get a replication fork. Now for that unzipping to happen, we have an unbinding enzyme or a helicase enzyme. Helicase enzyme. Okay. Now that helicase enzyme came and it started unzipping. Okay. It started unzipping. Fine. Okay, yes. So unzipping happened. It is continuous. Both the strands are separating. Both the strands are separating. Now, the main person who is going to help us in the formation of the template is going to be DNA dependent DNA polymerase. DNA dependent DNA polymerase. Now, this DNA dependent DNA polymerase has one problem. It will only do polymerization from 5' to 3' direction. So, what we have to do? We have to add a primer. So 3' means I can add 5'. So I added a primer. The primer is an RNA molecule. Ma'am, why did you use an RNA molecule? The RNA molecule I use, students, because the RNA molecule will not affect my formation of the new template. But if I use a DNA primer, it will combine. Okay, it will combine. Yes. Fine, perfect. There's no problem, right? Okay. Now, students, I added an RNA primer, okay, with the help of primase, and here the continuation happened. So, this becomes a continuous strand. This becomes a continuous strand. This becomes a continuous strand. Yes, ma'am. Now, what about this situation? What about this situation? Here what I can do, students, I want to add a primer here because this fellow will only do from 5' to 3'. So if I try to add a primer here, this has to be 5'. I cannot do that because 5', not possible. So I thought, okay, fine. Primer was like, let's do one thing, let's fool this fellow. Let's start adding from the back side. So when I'm adding from the back side, here the problem is that, students, formation is happening. Yes, ma'am, formation is happening. But as the formation is happening, every then and now I should add a primer because there is no free 3' end to continue. So here again, continuation is happening, continuation is happening. So this will form fragments. This will form fragments. Is this clear to all of you? Fragments formation will happen. Done, done, done. Yes or no? Any doubts? Fragment formation will happen. And this, since they are fragments, we call this as a discontinuous or a lagging strand. A discontinuous or a lagging strand, and these each fragments are called as Okazaki fragments. Okazaki fragments. Now after the purpose of the primer, okay, after the purpose of the primer, DNA polymerase will be like, hey, I don't want primer and all, you remove the primer, I know to do my job. So the DNA polymerase will remove the primer, like it will help in the removal of the primer and it will add the new nucleotides. But still, we need to make sure that the joining is happening. So for that joining to happen, we will bring one more person, students. The person is none other than your ligase, who is going to do the gluing. Understood? Gluing will happen because of DNA ligase. Done? Yes. Now, there is one problem. Since these two strands were complementary, they have an attachment issue. Because of which these people will try to come back together. So for that, I am going to use another protein which is called, SSBP. Okay, SSBP single. One second, students. Use this color. Yes. Can you see here? Single stranded binding protein, which is going to make sure that these people don't come back together. So this is SSBP protein. Okay, single stranded binding protein. So that these two strands don't come back together because they were complementary. They will have the tendency to come back. Yes, ma'am, they will have a tendency to come back, right? Okay, yes. So this two strands shouldn't come back. So SSBP it is. SSBP. Now here, students, one more fellow is there. He is like, I will make sure that these two couples don't come back together. So for that, there is one more protein which is called the topoisomerase. What is it called? Topoisomerase. Topoisomerase will do the job of avoiding supercoiling. Topoisomerase will prevent supercoiling. Understood? Yes or no? Is this clear to all of you? Any confusion is there? In the primer? Any confusion is there in the direction? Isomerase is there, which will prevent the supercoiling. DNA dependent DNA polymerase is there, which is going to do the formation of the new nucleotide or the template. Okay, and then we have everything we have done. Discontinuous, continuous, lagging strand, leading strand, all of that. Clear? Now here, students, here what is happening? This diagram. So a connection is showing excellent. No, what is the issue? Is it still the same? Okay. So what I was telling, I just told you, I just asked you people if the concept is clear. I just asked you people if the concept is clear. Okay. Concept is clear, no? Concept is clear, no? So here, all the enzymes you have to remember. Helicase, SSBP, topoisomerase, and your gluing enzyme, DNA ligase. Okay, DNA ligase. Only if an ORI is there, we will be able to continue the origin of replication. Here we are adding the primer, here also we are adding multiple primers, because here it is in the opposite direction. Okay. I think when I say that only. Okay, when I say that only, that happens. Okay. Now, moving forward, this is the diagram. Just look at the diagram. You will notice that 5' to 3' is a continuous strand. Okay. This end from here to here, this 5' to this 5' is coming like this. So, remember that DNA polymerase always polymerizes from 5' to 3'. Always it will polymerize from 5' to 3'. Understood? Yes or no? 5' to 3' polymerization will continue. 5' to 3' polymerization will continue. Got it? So, same thing will happen here, template strand and your discontinuous synthesis and all of that. Is this clear? Now students, one add on here very important is about your faba beans. Okay, so here you have to understand that Taylor et al. Taylor et al. Taylor et al. Means, now let's take an example, myself, Christina, Subra and your Geeta are writing a paper, but I am the main first author. So my name will come Gopika and all these three people's name will come as et al. That means Gopika and her colleagues, like that. Okay. So Taylor and his colleagues worked on faba beans, which with the help of radioactive thymidine. Okay, radioactive thymidine in 1958. When Michelson and Stahl experiment happened, no, similar time. Vishya faba. Okay, they used this beans with the help of radioactive thymidine to understand replication in eukaryotes. Okay, so look here, very similar experiment involving the use of radioactive thymidine to detect the distribution of the newly synthesized DNA in the chromosomes was performed by these people. The experiment proved that the DNA in chromosomes also replicate in semi-conservative manner. Understood? This word is very, very important. Radioactive thymidine. Radioactive thymidine. Now students, here one more thing that I want to add on here is the energy form. The energy form. The energy form here, we can say energy plus it acts as a substrate. Okay, it acts as a substrate. So we can say the energy form plus a substrate used here is given in your NCRT is DNTP. DNTP. Okay, deoxynucleoside triphosphate. So this triphosphate, I told you that the 2-phosphate breaking will yield so much energy to us. With the help of DNTP only, we will be able to do the entire unzipping as well. So this is an energy consuming, it's an expensive process. DNA replication is an expensive process. Why? Because we are using the energy form. Substrate means all of you know, enzyme substrate complex. Just now you studied in biomolecules. So the substrate will be utilized to get a product. The product is what? Chain formation. The product is what? The formation of the chain. Understood? So energy plus, so this DNTP has dual function, we can say. Okay, it has dual function. This is all mentioned in your NCRT. DNTP, energy form, expensive process, everything. Everything. Clear to all of you? Any doubts? Any doubts? Okay. So, just to take an overview, just to make an overview of the whole thing, just listen here. Replication, semi-conservative. Semi-conservative. Okay. Enzymes. Enzymes, you start with helicase, unzipping. Unzipping or unwinding. Okay. Then we have ligase, gluing. Okay, gluing. Then we have who? Topoisomerase. No, most important, DNA dependent. Okay. DNA dependent DNA polymerase. DNA dependent DNA polymerase. Why? To form the new template. To add the new nucleotide also I will write new nucleotide. To add the new nucleotide. Okay. Now next one. Fast. Tell fast. Topoisomerase. To prevent supercoiling. Okay, to prevent supercoiling. Then whom do we have? We have to prevent supercoiling. Then we have SSBP to make sure that do not anneal. Okay, anneal means come back together. Done. Is this clear? Okay, where does this happen? The phase is S phase. Phase is S phase. Okay, in eukaryotes it happens in the nucleus. They have many ORIs. Okay, each segment is called a replicon. This is the whole thing. Okay, fine. Done. We will go to transcription. So students, transcription, we will start from here and then we will come back to the slide. Okay, transcription students. Okay, no, I think I will do this first because you people will not understand this one. Okay, so students, in transcription, what you have to understand is what is happening. mRNA to protein. mRNA to protein is happening, right? Now mRNA to protein is called, DNA to mRNA. I'm so sorry, DNA to mRNA. This is called as transcription. Now in transcription, this student, there's one main thing that you have to remember. Out of both the DNA strands, we will be utilizing only one strand. Ma'am, why ma'am? We are utilizing only one strand, so we do not end up getting a double-stranded mRNA, double-stranded RNA. Okay, so that we do not get a double-stranded RNA. That is why. Okay, so here what is going to happen? You should remember that out of the both strands, let's say this is one strand, this is one strand. Okay, let me also write some combinations. A, G, T, A, T. Okay, and here also let me write. Okay, I think this should have been a little space. Okay, yes. A, T, A, G, A, T. Okay, what will be this for that? T, A, T, C, T, A. Now this is 5' to 3'. This is 3' to 5'. These are the two strands. Okay, these are the two strands. Now these two strands, students, if I take both the strands, I am going to get an RNA. What will I get? A, T, A, A, T, no, A, U. A, U, A, G, A, U. This is the first strand. Okay, I just made the RNA of it. Okay, second strand also, what will A bind with? U. U bind with A. Again U, C, U, A. Correct? This is what I am going to get. Same thing, T, A, T, C, T, A. U, A, U, C, U, A. Now, if this both combine, it is going to ultimately give me dsRNA, and this dsRNA cannot be translated. Okay, cannot be transcribed. Okay. So then what is the point? What is the point of doing this? There is no point of doing this. So this is the reason why I will not be using both the DNA strands. Instead, I will be using only one strand, and the strand that I am going to use is going to be called the template strand. The strand that will make copies, okay, the strand that will make copies is called the template strand, and the strand that is not going to be helping is the coding strand. The coding strand. Understood? The strand that will help me in making the copies is called the template strand. Done. Is this clear to all of you? So that is the reason. So main thing that you have to remember is we only use one strand for our transcription, and that strand is going to be called the template strand. Now students, one more thing that you have to remember is the coding strand sequence. Okay, the coding strand sequence is going to be exactly similar. Coding strand sequence is going to be exactly similar to the newly formed RNA, just that thymine will be replaced by uracil. Thymine will be replaced by uracil. Okay? Yes? Okay? So if they are asking you mRNA, see now you know the coding, no, at Gopika ma'am's class. So continue that only. That coding only you have to use. Okay, students, this is clear. Template strand, copies, coding strand, this is clear. Okay, now the next most important thing is we have unit. So again, as I told you, this is your entire DNA. We will not be utilizing the entire DNA. We will have segments of the DNA. We will have segments of the DNA which is going to do the transcription. This is one segment. This is one segment. Now in this segment, it is very important for us to keep the limits. Okay, limits. That means we should have the proper setup, no? So this, each of them is called as your transcriptional unit. Transcriptional unit. Now students, one transcription unit, starting part they will have a promoter, okay, and the ending part they will have a terminator. And in the middle there will be a structural gene region. Clear to all of you? In the middle there will be a structural gene region. So this is the two strands, okay, this is the two strands. In this two strands, this two, there will be promoter region, there will be terminator region, and this portion will be the structural gene. Understood? Understood? This I have taught you before also. Okay? Yes, okay. Now, look at this diagram to make you understand one PYQ question. They will ask you, where is the promoter region present? You should say that the promoter region is present in the phi dash end of the coding strand. Where is it present? Phi dash end of the coding strand. Okay, and that region, this region will be called the upstream. Okay, this is called the upstream and this is called the downstream. Okay, this will be called the downstream. So students, in these two strands, the promoter will be attached where? Like this. So on the coding strand, phi dash end of the coding strand. So this portion will be the upstream, this portion will be the downstream. Are you all understanding? Are you all understanding? You have studied this many times before now. Okay, so that strand that we are going to use is called the template strand, and the strand that is going to be exactly having the same sequence as mRNA is going to be called the coding strand. Okay, so promoter, terminator. Promoter region starts, initiation start, structural gene region elongation happens, and terminator region termination happens. Okay, yes. Okay, now look here, promoter, okay, promoter, here in the promoter, what is going to happen? Initiation is going to happen. From the term itself you understand. Now students, RNA polymerase, as I told you before also, recently also I told you in the most important concept, why are we using DNA dependent RNA polymerase? Because we are working on a DNA, right, to form an mRNA. So we are going to use a DNA dependent RNA polymerase. In the promoter region, this RNA polymerase will combine with sigma factor to start the initiation. The first process is going to be initiation. Okay. Second, what is going to happen? Elongation. RNA polymerase will form the newly formed mRNA. Okay. Then as it move forward, at the terminator, what is going to happen? RNA polymerase will combine with Rho factor to terminate the reaction. Clear to all of you? So elongation and termination. This is what happens in your transcription. So main things that you have to remember in your transcription is why we are using only one strand, why we are not using both the strands, what is coding strand, where is promoter present in the coding strand, where is terminator present in the coding strand. Can you remember all of this? phi dash, okay, usually they ask the promoter. It is present in the phi dash end of the coding strand, that is on the upstream. That is on the upstream. So here students, two main things that you have studied is sigma factor and rho factor. Sigma factor and the rho factor. Sigma is going to start. Okay, sigma male, you know, no, they will only start everything. Oh, I am this, I am that, and all. So sigma, like that you remember. Sigma plus RNA polymerase, initiation starts. Okay, then RNA polymerase knows to do only one thing, to form the mRNA. So it will form the mRNA. Then as it moves forward, as it moves further, what is going to happen? It will combine with the rho factor and it will terminate. Okay, it will terminate. Now, coming to the next topic, which is a part of your transcription itself. Okay, now students, when I was teaching you the structural gene region, I wanted to tell you people one more thing, that let's consider prokaryotes. Okay, let's consider prokaryotes. This is a prokaryotic gene. Imagine just one line I am drawing, so not to make it too complicated. Okay, in prokaryotes, you will notice that there are multiple structural gene regions. Multiple structural gene regions. And because of that, what will happen, students? These people will also be able to form many proteins. Okay, so we call a small section of the gene, we can say, as a cistron, So in prokaryotes, we call it polycistronic. Understood? Prokaryotes are polycistronic. That means one gene, okay, one gene will be able to make multiple, will be able to code for multiple proteins without any problem, without any complication. But we cannot do that. Okay, understood? So in our gene, let's say one structural gene region is there. Okay, we can, according to our central dogma, one strand of DNA ultimately forms one mRNA that ultimately forms one protein. So this ours will only allow us to make one protein. So this is monocistronic gene. Understood? Monocistronic gene. Clear to all of you? Thank you, Akhtar. Okay, monocistronic gene. Now this monocistronic gene is present in the eukaryote. So you remember like this: P for pro, P for poly. P for pro, P for poly. Now students, we have one more problem. We have only problems, okay? In eukaryotes, our gene formation is in the form of a split gene. It's in the form of a split gene. Now ma'am, what is split gene? One intron, okay, one coding sequence, one non-coding sequence, one coding sequence, one non-coding sequence. In life also it is like that. Some nonsense people, some useful people. Some nonsense people, some useful people. Right? In our life also, everyone cannot be useful for us. Okay? So, we want whom? We want only the person who is going to be useful for us. Correct? Same thing even the gene also wants. Gene wants only the fellow who is going to help with the coding later. Who is going to sequence. So, exons are the one who is going to code and introns are the one who will not. They are the non-coding sequence. So they will be like, I don't want introns, I only want exons. So then we will be like, okay, don't worry, we have something called as RNA processing. Because of RNA processing, we will be ultimately be able to give you only the sequence, or only the gene which has sequence. So that is here. This is called as RNA processing. Clear to all of you? Any doubts? Any doubts here? Please let me know. If you have any doubts. Students, one more thing I wanted to add here is, what is the exact phase? Okay, what is the exact phase at where all this transcription will happen? It is at G1 and G2 phase. Okay, G1 and G2 phase. Okay, mainly it will happen in G1 and G2 phase. Okay, we are basically copying the information. Now, going here. Okay, here what is going to happen? We got the gene, but you saw how the gene came out. It came as a split gene. Now, do you need split gene? No ma'am, I don't need split gene. So, you will go through a process which is called as splicing, where your introns will be removed. Okay, introns will be removed and exons will be added. Introns removed, exons will be joined together. Okay, exons will be joined together. Clear? Now, once we do the splicing, students, we have to do something called as capping and tailing. Capping and tailing means is to make the both the ends proper, at the same time like a covering, so that no cutting, chopping, or this mRNA is not affected. Okay, so for that we do something called as capping. Okay, capping, and we do capping with the help of methyl guanosine triphosphate. Methyl guanosine triphosphate. Methyl guanosine triphosphate. Okay, this methyl guanosine triphosphate, do you understand? Again, energy from these people are triphosphate. Whenever it comes, they give us energy. Then poly A tail, students, basically adenylation. Okay, poly A tail. With this, we will be able to do tailing. Okay, so polyadenylation. We will add the A. Clear? Understood? Now, what are we going to do with this mRNA? We are going to send this mRNA to the cytoplasm. For translation to happen. Done. Yes, all of you. Okay. Any doubts so far? Just check in, let me know if we missed something. Okay, if we missed something. After that, we can go for genetic code. Friends, is the board cut by any chance? You people should have told me, no? Zoomed out. 1 second. See, now it's proper. Should have told me, no, long ago. Now I'm seeing that the board has got cut. Wait 1 second. Yeah. Perfect. Okay. Yes. Break you people need. If I give you break now, then how will you attend Shreyas's class? Okay, we have again so many concepts now. Okay. Yes. Okay. So those who want break, just go take something. Okay, I'll also take a 5 minutes break after we finish genetic code. Okay, students, genetic code, did we miss something? Or everything we understood? Tell me quickly. Chapter is long, students, we can't do anything. Okay, yes, genetic code. So genetic code is basically we got our mRNA. On the mRNA, there is going to be something, okay, who is going to be like in a triplet form. But before we go into that, we have to understand there was a person called George Gamow. Okay, George Gamow. This George Gamow was the person who told that, wait, if you people are telling that for 20 amino acids you need codes. For how much? 20 amino acids you need code. Then we will try different permutations and combinations. That is, he knew that there were 4 nitrogenous bases. Right, there were 4 nitrogenous bases. He thought, okay, with the 4 nitrogenous base, let's make the first combination 4:1. That means 1 nitrogenous base coding for 1 amino acid. We only got 4 combinations, and he was like, no, there's something wrong with that. Okay, something wrong with that. Then he was like, okay, let's do one thing. Let's combine these two. Let's combine these two. Let's combine these two. Let's combine these two. Something like that. So permutation combinations. Okay, 4 to the power 2. He noticed he got 4 into 4. That was 16. But how many amino acids we had? 20 amino acids. Still we are less on 4. Then the last option was, let's do one thing, let's do 4 to the power 3, and that is when we got 64. And even though that time it was a lot of number, but now we understand that out of 64, 61 are coding for proteins, are codons, okay, and 3 are stop codons, or we can call termination codons. Okay, termination. These 3 are stop codons and 61s are coding. Understood? Now, 2 important things that you have to learn with this is that, students, see, Hargobind Khurana synthesizes homopolymers. Homopolymers means like this, U, A, okay, like this, U, like that, homopolymers, okay, homopolymers and copolymers. This is copolymers, again, homopolymers like this, okay. He was able to synthesize these people, that is again synthesize, that means everything was done at lab. Then Marshall Nirenberg developed cell-free, very important, students, cell-free system for protein synthesis. That is like, he's like, don't need cell only, we can do directly protein synthesis. So one person found homopolymers, okay, synthesized. Another person did a cell-free system for making proteins. This way, lot of complications can be reduced. Okay, now, ma'am, do I have to study the entire box? You don't have to study the entire box. What you have to study, you just have to understand that how these combinations came. You people know Punnett square, no? 2, 2 we will do. Here what is happening? First position, second position, third position. Okay, so UUC, UUA, UUG. So, see, I got that. Okay, understood? Understood. So, here what is happening with 3 positions? We are able to do the ultimate genetic codes. Okay, genetic codes. In this, students, where do we have the stop codons? We have UAA, UAG and UGA. Okay, UAA. So, I told you, remember like this, UAA. Okay, you replace the last letter, UAG. Okay, then you replace, you mix this two, UGA. So, first you replace this letter with this fellow, then you swap these 2 people. This is how you get your 3 stop codons. This is how you get your 3 stop codons. Clear? Clear? Okay. Now the salient features. First salient feature, I told you that out of the 61 codons, okay, for amino acids, 3 are stop codons. Okay, that we understood. Out of 64, 61 codes, 3 are stop and all the codons are triplet. Okay, all the codons are triplet. Some amino acids, important, some amino acids are coded by more than 1 codon. If you look here also, students, you look at phenylalanine, UUC also is coding, okay. And if you go like this, search, see, serine, UCU, UCC, UCA, UCG, right. So, what is happening here? What is happening here? Here, one code, some amino acids are coded by more than 1 codon. And this property is called as degeneracy or degenerate. Okay, the codon is read in mRNA in a continuous fashion, contiguous fashion, continuous fashion. Okay, continuous fashion. There are no punctuations. All of you know that there are no punctuations. Yes, ma'am, there is no punctuations. Okay, Severo-Oho enzyme, you have to study it here. Okay, after this Hargobind, it is there. I think by mistake I removed it or did I add it somewhere else. Okay. The codon is read in mRNA in a continuous fashion. There is no punctuation. The code is universal. That means from bacteria to human, your UUU will code for phenylalanine. Understood? Some exceptions are there in mitochondria, but otherwise, most of them there is no exceptions. Okay. AUG has dual function. That means AUG will code for methionine. At the same time, it is also a start codon or an initiator codon. That means it will be present in the starting of the mRNA telling that, hey, start the process. Then UAA, UAG, UGA are stop terminators. Understood? Understood? Is this clear? Salient features? Salient features are clear? Okay. This also all of you know. Right. What is this? This is addition. I added a B letter to this. Ram has red cap. Perfectly readable statement. Here, Ram has B I added. So, obviously, the entire tRNA and ribosome will read it in a triplet form. So, they will read this They will read this. This is gone. This will attach with the next one. Here what is going to happen? I added 2 letters. Still not readable. Still not readable. I added 3 letters. Simple. Ram has big red cap. Readable. So if you add a nucleotide, if you add or delete, you add or delete, you can say insert also. If you insert or delete a nucleotide, okay, a nucleotide or 2 nucleotides, the problem is there will be frame shift mutation. There will be frame shift mutation. Understood? Frame shift mutation. Mutation will happen. Okay. So this frame shift mutation shouldn't happen. For that, what we have to do, whenever we are inserting, we have to insert, if we insert a triplet, then mutation will not happen. Same thing goes here also. See, when I removed, okay, when I was trying to remove, first I removed 2 letters, didn't work out. Then I removed 3 letters, then it made sense. Ram has cap. Understood? So insertion inactivation will happen. By inserting, mutation will happen. By removing, frame shift mutation will happen. Understood? Clear, Pakka? Clear to all of you? Okay. Triplets are added. Okay. If triplets are added, you will not see any frame shift. Here are the example, students. You remember that in DNA fingerprinting also we study SNPs. Okay. Single nucleotide polymorphism. Here we have studied in your principles of inheritance also about your about your sickle cell anemia. Sickle cell anemia. It should have been glutamate. Okay. But it became what? Valine. It coded for valine. Why? Because this U got changed. Because this U got changed. Okay? This U got changed and that ended up forming valine. So this led to the formation of sickle cell anemia. This led to the formation of, all of you answer, sickle cell anemia. So even a single nucleotide changes, that can lead to mutation. Understood? Understood all of you? Yes or no? Okay. Now students, let's see what happens in 1 hour. Let's try to finish as much as possible. In case something gets left out, we will see what can be done. Okay. So now we will take a small break and come back. Okay, we will take a small break and come back, and after that we will start with translation. I will try to finish up to Lacopron. Okay, try to finish up to Lacopron. There are some PYQs given. You can solve the PYQs later once I share the notes. Okay. Yes, point mutation. Very good. So here you will get all the notes. Okay, biology by Gopika. Okay, chalo, we'll take a kuti break and come back because sir's class is there at 6. Okay, we will try to finish as much as possible, and if something is left, we will definitely, there are a lot of videos on the channel. If something is left, so make sure that you watch those videos. Okay, instead of complaining, you should watch those videos, because without break Other hello? Yes, am I audible? Yes, let's see how much we can finish because 6 o'clock sir's class is there and sir have JE exam. So we cannot change the class slot at any cost. So we will try. In case HGP and DNA fingerprinting is not possible, don't worry, I'll share you the video where I have done a separate video on that. That is a 2 hours video. You can check that out and understand, or you can also watch it from Bio Club. Fine. Okay, let's for time being do translation. So what is translation, students? We already formed the mRNA and we send that mRNA to the cytoplasm. Now that mRNA in the cytoplasm will become protein. For that to happen, we do translation. Why do we call the word translation? Because we are translating something, right? On the mRNA, you have the genetic code and the genetic code are triplet, right? Genetic code is triplet and this genetic code is going to be used to form our polypeptide chain. That is why we call it translation. When you don't understand a language, you use a translator to translate, right? But students, for this translation to happen, mRNA to protein, that process is not enough. We need some additional people like your adapter molecule, which is your tRNA, which is a clover leaf model. Clover leaf model. Clover leaf is that lucky symbol leaf you put. When you people put the word lucky, in your phone, they will show one leaf model. That is your clover leaf model and it looks like an inverted L. And it looks like an inverted L. Okay, clear to all of you, 2D and 3D. Now, other than tRNA, we need one more person, that is your ribosomes. Ribosomes. Now students, ribosomes, 2 units are there. Larger subunit and smaller subunit. Now both of them have to come for the tRNA to do this entire your translation to happen. But here the catch is, if your smaller RNA comes only, translation will start. Question has come, PYQ has come, that only if the smaller RNA unit, okay, smaller ribosome unit comes and joins only, the entire process will start. Okay, your translation will start. So here, if you look here, the first step of translation is called as charging of tRNA. Why do we charge something? Now, why did I give you a break? So that you can come back energetically. So, charging of tRNA, or else in other words, amino acylation. Amino acylation. Students, this charging of tRNA is very important. Why? Because if 2 tRNAs are charged, then it is easy to form a polypeptide, that is, it is easy to form a peptide bond. It is easy to form a peptide bond. Now, one motivated friend and another motivated friend. These 2 motivated friends, if they sit together, both will get motivated. If both are demotivated, both will get demotivated. Both the tRNAs, if they are charged, it is easy to form a peptide bond between them. Understood? Easy to form a peptide bond between them. Now, if you look at this diagram, one of the most important diagrams, you will understand that your ribosome has some sites. These sites are called exit site. Exit, okay, I'll write it here. Exit site. The middle portion is called the peptidyl site. Peptidyl site. And the one that is coming, okay, who is going to accept, that is called the acceptor site. Ma'am, why are you saying this? Students, because in this diagram, if you see clearly, you will understand that one person is already waiting there to come and make the polypeptide bond, and another person is attaching this and planning to exit. One person has already exited. So that means in the acceptor site, the tRNA, you know the tRNA has what? tRNA has what? It has an anticodon loop that will form anticodon to whatever is there in the mRNA. See, A, G, U. A will code with U, G will code with C. So it has made anticodon for it. So the tRNA has an anticodon loop and it has an amino acid acceptor site. Amino acid acceptor site. Correct? It has 2 things. One side it will read, one side it will attach. So for this to work, we need the ribosome as well. On the ribosome, there are 3 sites. E, P, A site. Simple, imagine when you're entering into a bus. Okay, you stand in there, you get into the bus, so you have got accepted. So with that, what you have? You have an anticodon loop and you have an amino acid. So you have already made the anticodon and the amino acid. Like you have already made your bag ready to stand inside the bus. You have already taken the money to take the ticket. Now you are looking at one seat. That is your peptidyl seat. That seat, the moment one person gets up, you will immediately go and sit there. So now you are here near the peptidyl seat. Now here what will happen? When you are sitting on the seat, someone in the bus will give you a bag. Same way here, students, when you are sitting in the peptidyl site, this person who has made the entire polypeptide chain, the before tRNA, will give you the polypeptide chain, telling that since you are in the peptidyl site, you continue the chain. You continue the chain. Clear? Clear? So you continue the chain, and then what will happen? Your stop will come. Okay, the before person took the bag and left. So what will happen? Your stop will come, you will exit. So same thing like this. You enter, you look at a seat, you sit on the seat, you get the chain, after that you leave. The chain will continue to form. For the chain formation, charging is very important, because when two charged tRNAs come together, the peptide bond formation is faster. Okay, so charging of tRNA or amino acylation, that means with amino acid we are giving ATP. This is an energy process. So amino acid will give energy and we'll tell, hey bro, you continue the formation. This is how we will form the entire polypeptide chain. Is this clear to all of you? Is this clear to all of you? We will form the entire polypeptide chain. Perfect? Perfect, no doubts? Fine. So two charged tRNAs, if they come together, we will get the peptide bond. Now students, one thing you have to understand, your tRNAs are specific. Okay? Specific. If you look here also, you will understand. One fellow has come with histone, another fellow has come with valine, another fellow is waiting with another amino acid. So these people are all specific. Same way, there is one more tRNA which is called the initiator tRNA. Okay, it is called the initiator tRNA, which will start the process. Initiation will happen. Clear to all of you? Yes or no? Understood? Any doubts? Any doubts? Any doubts about what is happening in your tRNA? Any doubts about what is happening in your tRNA? Now, two more very important things of your translation is that this is your mRNA. Okay. In this, students, here you have your start codon AUG. Here you have your stop codon UAG. Okay. Now, there is something called as UTR, untranslated region. These UTRs are going to be present before the start codon, okay, and after the stop codon. This is to increase the efficiency of translation. And students, this is also to terminate, because stop codon comes, we'll understand. With that, we also have release factor. Which is going to help us in termination. Okay, and the ribosome ultimately will help us to give the protein polypeptide chain. Clear to all of you? Any doubts? So both the tRNAs will be charged, and those two tRNAs, when they come together, they will form the peptide bond. Translation is clear? Translation is clear? Now we will go into gene regulation. Gene regulation means there are two types of gene, students: housekeeping gene or constitutive gene, luxury gene or non-constitutive gene. Now just imagine in your home there is a servant. Okay, so let's not call them like that. Let's call them a housekeeper. Okay, there's a housekeeper or a maid, housemaid. That maid will do job 24/7. 24/7 she'll be doing a job. But then at the same time there is a luxury maid. She'll be like, no, I will only come 1 hour in the morning and 1 hour in the evening. Rest of the time you cannot call me, I will not come. That is luxury. That means whenever the gene decides to switch off or switch on, they can do it at their own mercy, like their own wish. But on the other side, there is a gene which will work 24/7 who cannot switch off. Those are called as housekeeping genes. So housekeeping gene or constitutive gene always switched on. Okay, the genes which are responsible for glycolysis and all that. Luxury genes, the genes can regulate itself. Understood? Now, in eukaryotes, students, there are 4 places where the gene can decide to switch off or switch on. First is during transcription. That is when DNA becomes mRNA. Second is during RNA processing, between splicing, capping, tailing, when that process is happening. Second is when we transfer the mRNA from the nucleus to the cytoplasm for translation. Fourth is obviously translation. But ma'am, in prokaryotes, what's the situation? In prokaryotes, students, since transcription and translation is a coupled process, you only get to do switching on and switching off at only one place. So depending on this, there is something called as operon models. which was found by Jacob and Monod. The one that you're going to study is your Lac-Operon model. Okay, clear to all of you? Clear to all of you? Where what is happening? Yes or no? Yes or no? So now we are going to study Lac-Operon model. Now we are going to study, students, I have added some PYQs, you please solve it after the class, immediately after the class, okay. Now let's learn Lac-Operon model. Now students, when you learn Lac-Operon model, this is the diagram with which you will learn. I have taught Lac-Operon multiple times on the channel, so by now I know 99% students know it. See students, those who haven't liked the video and subscribed to the channel, do that. Okay, we are doing all this for you people. Right, molecular basis I have taught so many times, still I am teaching. Okay, so look here, Pipo ZYA. How will you remember? Pipo ZYA. So students, your I gene will form repressor mRNA. That repressor mRNA will form repressor protein. But this repressor protein has a problem. This fellow will go and sit with the operator. This fellow will go and sit with the operator. And since this fellow goes and sits with the operator, what is going to happen, students? This is going to make a problem. What problem? Because we are studying in prokaryotes, okay. RNA polymerase will be coming, he wants to do transcription, he will come, he will notice that there is a block, he will go back. So here transcription will not happen, okay, no transcription. So no transcription means no formation of mRNA. No transcription, no mRNA. Understood? So here we can say that the gene got switched off. Gene got switched off. Understood? Why did the gene get switched off? Because transcription did not happen. Why? Because the repressor went and bound with the operator. Repressor went and bound with the operator. Clear to all of you? Clear to all of you? Okay? Good job. Now, students, you should understand, before I go further, you should understand the Z, Y, A are actually structural genes. What are they? Structural genes. They will listen to this fellow, who? Your I gene. Okay, these people are regulatory genes. These people will regulate when these people should be active. Okay, they will regulate. So here in the second scenario, what happened? First, the gene was switched off. Second scenario, we found lactose. Lactose is going to act as the inducer. And it is going to bind with the repressor and not let the repressor go and bind with the operator. So because of that, here transcription will happen. Why? Because RNA polymerase who is coming, he will happily go forward and make the lac mRNA. Lac mRNA. Now what is the job of these structural genes? The Z gene will release beta galactosidase, which will break down galactose to glucose and lactose to galactose and glucose. Okay, and permease will do the job of increasing the permeability of the E. coli to absorb more lactose. Okay, now trans-acetylase function is unknown according to your NCERT. Then students, after this what will happen? Translation will happen. Okay, so in prokaryotes, I gene will form repressor mRNA, that repressor mRNA will form repressor. Repressor will go and bind with the operator and stop transcription from happening, leading to the gene being switched off. Second scenario, lactose will be present. Then you will be like, ma'am, how? Understand, Lac-Operon model is a leaky model and lactose has entered the system somehow before. So because of that, the lactose will act as an inducer, go and bind with the repressor and not let the repressor go and bind with the operator. This way, RNA polymerase who is coming to do transcription will happily do transcription and move further to make the lac mRNA, continue to form the protein, and in this the structural gene will release beta galactosidase, permease and trans-acetylase. Is this clear to all of you? Yes or no? Understood? Any doubt in this? Any doubt in this? Perfect. Jacob and Monod gave the Lac-Operon model. This is not the only model. We also have valine models. Okay, other models are there depending on what. Now here lactose is present. So lactose was controlling the switching on and switching off. Okay, so here automatically the gene gene will switch on in the presence of lactose. So simply you can say in the absence of lactose the gene is switch off, in the presence of lactose the gene is switch on. Okay. Now students, HGP, the aim of HGP, see in HGP very less topics to explain. Most of the topics is something that you have to learn. Okay, most of the topic is when you have to learn. Okay. So aim is what? To sequence the whole genome with 3 billion base pairs, creating a physical map of human genome, to identify all the disease causing genes, and to understand the function of genes, to make the informations available for all the researchers, and to develop tools for processing and analyzing data. Even though we have 3.3, even though we keep talking about this 3.3, imagine each of them have to carry a book containing all the gene information. It would be 3,300 books, right? Each book having 1000 pages. And obviously making of this book would cost us so much. That is when people thought, why don't we do something called as bioinformatics, that is use information like biology plus computers and do a process where we have all the information of all the genes, so that we can use it for medical purpose, we can use it for research purpose, and we can also understand what is going wrong. If a mutation has happened, what is going wrong? Clear? Yes? Students, are you all understanding? So this HGP process costed around 9 billion. 9 billion. This is full, what is the full form? Human Genome Project. Okay? Human Genome Project. Understood? Yes or no? Okay, now, students, moving forward here, understand some of the important points, okay, of HGP is that to identify approximately 20 to 25,000 genes, to determine the sequence of 3 billion chemical base pairs, store this information in a database, and improve the tools for data analysis. Transfer related technologies to other sectors such as industries, medical industries, everything. Here question can come about the full form. LC, ethical, legal, social issues. Ethical, legal, social issues. Clear to all of you? Yes or no? Yes or no? Clear? Any doubts? Any doubts? Okay, chalo. Now students, two main things that you have to study, like other than the by-hearting part, is HGP had two approaches. First approach was a blind approach. The blind approach means, students, they did not bother that which was the sequence or which was the non-sequence. They just took the whole genome. They just took the whole genome and they did the sequencing. This was a blind approach where you took the whole genome, that means exons plus introns, both you are taking. But do you understand that which will ultimately form the protein? It's only the exons. Then another one was expressed sequence tags. Expressed sequence tags. From the term itself you understand the only ones that were expressing themselves, right? The one genes that were expressing. So this was a more prominent approach. Understood all of you? Which were expressing itself, I only took those. I only took those and this is called as ESTs. ESTs. Clear? Clear? Yes or no? Okay. Now here, when you go to the whole thing, I'll just tell you what you have to, like most of you might be thinking that ma'am, I don't want to study this, I want to skip it. In case you're planning to skip also, there are some numbers that you have to remember. First of all, less than 2% of the genome codes for protein. First thing you should remember. Second thing, human gene being dystrophin. Okay, dystrophin as the largest known human gene. Largest known, okay, human gene. That is dystrophin at 2.4 million bases. These lines you have to study at any cost. Now students, chromosome 1 has 2968. Phone number like that you remember. 2968 and Y gene has the fewest 231. Both starts with 22. Chromosome 1 has most genes, Y has fewest genes. Second most important thing, about 1.4 million locations were single base DNA differences, that is called your SNPs. single nucleotide polymorphism. SNP, single nucleotide polymorphism. That means, students, what is happening between me and Madhumita? Let's take an example. AAG is there, okay, in my body. In her body, AGG is there. So this A has got replaced with G. But this is more than enough for us to have so many differences. Okay, so many differences. Maybe texture of the hair, maybe the eyelashes, whatever. One small change, okay, one small change in one nucleotide can cause a major difference from people to people. Now, every one of us have straight hair, but all of us have different silky hair, textured hair, no, like that only. Here, nucleotide, that is called as SNP, single nucleotide polymorphism. Single nucleotide polymorphism. Clear? Yes or no? So, I am just quickly, like, revising. Okay, quickly revising. Now, let's go to, so HGP is clear to all of you? Okay, 10 minutes I'll take DNA fingerprinting and then we will be done with the chapter. Okay, we'll be done with the chapter. Chalo. Now students, DNA fingerprinting means what? Now let's take an example. This is Mintu, okay. Mintu did a crime. Okay, Mintu did a crime. But Mintu escaped from there. So there were other peoples in the crime. Okay, there were other peoples in the crime. They were all like, just they were there. Now police have doubt on these three people. Police have doubt on these three people. Let's consider them as Bintu, okay, Chintu and Tintu. Okay, Tintu, Chintu and Bintu. They were three, Chumma there, but Mintu was the criminal. Mintu ran away. Now, how do I prove that Mintu is the criminal? For that, I should have some differences. So, understand, even though Chintu, Mintu, Bintu and Tintu has DNA, in that 99.9% of the DNA is the same in all these four peoples. Ma'am, what are you saying? Then how will we find that Mintu is the criminal? Right? How will we find Mintu is the criminal? All of you have the doubt. How will we find Mintu is the criminal? But students, that 0.1% is different. This is more than enough for me to find that Mintu is the criminal. So this same DNA, we call it as bulk DNA. Like you take, bulk sari, bulk everything means what? A bigger amount, bulk. This one can be called as satellite DNA. Satellite DNA. So, to understand Mintu is the criminal, this 0.1% or your 1% difference is enough. Okay, 1% difference is enough. Now, this satellite DNA can also be mentioned as repetitive DNA. Repetitive DNA. Clear to all of you? Yes or no? Okay, now, this repetitive DNA and satellite DNA are of two types. One is called VNTR probe. Okay, sorry, VNTR, and one is called as short tandem repeats, STR. One is VNTR, one is STR. Now, ma'am, what is this? Full form is variable number of tandem repeats. And this is short tandem repeats, okay? Short tandem repeats. Clear? Now, what are these people? Understand students, when we talk about short tandem repeats and your variable tandem repeats, there's two things that you have to remember. Mini satellite and micro satellite. Okay, one second. Yes, mini satellite and micro satellite. So students, VNTR probe, we say here mini satellite region. Now mini satellite and micro satellite regions, you can just remember it. If it is too difficult, you can just not break your head for it. Mini is bigger, micro is smaller. This much can you remember? Mini is bigger, micro is smaller. This will have 10 to 60 base pairs. This will have 1 to 6 base pairs. Ma'am, what are you saying? Students, what is the name? Variable number of tandem repeats. How many times one base pair is repeating? Now, in Chintu, Mintu, Bintu, Tintu also, there might be AGATTC repeating. But how many times? In Tintu, if it is repeating 50 times, in Mintu, it might be repeating 10,000 times. This is enough for me to find the difference. Yes or no? So repeats, 10 to 60 base pair repeats will happen. Understood? Yes or no? Clear to all of you? Okay. So that means the same sequence can repeat up to 100 times. Up to 100 times. Okay. Yes. One more small thing that you can remember is micro is smaller. No. So this is AT rich region. Mini is GC rich region. This is why I told you in the Chargaff rule that it is not necessary that these two people should be the same. Okay. Yes. Very good. Very good, dreams. Perfect. Understood? Yes or no? Yes or no? Now, if you go here to the example, you will all notice one thing, that there you can see paternal and maternal. Our paternal and maternal will be different, no students. In abroad and all, you would have seen that, you know, these people are going for cases, right? These people are going for cases where they say that, you know, this is my child, this is your child, but later after DNA test, they get to know this is not. Why? Because paternal and maternal is going to be different for all of us, right? So here you should understand that from a crime scene, if I got the blood sample, I got, this is the blood samples, okay? So individual A, individual B, and I got this from the scene, okay? Now paternal is there, maternal is there. You can see it's very different, paternal and maternal for B and C. Now if you go to the crime scene, this is what I got. Number of short tandem repeats I got 11, 7, okay, somewhere around 8, 5, something like that. When I notice and run it in a gel electrophoresis, I notice that my C and B is similar. Now to confirm this, what I will do? Let's take an example that SNTR, okay, STR is this sequence, okay, AGATTC. If this is the sequence that is repeating in this fellow, I will make a complementary strand for this. A will bind with T, G will bind with C, A will bind with T, T will bind with A, G. I made a complementary strand. This complementary strand will go and bind with this fellow, and I will be able to see it under an autoradiography. How, ma'am? This, students, this is called a probe. This is a VNTR probe, and I will radioactively label it. So I can see this under an autoradiography. Is this clear? This also I have taught you multiple times. Autoradiography. Clear to all of you? Yes or no? Clear? Understood? So, if you want to do a DNA fingerprinting, what are the things that you are going to do? Okay, we have like 4 more minutes. What are the things you are going to do, students? First, you have to isolate. So, now I have doubt on Mintu. Okay, I have doubt on Mintu. Mintu is the villain, right? Criminal. First, I will isolate the DNA of Mintu. Isolation of DNA. After I isolate the entire DNA with the help of restriction enzymes, I will cut the DNA. I will cut Mintu's DNA. After I cut Mintu's DNA, what will I do? I will run it on a gel electrophoresis. Why, ma'am? I want to see the fragments and I want to separate the DNA with the help of size. So, after I separate Mintu's DNA according to the size, I will transfer it to a nylon or a nitrocellulose membrane. Students, we call this as southern blotting. So like that, southern blotting, western blotting is there. So southern blotting, I will transfer it because I cannot keep it in gel electrophoresis for a long time. So I will transfer it. After I transfer it, what will happen? I will give a probe. Which is radioactively labeled, a VNTR probe, and I will tell. So this probe will go and attach to the fragments, right? It will go and attach to the fragments, and later I will check it in autoradiography. I will be able to see exactly the highlighted fragments. Like this, I will understand the criminal. Is this clear? Who made me find out this? It's because of the presence of those STRs. okay, because of those repeated tandem repeats, sorry, repeated sequences. Repeated sequences. Understood? Yes? Perfect. This is your DNA fingerprint. Okay? So sorry students, at the last I had to speed up a little, but I hope you understood everything. Now let me tell you students, crash course, last day to join. Okay, last day to join. This is the video that you are watching. First of all, like the video, all of you. Okay, lot of hard work and effort is there in this to make you people improve. Now students, in the first you have a form to fill. I have already told you, if you are in Bangalore, fill the form. Otherwise, click on the crash course. After this, you will not be able to join the crash course and you will also be left with a lot of syllabus. So it's better that you join now, and you can see the prices have not changed a lot. It is similar. Crash course means if your revision game is not going properly, this is the best thing that you can join, because there you will get proper scheduled classes. Okay, so if you want just the crash course, it's 1,999. If you want the crash course plus the QR, that is your flashcards, it's at 2,999, and here at 6,449 for doubt solving as well, plus all India test series. Okay, so if you are a student who is thinking of last minute revision plan, then this is the revision plan for you. Join the crash course quickly, because there will no more be, you will be able to enter. Okay, understood? Okay, who are the 7 kanjus who hasn't liked the video? Shame on you people. So students, we have completed molecular basis of inheritance and biomolecules. So I hope all of you enjoyed the session. As I told you, don't forget that you have today 1 day to join the crash course. Okay, so this is the video. We have taken a 7 hours marathon. It's a 7 hours marathon starting from 10 o'clock, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and it's almost going to be 6 o'clock in 10 minutes. That means it's almost an 8 hours marathon. Just biomolecules and molecular basis of inheritance, but that just word is not practical. Why? Because 60 marks you get from this entire 7 hours video. 60 marks in biology out of 360 is as valuable as gold. Okay, so students, thank you so much. Thank you so much. Quickly smash that like button and let's make it 500 likes soon, because the target was that. So all of you who stayed from the starting till this minute, I am so proud of you. Hats off to all of you. It is, see, our hard work is going to happen every single day, but when my students do it, I feel very proud, and thank you so much for joining. Without fail, do let me know in the comments if you were there from the starting to beginning, and if you are confident in these 2 chapters, as biomolecules is the foundation for molecular basis of inheritance, and we are doing 11th and 12th mix. Okay, tomorrow 1 more class is happening. Let's hope and pray that my voice will be there for tomorrow's class. So yes, tomorrow I will be doing structural organization. As you know, last class there was a technical error because of which I could not complete frog. So tomorrow the class will be little more shorter, students, because it's cell and structural organization. So yes, tomorrow both of us will be here, so you will be able to see together both of us in the same frame. So till then, thank you so much. I'm so happy that all of you stayed, and lots of love to all of you. Bye bye, take care, see you all. And Shreya's class is starting at 6 o'clock, so don't miss it. Physics is as important. Okay, yes, bye bye. Don't forget to comment. Okay, you should comment that you were there. Even if you're there for even one of the classes, also do comment and let us know how you felt it. I'm so sorry for increasing the speed at the end, but don't worry, there's a lot of lectures of mine, molecular basis. Any doubt, go back to watching any of the lectures. Okay, these notes will be shared on my Telegram channel, Biology by Gopika. If you want to follow me on Instagram, it's Gopika Biology, and do follow us on Vedantu NEET English Telegram channel, which has all the notes and all the important contents.